A very good morning to all. Assalamu alaikum. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. لإيلاف قريش إيلافهم رحلة الشتاء والصيف فليعبدوا رب هذا البيت الذي يطعمهم من جوع وآمنهم من خوف. صدق الله العلي العظيم. Translation. In the name of Allah, the most gracious and the most merciful, by the afternoon and by the night, when it is still darkness, your Lord has neither forsaken nor not hated you. And indeed, there, hereafter is better for you than the present. Did he not find you an orphan and gave you a refuge? And he find you unaware its legal law and guided you. And he found you poor and made you rich. Therefore, treat not the orphan with depression and repulse not the beggar. Amen.
Thank you. I now request everyone to stand up for the Tamil Varieties.
சீராரும் பதனமென திகழ்வரத கண்டமில் தேக்கணமும் அதிசிறந்த திராவிடர் திருநாடும் தக்க சிறு பிறை முதலும் தரிசனரும் திலகமுடி அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் வழக்க இருந்த பெரும் தமிழனங்கே உன் சீரிழமை திறவியந்து செயல் மறந்து வாழ்த்துதுமே.
Thank you so much. May I request Professor S. Himlata, Professor G. Explorer Life Sciences, and the Organizing Secretary for ICP&3 to propose the welcome address to the hearing.
Good morning to all of you. It's my immense pleasure to welcome you all on behalf of School of Life Sciences, T.S. Abdur Rahman Crescent Institute of Science and Technology, to welcome to this international conference, that is Indo-USA International Conference on Applications of Nanotechnology in Biology, Biotechnology, and Biopharmaceutics, ICNB3. In association with University of Missouri, USA, the Biotech Research Society India, Microbiologist Society India, Nano-Biomaterials Association India. It's my immense pleasure to welcome our chief guest, Dr. Satya Rajeshwaran, Assistant Director, Siddha Research Institute, Central Council for Research in Siddha, Ministry of Oil, Government of India, was kindly accepted to inaugurate the conference in his busy schedule. I'm extremely honored to welcome our Vice Chancellor, Dr. P. Mohan, who always motivates in the right directions with his experience. I'm privileged to welcome our Registrar, Dr. Raja Hussain, who is a source of inspiration for all of us working in this campus. I'm extremely happy to welcome the pillar of our institution, Mr. Jalal Singh, General Manager. I welcome all deans, directors, heads of the departments, faculty, research scholars, students from this institution as well as from other institutions. My special welcome to our exchange students from University of East London who came here through touring scholarship from government, that's from Government of UK. I welcome all the invited speakers from various continents and for sharing their knowledge. The conference will be focusing on the applications of biology, biotechnology, nanotechnology, and its applications in healthcare, pharma. And also this conference is aimed to provide up-to-date findings and covering of different research areas in biology, nanotechnology, including molecular biomarkers, microbiology, bioinformatics, genomics, drug designing, etc. The conference includes invited talks from eminent scientists from India as well as from abroad, and poster presentations and oral presentations by the PG students, UG students, research scholars, postdocs, scientists, and also from faculty. Based on the abstracts and based on the presentations, awards will be given to each category. And I'm happy to announce that we have received overwhelming response from all over India and also from abroad. And we have received 340 abstracts from outside. And the presentations will be published in the conference proceedings with the ISBN number. I am also glad to announce that special issues in 4 journals indexed in Scopus, WOS, and PubMed will be published. And these selected peer-reviewed papers will be published in Applied Biochemistry and Biotechnology, Traditional and Complementary Medicine, Inorganic Nanomaterial Chemistry, Basics of Journal of Basic Microbiology. We thank the publishers of Stringer Nature as well as Taylor and Francis for associating with us to publish our conference papers. We thank all the participants for joining hands with us to share the knowledge in various areas of biotechnology as well as nanotechnology. I hope this conference will help in the attainment of research problem. Once again, I welcome you all for this international conference. Thank you.
Thank you, ma'am. I now request the Honorable Vice Chancellor, Dr. A.P. Mohammed, to honor our guest, Dr. Satya Rajeshwaran, Assistant Director and in charge, Siddharth Central Research Institute, Central Council for Research in Siddharth, Ministry of Ayush, Government of India. Also, I now request Dr. Satya Rajeshwaran to release the abstract book. And the first copy will be received by our Vice Chancellor. I now request Dr. A.P. Mohammed, Vice Chancellor, to present the presidential address.
Good morning, all of you. our Chancellor, Dr. P. Satya Rajeswaran, the chief guest of today's function, our Registrar, Dr. Raja Hussain, and the Dean, School of Life Sciences, General Managers, and Deans of various schools, faculty members, and particularly the students from University of East London, and my friends. It gives me immense pleasure to participate in the inauguration of Indo-US International Conference on Applications of Nanotechnology in Biology, Biotechnology, and Biopharmaceutics. At the outset, I congratulate the Dean, School of Life Science, and our team for organizing an international conference. And normally, the School of Life Science conducts many programs, particularly on the international level. So they carry out collaborative work with the foreign universities and foreign organizations, and they have a lot of interaction with the foreign university. One example is the School of University of East London are with us for the past 6 weeks. So this kind of exposure to foreign universities helps us to come out with new ideas, to network with foreign research workers, to deepen our knowledge and carry out useful research work. Particularly nanotechnology finds a lot of applications, and here the main focus is on the application in biology, biotechnology, and biopharmaceutics. Our university is a multidisciplinary campus. So we have School of Life Science, along with we have Pharmacy, School of Pharmacy, and in the mechanical sciences, we have a polymer engineering. So these branches of study find a lot of application in nanotechnology. Nanotechnology mainly engineer the material to get the desired properties. And our mechanical engineering faculty and students have gained a lot of expertise on material science. I would be happy if you combine and collaborate with our mechanical science faculty. Of course, the interaction with the pharmacy is already there. And polymer engineering also, we have a nanotechnology center, well established long back. So our university is pioneer in making the application of nanotechnology to various fields. So that's activity is continuing right now. Really, it's a good feature being organized by our School of Life Sciences. Nanoscience finds a lot of applications, particularly in healthcare, in cancer treatment. So directly attacking the targeted area. So new applications are found with the application of nanoscience. And of course, our air pollution. Every day people are concerned about the pollution. And nanotechnology helps in reducing the air pollution, particularly the treating the effluent water discharged by many industries. And there are a lot of smart textiles also with application of nanotechnology that monitors our health condition and keeps on improving our quality of life. So this kind of conference would definitely increase and motivate our students in doing a lot of research work, particularly on nanoscience. So what I advise all the students is to deepen your knowledge. That's more important. You have to deepen your knowledge in nanotechnology and find some useful application for the society. So doing research for the sake of finding some new knowledge may not be sufficient. So that knowledge will be converted into a useful product. So then only the society would be benefited and it will contribute to the growth of our economy also. So keep in mind always that is in whatever research you do, whatever innovation you come out with, should find some useful application for the benefit of the society. So this kind of conference will go a long way in helping all these activities. I wish that all the participants take part in all the deliberation quite attentively, and it will be very much engaging, it will be useful, and you will get a lot of new ideas and thoughts. So with this, I wish the program a grand success. Thank you all.
Thank you, sir. I now request Dr. Raja Hussain, the Registrar, to deliver the special address.
BS Abdur Crescent Institute of Science and Technology, School of Life Sciences, jointly organized Indo-USA International Conference on the theme of applications of nanotechnology in biology, biotechnology, and biopharmaceutics. ICNB3 hybrid mode. This conference is organized for 2 days as an international level. Today, now the inauguration is going on. For our inauguration, our most honorable chancellor of our esteemed institution come over here and grace the function. Our honorable vice chancellor is also given a presidential address for this conference. The most respected chief guest of the today's event, Dr. P. Satya Rajeshwaran, Assistant Director and in charge, Siddha Central Research Institute, Central Council for Research in Siddha, Ministry of Ayush, Government of India, has kindly consented to be the chief guest and going to inaugurate this conference and deliver the inaugural address. Our respected Dean, School of Life Sciences, Dr. Hemalada, our respected Senior General Manager, our Deans, Directors, HODs, faculties, guests, my dear student friends, particularly the delegates, students from East London, come over here as a touring program. They are also participating here. It's a great honor to us. Today we are witnessing the real international conference is going on, which is organized under the leadership of Dr. Hemalada. So on behalf of our institute, I congratulate the organizers, particularly the Dean, School of Life Sciences, for her efforts, involvement, commitment to make the 2 days international conference a grand success. Likewise, our Honorable Chancellor is always supporting us, and whatever the institution, particularly the various schools, wants to do the betterment, organizing such international conferences, various programs for the development of the institution as well as the individual development of our students, is always encouraging us. At this moment, I extend my heartfelt thanks and felicitation to our Honorable Chancellor on this occasion. Likewise, our Vice Chancellor is also an inspiring source of energy for the day-to-day administration as well as the academic development of our institute. I congratulate and felicitate our Vice Chancellor also on this occasion. Our chief guest come over here due to various special schedule, is going to inaugurate the 2 days international conference by his valuable information, by his the source of energy is going to give the topic which is related to this theme application of nanotechnology in biology, biotechnology, and biopharmaceutics. Is the right person we identified. So on behalf of our institute, we express a heartfelt thanks and felicitations for your come over here to inaugurate this international conference. So with these few words, I congratulate all the student delegates, the guests, the touring students come over here and stayed with us for more than 6 weeks. It's all shows the BS Rahman Crescent Institute of Science and Technology is taking efforts, bringing the more students, faculties, resource person all over the world. It is the witness we are seeing here. With these few words, I congratulate all. Thank you very much.
Thank you, sir. I now request Dr. Satya Rajeshwaran, Assistant Director and In Charge, Siddharth Central Research Institute, to deliver the inaugural address.
Most respected Chancellor of BS Rahman University and Vice Chancellor, Honorable Vice Chancellor, sir, and Registrar, sir, who have say a few words and occupied his seat now. Many of you may be thinking, what is this big man is going to do something about a nano conference? Yes, true. And also there will be questions among what a Siddha person may have something to offer to a nanomedicine. I hope majority of us know Tamil, isn't it? How many of you doesn't know Tamil? Can you please raise your hands? Who doesn't know Tamil? Yeah. Yes, naturally. Okay. Let me put you in small words my association with Crescent first, and I will start doing this. 2 years before, I think before COVID, I met a team of. I had a letter or a card stating that some of very energetic female staff has come over here to meet you, sir. When I saw the card, I can read the name as Professor Hemlana madam came over there, and Ranjani madam came into my room and started a discussion. And slowly, I have smelled the power of women over that entire discussion of 20 minutes, that they are doing many wonders without showing to everybody. And I could understand that they are traveling in a similar path in which I used to travel. As sir very rightly said, it's not a research should always have a social relevance. I have been working in converting up of a small ferric chloride to ferric oxide via green synthesis methodology, in which I always share a patent with an MSc Biotechnology student of 2nd year, because she was the inspiration for us. She came and she started doing her internship, and she was asking her so many questions, and finally we gave her freedom. You just say what you want, and her interest, along with her guide, who is also an officer in chemistry, was towards identifying a compound for green synthesis. And they have been referring to many particles, stating that the people have used silver nanoparticles, people have used gold nanoparticles and all. I said them that let us not repeat the same.
Because in many times, you don't mistake me, I'm saying the truth. Many times, what we used to do is we will try to take up one herb in which our friend has worked, see the loopholes and try to fill up the loopholes. Our aim should not be of that kind that our aim should be you should knock every single door and open the entry of science everywhere. I said them that I have found a small quotation from Siddha in which they have used a particular plant, that is Acalypha indica, which you used to extract out the silver nanoparticles. They have used that particular plant for trituration of a compound and converting it from one form to another. And she has tried just made a green synthesis, pouring some 10 ml of Acalypha indica juice, converted ferric chloride to ferric oxide. If you go back and refer back to the industrialization of conversion of ferric chloride to ferric oxide, huge economies involved over there. And what is the use of this? What is the social relevance, as I have quoted earlier? If you take this ferric oxide and if you just put it in so it's a very great achievement for us in the environmental engineering area. As Sir said very rightly, nanotechnology is a gateway of many sciences. And I was, when Rajani Madam shared the brochure, I was thinking, what is this ICNB3? It's more or less like a chemical formula. It is more or less like a chemical formula. So it's very important. See, nanotechnology, see, our traditional knowledge has the fission of an atom has placed it as being taught us via earlier. If you go and refer back to the earlier Tamil literature, antique Tamil literature, all has this. And Abdur has described nanotechnology using Tirukural. You may be knowing Tirukural was the earlier shortest form of expression. Tirukural, even though having 2 lines, will express your entire life theory over there. Anuvai an atom and inserting the water in the ocean. She was quoting Tirukural as equated to this. So when you go behind and say have very easily stood away and said that there is one energy which governs the world, and this energy will come out when you break up all the atoms. Anuvil, Anuve, Adibirane, Anuvil, Anuve, Ai. That is the point. So people has a knowledge of splitting an atom, converting it into its smallest sizes. So I think, as Sir said, Nano, to me, will start ruling the world from 2030, at least for a period of 2 centuries, because we are failing. Medicines started failing, the macromolecules started failing. But my point of address today in my inaugural address, that is in the talk, will be about the ethics involved in nano-related researches and product development. I know many of you are now very much skilled in developing nano products. But if you want to do an application with a nano product, you should be more careful than with that of a macromolecule which we use. As many of you know that pharmacology very clearly denotes there is a proportion between the size of what you give and its absorption. When its size goes very small, absorption will be bigger. The same way, efficacy will be bigger. Equatedly, toxicity will be bigger. So it's going to be in my presentation, but don't take it in a negative way. It's a very positive note that We have developed a product now. We are before launching. What are all the areas we should be most careful? That's going to be my address. And with this, I'm thankful to every one of you present over here, all the deans of this college, Emalana madam and her team. Thank you all, and I wish you all a wonderful knowledge gathering for the students. Thank you.
Thank you, sir. I now request Dr. Mubarak Ali, Assistant Professor, School of Life Sciences, B.S. Abdur Rahman, Crescent Institute of Science and Technology, to deliver the vote of thanks.
So very good morning to all of you. I gathered here for this Indo-USA international conferences on applications of nanotechnology in biology, biotechnology, and biopharmaceutics held in today and tomorrow in our campus. So we extend our deepest gratitude to the Chancellor, sir, Honorable Vice Chancellor, Professor P. Mohammed, and Registrar, sir, dear General Manager, sir, for your encouragement, support to organize such an event in a hybrid mode. It's very challenging to conduct in both in offline and also in online. So the management and the administrator operator, they are support to managing this very efficiently. We extend our request to gratitude to the chief guest of today, Dr. Satya Rajeshwaran, sir, Assistant Director, who come our way to give a chief guest, inaugurating this event and also be going to give a keynote address to this gathering. We also render our gratitude to all the national and international speakers, namely the Sir Satya Rajeshwaran sir and Jungwon Kim from the Republic of Korea, and the Rubendran from University of Missouri, USA, Dr. Srijit from Teesside University, UK, and Haribalan from Hanming University, Korea, and Luke Elizabeth Hanna from National Institute of Research in Tuberculosis, and Mukesh Tobul from IIT Madras, and Avinash from IIT TM Kanchipuram. So we'd like to thank all the speakers who are going to deliver their invited token of two-day deliberations. And we also extend the gratitude to the University of Missouri being associated for conducting this conference, and the BRSA, that is the Biotechnology Research Institute India, and Microbiology Society India, Crescent Institute of Education Madurai campus, and National and Nano and Biomaterials Association of School of Life Sciences, and also it is sponsored by the TNSST. We also thank CIIC for their technical support, and also thank the deans of all schools, other schools of our BSA professors, research scholars, and students of BSA CST. So with that, and last most importantly, the participants from various countries and also other national wide. So those all joined in online and also in offline. So without that, this not make it possible. The short span of time, we got the overwhelming responses from all the participants. So on behalf of our School of Life Sciences and BSACIST Crescent of Sciences, we all welcome you all for this conference, and thank you for joining this one. I hope this 2 days of deliberation will make you a wonderful day. Thank you so much.
Thank you, sir. Now I request all to go for the tea break. Dr. Satya Rajeshwaran. A brief introduction about him. Dr. P. Satya Rajeshwaran is the Assistant Director in charge, Siddha Central Research Institute. He has completed his Bachelor of Siddha Medicine and Surgery and MD in Balava meaning Siddha Pediatrics, and PhD in Siddha Medicine Clinical Research from the Tamil Nadu Dr. MGR Medical University, Chennai. He has also completed his PG Diploma in Bioethics and a Professional Diploma in Clinical Research. He also has a work experience as a lecturer, professor, and HOD, research officer, and now he is working as an assistant director in Siddha Research Institute. His research specializations include clinical and drug research, teaching and training. He has also received research grants around 3 crores from Central Council of Research in Siddha from various projects such as polyherbal formulations, diabetes mellitus, and non-communicable diseases. He also has more than 30 publications in international journals. He has also delivered invited lectures for various workshops and national conferences. It is a great honor to have him here. I now request Dr. S. Envalata, Dean, School of Life Sciences, to honor Dr. Satya Rajeshwaran. Thank you, sir. I now request Dr. Satya Rajeshwaran to deliver.
How many of you know about ethics? Every one of you know about ethics, isn't it? Is ethics a special term, or ethics should be a necessary responsibility of every human being, isn't it? How it is different from, see, ethics in medicine is already there, no? How it is going to be different for ethics in nanomedicine? That's the question. If you ask this question, that question will make you to answer many things, and it will make you little careful when you are going to do any application using a nanomaterial. This is the cardinal principle of any research happening in a human. You should understand first. Just I want to. Is there any doctor over here? Is there any physician or a clinical researcher over here among yourself? Okay. Think a phenomena that you are entering into a clinic. You are entering into a clinic. At the point of time, a physician is examining you and saying you, stating that you belong to this and this category, and you are excluded from a clinic. Is it possible? நீங்க ஒரு ஹாஸ்பிடல் போறீங்க, டாக்டர் உங்களை எல்லாம் பர்சனல் எல்லாம் பண்ணிட்டாரு, பண்ணிட்டு saying that நீ என்னுடைய கேட்டகரியில வரல, நான் உன்னை பார்க்க முடியாதுன்னு சொல்ல முடியுமா? Is it possible in this country? In clinical ethics, it is not possible to exclude any of your patient. As per Government of India regulations, a physician should attend and say that I am not specialized in this and I will refer this particular person to another doctor. So that is called as a clinical ethics. But if you come to my hospital in which I am conducting a clinical trial, I have the freedom to exclude you, because I have designed my clinical trial in such a way that I can exclude you exclusively, and I can select you. I can smell your quality and I can include you. So here in a clinical trial, who is the real king? In a clinical trial situation, who is the real king? Is it the sponsor who is going to manufacture this drug, putting its cost and manufacturing its drug, or the principal investigator or the physician who is conducting this study, or the monitor who monitors the physician who conducts this study, or the patient? Who is the king here? Why? Good answer. But you just imagine a situation in which a sponsor would have put over money, and secondly, the investigator should have getting a regular income from the sponsor. A monitor, to monitor the investigator, he will be getting some money from the sponsor. Those three guys do not have an autonomy. The question is, it's the autonomy of the patient that he can move away of the clinical trial at any point of time. So is the real king. நான் நினைச்சால், நான் சம்மதித்தால் மட்டுமே தான் நான் என்ன பண்ண முடியும்? I can come and exist in your clinical trial. Then comes the confidentiality. The investigator or the monitor or the sponsor should not reveal any of these information about the participant who have participated in this clinical trial. And third comes the non-maleficence. This is very, very important for us. The drug that we give to a patient or an intervention, let it be a drug or an intervention which we use it in a diagnosis, nothing should harm the patient at any point of time. And there should be justice. There will be justice if you go with these 4 cardinal principles. You may now think, I'm a person who is doing my study in biotechnology. How a clinical trial will be very much close to me? An answer is this. There are around 100 and 150 clinical trial companies in India who recruit biotechnologists for helping in their entire clinical digital information transition. So it's very imperative to know that all biotechnologists are now included in a clinical trial, not as a physician, but even to know about the data, the safety, the efficacy of the drug, and they used to do that. Why nano diagnosis is becoming very, very prominent now? In clinical diagnosis, in any laboratory diagnosis, the diagnostic, see, if you want to do a keyhole surgery, people used to say the word called as keyhole surgery. And they will say that with the keyhole surgery, you can go within 2 days. You have only a minimal hospitalization. the hours of hospitalization, the size is very smaller. So the approach is easier. You can put a small capsule into a catheter and drive this catheter in your body and diagnose things. So it's very, very important. As I said, even in the talk, that nanomaterials will be very famous between 2030 and 50. Ethics statement in nano usage is still nano in nature. We are very now we are a toddler in writing ethics for nano. As I said, size matters always, either big or small. The effect cost is measured out of the size. More absorption will cause more toxicity. All of you should understand that I am trying to minimize the size of my particle, but I am increasing the probability of toxicity. People used to say that this is very small, this will cross the barriers. Yes, do. If it crosses the reproductive barrier, you can go and see, you can go and look into the reproductive toxicity caused by nanocarriers. Because of that, their sizes, it's more. So absorption, when it's absorbed more, toxicity is more. And as we have even in pharmaceutical areas, in macromolecules, the kinetic studies are very, very minimal in country like India. See, you will be astonished to know that I belong to a traditional medicine. This traditional medicine, which is around 10,000 years old, prevailing in this country, have around 267 enlisted essential drug list. Same number exists in Ayurveda. A similar number also exists in Unani. If you put a sum total of the traditional Indian medicine alone, these molecules will cross more than 900 in number. If I want to do a kinetic study, it will take at least 2 years to complete a kinetic study of a single drug. Drug here, don't misinterpret my word as single drug, a single formulation. And now we are medically to be used adhering ethic statement. We will be always adhering ethic statements. But adherence should be a behavior, not in only adhering statements. Many times, why films criticize the doctors? Why all the industries, pharma industries, try to capture the doctors? Ethics is a personal character and an attitude. It implies also in dwellers who are stakeholders of the nanotechnology in various ends. See, I am very small. Why you are making a huge crime? A nanoparticle can ask any one of you. Who am I? I am a miniature. Who am I? But I easily enter within you while you are inhaling. I will not inform you, I will enter. People who are working in nano-related industries are suffering from hazardous diseases from which we get from industry. That's very, very important. I can cross BBB, which the macromolecules cannot do. Yes, true. If you come and look into traditional Siddha formulations, the formulations which are designed for brain are always have been ended with, we will extract the juices from herbs, put it in ghee, boil it, and make it as a medicated ghee, and we give. Because there is a blood-brain barrier in which you are I expected to have a lipid which will cross a blood-brain barrier. As like a lipid, a nano carrier or a nanoparticle due to its size can cross. I will be small, but after getting ingestion, after getting absorbed, If I ingest via orally, I don't know, will I be bigger? I don't know, will I dwell? I don't know. I may hit on any other object. I don't know. So I can change myself after getting ingested. That's very important. I can change my size. I can behave differently for animal and humans. That is the very important point. A nanomaterial we will slowly look into that. A nanomaterial which has been inserted into an animal, and the animal behavior to that insertion will be little different than that of a human behavior. Until today, I am having an animal house in my institute. I have a thought, and it's true many times that what I try in an animal study will be replicated in human, but not in nano many a times. That is a very important point to be known over here. This is a reference from Chase et al. Shidova et al. 2003. You can see that carbon nanotubes, that they have been a reason for platelet aggregation. If you are going to say that there is a possibility of a platelet aggregation, then there is also a possibility of vascular disease. That we should have it in mind. All my talk over here is not to inhibit you towards your science. No. All my talk over here is to include you also in these ethics related sciences, and you should be little careful while you are defining or writing your protocols. That's very important over here. I think you all know better than me. This is fullerene. Fullerene is a water soluble item. Usually, fullerene has been used. It possesses exceptional antioxidant capacity. I think you may be knowing, many of you may be knowing what is antioxidant. To people who are away from India, I want to say a small information. The theory of antioxidant came into existence in the year 1950. But Indian traditional knowledge used two words called as Rasayana or Kayakalpa. Rasayana is a term used in Ayurvedic sciences, and Kayakalpa is the term used by Siddha science. Both these sciences have a 2000-year-old history. And they have found that there are practices in which you can take some food which will give you antioxidant mechanism, which will make your tissues stone-like, and which will allow you to live longer. So these antioxidants are abundant in many of the Indian foods. Here, what happens is, at times, fullerene have promoted apoptosis than it is expected to prevent the tissues. You are traveling in a road. You may be exposed to many smokes. You may be exposed to fumes. All these are anthropogenic. That is which will have a very close relationship between the human behavior and character. And the viruses which you get at time, the virions float in air. People used to say that at the time of COVID-19, people used to ask you to fumigate your entire place. So all these are smaller, but all these can make a disaster. It may create oxidative stress. It may create inflammation in your body, and it may interfere in your immunological response. So it's very important to identify all these naturally occurring nano-related particles. So when I am saying naturally occurring nano-related particles, I hope you all guys are exposed to top-down and bottom-up phenomena in nanotechnology. Do you know who is the first person who have invented the top-down? None other than your grandma. none other than your grandma, who has a habit of pounding the millets that she had. See, what we do, we pound and make a macromolecule into micromolecule. In Siddha, what we do, we take a macromolecule, a formulation, either fry it or shade dry it, sometimes sun dry it, powder it to its minute size and sheave. We used to sheave in pharmacies. This is the top-down method. Or otherwise, what we will do? We will do an incineration. We will make cakes out of the herbal mixtures, put it in earthen discs, earthenwares and earthen pots and incinerate. We will collect the sublimated material which has been stick to the upper earthenware. All these exist. See, that's a different topic. If you go and read Nano in Siddha, my PowerPoint is really available for everybody to read. You can see that around 10 to 25 already existing drugs have been standardized for their nano characterization. And you can see a lot of oils which we use are nano emulsions by nature. Now in my lab, I am trying to make it into a nano emulsion material using lecithin. So there are many understanding and things are going all around. What we want to do is, yes, it's very true that we are very good in, but when you are going to make it into bigger, when you are going to extrapolate into a bigger industrial engineering, you have many regulations with you. Only understanding these regulations will help you to make it to the market. In the right side, I have placed a small capsule. Have you seen it? This small capsule has a history for a patient suffering from severe stomach pain. And she has a habit of vomiting very often. And when somebody put a capsule of its similar character, they have identified this capsule underlying there. So, like a capsule retention, a dendrimer or a nanotube many a time may be a retented material inside your body. Be very careful in designing such type of thing and do clinical studies. Phase 1, see, many a times, we skip phase 1 studies. Do you know what is a phase 1 study? See, I am developing a drug in the market. Okay. Say I am developing a drug for your jaundice. I am developing a drug which is a hepatoprotective. Okay, wow. I am developing a drug which will safeguard your liver. I am claiming that it safeguards the liver. I am claiming. If I want to prove, what study should I do? Is it efficacy or safety?
Both efficacy and
If you want
safety.
me to repeat in Tamil, I will try to do it. நான் வந்து ஒரு லிவர் ஈரல் நோய்க்கு ஒரு மருந்து கண்டுபிடிச்சிட்டேன். அந்த மருந்து எப்படி வேலை பார்க்குதுன்னு நான் பார்க்கணுமா, இல்ல மருந்து வந்து சேஃபா இருக்குன்னு நான் பார்க்கணுமா? Which is priority? Why? Imagine a situation. My drug is wonderful for liver, but it takes you one of your kidney. That is happening. That is happening. So it's very important in any trial to do a safety first. That's very important. That's my point over here. That you should understand. I can even see people will say that I am just using an external oil set, which is a nano emulsion which will make me to glow like anything. Next day after application, the black color is glowing like anything. What happens? Expectation is in the opposite side. So safety, why people used to always, there will be in all your, I hope our male community doesn't have an opportunity to take something and put it behind the ears. But you guys used to do that. That's very important. See, that establishes your safety. And second comes, as you said, efficacy. Efficacy should be an exploratory part first. What is exploratory? I want to test this in a smaller group of people. I want to test the efficacy of my nano based product which I use inside for a smaller community. I should understand the efficacy. Then I should reconfirm it via larger community, in which I will be happy to do it in a multi-centric, multi-race, multi-ethnic trial. The safety, the efficacy exploratory, I will do in a small population, including my own people in my village. Then I will do the study in a city like metropolitan, in which I will include people from Northeast. I will include ethnic race from Kerala. I will include some ethnic race from Karnataka and some from Andhra, and I will see how my drug acts differently among all these populations, and I will come into a conclusion to say that it is beneficial for the human race. This is the step. You should do an exploratory, then you should confirm it. But there is another step, which is called as a post-marketing surveillance. Every time we will be seeing different actors promoting different products. No. Same product, when Dhoni is a captain, he will promote. And the same product will be promoted by Virat Kohli. But you don't know, all the products are different. The first product would have been flooded over in the market, then they would have done a post-marketing surveillance and understood how this drug is good or bad. They will adjust the qualities which is expected and they will remarket it, which we don't know. For that, they will say that now Horlicks is in a newer version. Old Bhanumati will vanish and Nayantara will come. So we don't understand what is happening. This happens in medical research also. But it should primarily happen in nanoscience. Because I have taken a nanomaterial, a nanotube, put a target molecule over there, send it to a cancer affected area. The substance would have released. What about the remnants? I don't know. I don't have a clue what may happen. So it's very important to also do a post-marketing surveillance in any nano-related products. And informed consent. Do you know what is an informed consent? Some of, I can see some young guys over here. If you are asked to write an informed consent at the time of your marriage, what will happen? Informed consent, I should inform that to my would-be that I think, or I should say openly that you are one among the choices. And I had some 3 or 4 breakups earlier. I used to spend my evenings, Saturday evenings at pubs. And I give my consent to marry you. And then all these guys have started cursing me. I'm saying that this alone has not happened in Indian marriages, then you are trying it. What is informed consent? Same thing should happen in a clinical trial. In clinical trial, you should inform to a patient that I have found out a nano-based cream, skin cream. I don't know the toxic effects this skin cream may do to you. And I can say that it is hypothesized that this may increase your facial brightness. And you are, all the investigations and the blood which we draw from you will be the ethical procedures. There is no cost for you to get involved in this study. You have the autonomy or the freedom to move away from this study at any point of time. And we have insured you who have participated in this trial for such period in this clinical trial. Any harm happening to you will be managed with the insured money. This is the real expectation. Do you know what happens really within our PGs? If it is an osteoarthritis trial, their inclusion criteria will be between 30 to 65. Sorry for using Tamil, and I will come back and explain in English. Party, Armiano or Marnurke. Free, X-ray free, blood free. Musa test penny, super Marandu, free at Taraporo. The Korean Kail Matum Portugal. The Bala for a party Kail Portugal. Nalaki, Maranda Enapanua, party Kutrua. It may have some benefit. You put your guard. And our trial period Mundu party verbal. Even break up on a Kadali de Epri Nadapan. Adumari Nadapa. Party Q, Imunuku, Samandimilade. This is the reality. See, I'm not cracking a joke over here. This is the reality. When you do an informed consent, you don't explain the benefits alone. We used to say that we will explain the benefits alone. We don't explain them the risks involved. That's the point. See, inform, you know lesser about toxicity. Inform them the risks involved. At times, you may not have even a clue of what a risk is going to happen. Then inform in their local language. That's very important. Addressing a party from Brooklyn in a British accent, immediately she'll be frightened and put a signature. So it's very important, make them understand in their local language, you inform them and get a signature. Also inform the benefits to the society. You should write what is the benefit. You should say in this language, I know that you are a patient suffering from cancer, but I don't know either my drug may work on you or not. If you survive, you are the person who is going to give a very big benefit to the society who have tested this drug. This is very important in the clinical ethics. I will close here with a published TB nano story. There is a publication, even you can go and see this publication. This publication says about the investigators involved in a nano-based drug. They have the regular anti-tubercular drug, which we have in the market. It's around 5. And after that, they have a nanoparticle which will enhance the bioavailability. The normal course with an anti-tubercular drug is, this is a 5 combination drug. When you take this drug for 6 to 7 months, it will give hepatotoxicity. Because if you take 400 mg, 200 mg will be absorbed and 200 mg will be kineticized, by which you will get a toxin. I have identified a nanoparticle which will increase the bioavailability, thereby reducing the side effects. If you are supposed to take the older drug for 4 days in a week, this drug will give you 2 days in a week. They have released this drug in the market and they have been caught by ethics people. And they have asked questions, an interview. See the courage of these authors. These authors have dreamt a situation. They have not done this trial. They have dreamt a situation and they have published it. On the day, I am going to launch this product on today. Next day, I am going to launch this product. Before that, there were a discussion between the four group involved inside, and they have published the risk that they would have encountered, and what is their urge to take this drug. Just imagine this with the story that I am going to tell. Definitely, all the nano-related people who are working in nanoscience have an urge to give an answer. That is, see, every innovation has a solution. They are trying to give an answer for the society. So here, the physicians told that, see, I have been seeing these guys suffering out of tuberculosis. I have been also watching that they are suffering out of the toxicity given by these drugs which we use for tuberculosis, and I think that it might be a panacea for them. This is the physician statements. A nurse come and tell, I am bored with these TB patients, sir. These TB patients, whenever they took 4 days drug, then they vomit. They say that I am having a heat all over the body. I am reduced weight. I couldn't eat much. If you give a solution, it will be for me. The sociologists who have been involved in the TB research are saying that I am bored to go walk day by day into the houses daily and come back. If this drug eradicates TB, I can have a rest. And the poor patient came and he said that I would have died 4 years later when I have been diagnosed on the day of TB. And they are saying that if I could get a solution, that will be better for me. See, here we have concluded. Here the story ends and it has been published. You can go and verify. Everybody has an expression. They have an urge behind. They are trying to get a solution. But this study didn't happen as the ethics committee questioned 4 things. Ethics committee wanted the safety of this drug which is being tested. And they want to do it in a phase 1 safety drug tested among the tuberculosis population. And they wanted the efficacy of the drug with the limited amount of tuberculosis population. And the the poor nanoscience person who is from pharma is not allowed as per the guidelines of the ethics, stating that only a trained doctor should investigate this drug. So 100% we have a complex mechanism, and this complex mechanism are our regulation. If you go slow by slow with this regulation, you will win, and then you can say that nano is small, but it is big. What is the take-home message? Always smaller is not inferior. Smaller can be bigger in action. Size do matters. Smaller or bigger, patient is bigger than enemy. Smaller are not safe always. With this, I am concluding my talk over here. I will be happy to answer one or a few or more questions from you. Thank you.
Anyone would like to ask questions?
Here there is only 2 situations. I am clear with everything. Nothing is clear to me. Okay, thank you.
Thank you, sir. Thank you for this wonderful lecture and letting us know that we as biotechnologists can also have career in clinical research. And thank you for discussing about the ethics involved in nano-related clinical research. Thank you, sir. We have another lecture, so kindly wait.
Hello. Hello, Professor.
Yes,
Yes, okay. So checking whether the voices are clear.
pardon me. Okay, so is this my turn to present?
Yes, Professor. We have a
Oh.
formal introduction, then we'll have to.
Okay, okay, thank you. Do you hear me?
Dr. Farida. Excuse me, Professor.
Work, sir.
Simon.
Hello, கேக்குதா?
Professor, just adjusting the laptop and the view and all to the participants. Please be for 2 minutes.
Okay. So I'm not lost at all.
No, Professor, you are. I mean,
Okay. Because I don't hear anything.
yes. Hello.
Yes. Should,
Yes, Professor.
shall I?
Yes, we can.
So now I can start.
You can share
Okay,
your
so-
slide. Before that, I like to give some
Okay.
introduction about your professor. Yeah.
Okay. So
So on behalf of our School of Life Sciences, BS Abdur, Crescent Institute of Science and Technology, India, we cordially welcome Professor Jungwon Kim from Incheon National University, Republic of Korea. With a small brief introduction about Professor Kim. She has taken her BS degree in Korea University, Republic of Korea, and she graduated PhD in University of Illinois in the year 1990 in the field of molecular biology, and she's serving till there the professor in Incheon National University, the division of bioengineering since 1944. And there are various field of interest which includes expression and application of amylolytic enzymes, regulation of glycogen metabolism, and pathogenesis in bacteria. Now she elaborately involved in the application of solution plasma process for the development of biomaterials. And she's also been a chair in, coordinator and chair in the division of bioengineering and recruiting the students for the employment. And I great to welcome my own professor to this guest gathering to deliver a lecture on application of solution plasma process for the development of various biomaterials derived from alginate. Yes, Professor, this is time for you.
done. May I
Yes.
start?
Yes,
Okay.
Professor.
Thank you for wonderful introduction. And good morning, everyone. I'm Professor Jungwon Kim at Division of Bioengineering, International University, Republic of Korea. It is my great honor presenting my research topics in ICBN And I thank Dean Himalata and other faculty members and staffs in Abdur Rahman Crescent Institute of Science and Technology for the invitation. Today, I'd like to present our recent research on solution plasma process for the development of various biomaterials based on arginate. Oops. Okay, so first I'd like to give you some background information on our research. The aims of the investigation is to produce various oligobiopolymers from macromolecular organic compounds such as arginate, chitosan, and beta-glucan using a solution plasma process, which is to be abbreviated as SPP, and characterize their potentials as biofunctional materials, thereby breaking through limitation in application of the biomaterials. Today, I'd like to make focus on the development of biomaterials based on arginate discharged with plasma in solution. Solution plasma process is carried out by discharging plasma in liquid. By high voltage application, various ions and reactive oxygen species are generated at the interface of gas and liquid. Okay, and those ions and reactive oxygen species would accelerate reactions in the solution. It is a very rapid and facile green strategy for various reactions that can be adjusted by modulating parameters such as voltage, frequency of electricity, and discharging time, and the concentration of solute in the solution. Discharging plasma in a reactor equipped with 2 tungsten electrodes here and here, okay, in juxtaposition with a gap of 1 millimeter at 600 to 900 voltage would generate various ions and radicals in various solutions to accelerate diverse reactions to generate nanoparticles or depolymerize molecules. In our laboratory, SPP has been used for diverse purposes, such as synthesis of nanometal particles and nanometal biopolymer composites of silver or ceria in the matrix of gelatin, cellulose, chitosan, arginate, etc. And it also has been used for sterilization of water body and degradation of toxic compounds such as bisphenol A and macromolecules. Okay, and it also has been applied to the synthesis of biofunctional biomaterials such as artificial bone. Now, I'd like to present results on synthesis and characterization of oligoarginate using SPP. Arginate is an anionic polysaccharide, a major component in the cell walls of brown algae. It is a polymer of hexanuronic acids, of mannuronic acid and gyuronic acid linked by beta-1,4 glycoside linkages randomly to be arranged in repeating GG, MM blocks or alternating MG blocks with molecular weight larger than 10,000 to 1 million Daltons. It is known to be non-toxic, biocompatible, and biodegradable, and has been used as hydrogels for foods and cosmetics, and also as drug delivery systems. However, its application has been limited due to its low solubility and high viscosity in solution. Sorry. Okay. Oligoarginate with molecular mass lower than 10 kilodalton has been produced by hydrolysis using an enzyme, arginate lyase or strong acid, or treatment with gamma radiation. It has been known to have antimicrobial, anti-tumor, and antioxidant activities, and has been used in pharmaceutics, as you can see here, and cosmetic industry for its biocompatibility. As an effort to produce oligoarginate more efficiently and in a safe manner, we employed SPP. Okay, so 0.1% to 0.75% arginate solution was discharged with plasma for various times at voltage 800 and frequency of 35 kilohertz, equipped with 2 tungsten electrodes and water cooling system. And the resulting oligoarginate was freeze-dried and cross-linked with UV irradiation before utilization. Upon increasing the discharge time and concentration of arginate, the color of the solutions turned to pale yellow to light brown at 0.5% and 0.75% of arginate, indicating changes in arginate. UV visible spectroscopy showed increment of peak intensity at 265 nanometer to the peak at 265 nanometer represented formation of oligomeric molecules from the polymer, correlating very well with the previous report on radiation-induced arginate degradation. GPC analysis of oligoarginate generated from 0.75% arginate showed that in 60 minutes of 60 minutes of plasma discharge, the molecular mass decreased to about 7 kilodaltons, and the viscosity of arginate was reduced significantly to 1.8 CPS by the plasma discharge in the solution. Dynamic light scattering analysis showed the size of the oligoarginate molecules decreased as the plasma discharge time increased, and the absolute value of zeta potential decreased significantly by the plasma discharge in the solution. And FTIR analysis of the oligoarginate solutions revealed no obvious changes in the chemical structure. Okay, and the data is not presented, but the polymerization of the arginate molecules has been proved by the DNS analysis, measuring the amount of reducing monosugars released from the macromolecule. Oligoarginate synthesized using 0.75 arginate showed excellent DPPH radical scavenging activity and also hydroxy radical scavenging activity, and relatively low superoxide radical scavenging activity and hydrogen peroxide radical scavenging activity. And the activities of oligoarginate increased as the plasma discharge time increased. Biological functions of oligoarginates were investigated further. 0.5% oligoarginate promoted growth of lettuce and proliferated the human embryonic kidney cells in vitro by more than 40% at the concentration of 1 milligram per milliliter. Fluorescence microscopy showed that apoptosis and death of the HEK293 cells were reduced significantly by oligoarginate. The possible changes in the gene expression of the cells treated with oligoarginate is under investigation. Next, effects of oligoarginate on the bacterial growth were examined using oligoarginate discharged for 90 minutes, using 0.75% arginate. Growth of the two industrial species of Bacillus licheniformis and Bacillus subtilis was greatly promoted and extended when treated with 2% oligoarginate. The control culture in TSB, shown in black, reached OD at 600 of 11.8 at 72 hours. However, the experimental culture in TSB with oligoalginate, shown in red graph, grew steadily to a maximal OD at 600 of 20.6 at the same time point. However, no such effect was observed for other industrial microorganisms such as Lactobacillus plantarum and Saccharomyces cerevisiae, whose data are not shown here. Not only the vegetative cell growth, but also sporulation of Bacillus licheniformis was greatly enhanced, about 3/4 by oligoalginate. At 36 hours, okay, as you can see here, in the control culture, the cells in the control culture began to lyse and not many endospores are observed, while the cells treated with oligoalginate developed into endospores efficiently. So as an effort to understand how oligoalginate promoted the bacterial growth at the levels of gene expression, transcriptome analysis of mRNA in the bacteria treated with oligoalginate or untreated was carried out. Okay, total RNA was extracted from the bacteria at the hour 15. At hour 15, when the two cultures began to show difference in in the pattern of growth. Transcriptome analysis revealed that 904 genes out of 4,350 genes in the genome had more than twofold differences in expression due to oligoalginate. Genes for molecular functions and biological processes were affected greatly. Regarding the genes for molecular functions, 458 genes for enzymes and transporters were the most affected. And regarding the biological process genes, 522 genes related to metabolic process and the cellular processes were the most affected. Regarding the cellular components genes, 281 genes related to cell and membrane were the most affected. 6 of the top 10 upregulated genes were those related to the biotin synthesis. Biotin is a coenzyme for carboxylase enzymes, which are involved in the hydrolysis of carbohydrates, synthesis of fatty acid, and gluconeogenesis. Expression of the genes for biotin synthesis increased greatly by 24 to 139.5 folds. This could be the reason why the culture of Bacillus licheniformis treated with oligoalginate could grow more and longer than that untreated. Most of the sporulation genes, 55 out of 58, were expressed more than two-fourths higher, and this evidence the oligoalginate promoted sporulation, especially the genes working during the sporulation stage 2 or later were expressed much higher than others. And all the genes for ion ABC transporter and CDR4 were upregulated too. However, all the genes for other metal ABC transporter were downregulated, especially the expression of the 3 MNT genes decreased by 100 to 200 folds. CDR4s are known to promote sporulation in Bacillus subtilis, acquiring ion to change cell development and accelerate sporulation. Supporting sporulation was promoted in the oligoalginate treated culture. In the meanwhile, the expression of N-acetylmuramoyl alanine amidase inducing autolysis, it decreased by 19.5 folds. This also supported prolonged growth of the bacterium when treated with oligoalginate. And this is the summary for the part 1. Alginate was depolymerized readily to oligoalginate with molecular weight less than 10 kilodaltons via eco-friendly way of SPP by discharging plasma for 60 to 90 minutes. And the resulting oligoalginate had excellent DPPH and hydroxy radical scavenging activity, and oligoalginate promoted growth of lettuce and the HEK293 cells greatly, and also enhanced vegetative growth and sporulation of important industrial bacteria. And transcriptome analysis of Bacillus licheniformis treated with 2% oligoalginate suggested that the bacterial growth was enhanced and extended by increasing expression of the genes for biotin metabolism, sporulation, ion transport, and repressing those of the genes for autolysis and inhibition of cell division. Now, I'd like to present the result on synthesis and characterization of oligoalginate nanoseria biocomposite using SPP. Okay, nanoseria have a low redox potential of the tetra and trivalent serial redox couple. Nanoseria particles are metal oxide-based nanoparticles possessing outstanding ROS scavenging activities, primarily due to the availability of oxidation switch on their surface. And nanoseria has been used for various biomedical purposes due to its excellent antioxidant activities. And nanoseria mimics oxidase, peroxidase, and catalase and phosphatase, etc. And they have been synthesized by various ways, including chemical and physical methods. However, the methods use hazardous chemicals or expensive apparatus and usually take very long time, which making them inefficient. So previously in our laboratory, nanoseria particles were synthesized efficiently by discharging plasma in the sodium nitrate solution at 800 voltage with a frequency of 30 kilohertz for maximum 25 minutes using a pulsed unipolar power supply. UV-based spectroscopy showed a characteristic absolute maximum, observance maximum at 304 to 320 nanometer for the nanoseria particles. The peaks exhibited transition redshift due to nanoseria formation, and high-resolution 10 microscopy revealed spherical nanoparticles with an average size of 7 nanometer, and nanoseria showed excellent pH-dependent antioxidant potentials for hydroxyl and superoxide anion radicals with no cytotoxicity on the HeLa cells up to 1600 microgram per milliliter. So as an effort to enhance the antioxidant activity of oligoalginate and nanoseria, biocomposites of nanoseria in the matrix of oligoalginate were synthesized using SPP. For the purpose, 0.75% alginate was depolymerized into oligoalginate using SPP for an hour, and then various oligoalginate nanoseria biocomposites were synthesized by discharging plasma in the oligoalginate solution containing sodium nitrate for 15 minutes. As you can see on this slide and this slide, UV-vis spectra of oligoalginate containing 1, 3 or 5 millimole sodium nitrate showed the peak at 260 to 264 nanometer around here. Okay, and this indicates the presence of oligoalginate, and unique peaks were observed at 362 and 634 or so, probably indicating the synthesis of nanoceria particles and biocomposites. The peaks became higher as the concentration of sodium nitrate and plasma discharge time increased, and the color of the solution turned to darker as the discharge time increased. Okay, and these results suggest the formation of nanoceria in the oligoalginate matrix. FTIR analysis confirmed no specific change in the chemical structure of oligoalginate, and the XPS analysis of the biocomposite showed the prevalence of nanoceria as tri- and tetravalent ceria in the oligoalginate matrix, and showed that the oligoalginate matrix did not interfere with the bivalent state of nanoceria particles. The biocomposite had sheet-like structures with some pores in which nanoceria particles were embedded and well dispersed. EDS mapping analysis showed 4.16% of nanoceria was present in the biocomposite. DLS analysis showed that the particle size of the biocomposite became larger by the incorporation of nanoceria and that of oligoalginate itself. And the absolute value of zeta potential, zeta potential increased. Zeta potential of the biocomposite became larger, suggesting that the biocomposite solutions became more stable regarding colloidal dispersion. TEM analysis showed that the nanoceria particle had spherical shapes with an average diameter of 5.17 nanometer, and about 42% of nanoceria particles had sizes smaller than 10 nanometer in diameter. The biocomposite synthesized using 0.8% oligoalginate and 5 millimole sodium nitrate showed DPP, H, and hydrogen peroxide scavenging activity higher than those of nanoceria or oligoalginate. Its hydroxyl radical scavenging activity was similar to that of oligoalginate, but higher than the nanoceria. And the super oxide radical scavenging activity was similar to that of nanoceria, but higher than that of oligoalginate. Therefore, these results showed that the capacity of oligoalginate nanoceria biocomposite as an antioxidant agent was greatly improved. Preliminary investigation on anti-biofilm activity of the oligoalginate nanoceria biocomposite indicate that it could inhibit bioformation of Vibrio bonificus, a marine pathogen causing fatal septicemia, by almost 50%. Under the conditions, biofilm formation was inhibited without affecting the level of growth of the pathogen. On the other hand, the biocomposite of oligoalginate nanoceria was not toxic to the HEK293 cells at all, up to 1200 microgram per milliliter, and the estimated LD50 value of the biocomposite was 1995 microgram per milliliter. So the results suggest that the biocomposite is safe for various applications, even to humans. And this is the summary of the part 2 regarding the oligoalginate nanoserial biocomposite synthesized using SPP. I think due to the time limitation, I will skip it. Okay. And the third part is preliminary studies on the synthesis and characterization of oligoalginate nanoselenium biocomposite. Selenium is a microelement that functions as cofactor for reduction of antioxidant enzymes in various organisms. It is an essential microelement, micronutrient, I should say, for animal, but toxic in large dosages. So it may have a chemopreventive role in cancer risk as an antioxidant and might trigger the immune response also. There are numerous functions of nanoselenium, as you can see on this slide, and nanoselenium has potential for application to food, cosmetic, and biomedicinal industries. Nanoselenium is synthesized conventionally using ascorbic acid as the reducing agent. The solution turns red as nanoselenium is formed, and a unique peak is observed at about 295 nanometer. Okay, nanoserium, however, was not synthesized by plasma discharge in the solution, in the sodium selenide solutions under various conditions, though. Therefore, we attempted to use the antioxidant oligoalginate being synthesized by depolymerization of alginate as the reducing agent and capping agent for the synthesis of nanoselenium via SPP. So 0.75% alginate solution containing various concentrations of sodium selenide was discharged for various time period, okay, at 800 voltage for 30 to 90 minutes. Okay, and as the results, as oligoalginate was produced, selenide began to be reduced to nanoselenium, as you can tell from the color change of the solutions. However, the peak unique to nanoselenium at 295 nanometer was not detected. Only the peak at 365 showed a slight blue shift to around 353 nanometer in the oligoalginate nanoselenium biocomposites. This needs to be investigated further to examine interaction between oligoalginate and nanoselenium. The XPS analysis of the oligoalginate nanoselenium biocomposite indicate that selenium was present in the form of nanoparticles rather than ions as the plasma discharge time increased. And the structure of the biocomposite varied according to the length of the plasma discharge time. They had multi-layered microfibrillary structures and became more porous sheet-like structures as the discharge time increased. EDS mapping of the biocomposites showed that the nanoselenium particles were well dispersed in the oligoalginate matrix, and the content of nanoselenium in the biocomposite was 1.26 and 1.87 in the biocomposite containing 5 millimole and 7 millimole nanoselenium, respectively. The TEM analysis showed nanoselenium with ununiformed shapes, but mostly in spherical shape with irregular edges. The average particle size was 45.5 nanometer and 70.5 0.5% of the nanoparticles were in the range of 31 to 60 nanometers in diameter. Antioxidant activity of the oligoalginate nanocellular biocomposite was evaluated regarding DPPH and hydrogen peroxide radical scavenging activity and the hydroxy radical scavenging activity. DPPH scavenging activity of the biocomposites were higher than that of oligoalginate and increased gradually as the reaction time extended. Hydrogen peroxide radical scavenging activity of the biocomposite carrying 7 millimole nanocerium was higher than that of oligoalginate, but the biocomposite had hydroxyl radical scavenging activity lower than that of oligoalginate itself. Now, these are the summary of the studies on synthesis and characterization of the oligoalginate nanoselenium biocomposites. Selenate was reduced to nanoselenium by the antioxidant activities of oligoalginate synthesized simultaneously in the reactor using SPP. Synthesis of nanoselenium was confirmed by the color change of the reaction, but no significant change of the peaks was detected except small blue shift of the peak at 365 nanometer in oligoalginate to 353 nanometer in the biocomposite. Okay, the 0.75 oligoalginate containing 7 millimole nanoselenium biocomposite that were discharged with plasma for 90 minutes exhibited excellent DPPH radical scavenging activity that increases gradually during the reaction periods. The hydrogen peroxide radical scavenging activity of oligoalginate was improved by incorporation of nanoselenium particles into the biocomposite. Okay, so from all the results presented today, we can conclude that SPP is a valuable tool with great potential for the development of biomaterials based on biological functional macromolecules. Okay, so these are the members of my research group and the collaborators, including Professor Mubarak Ali at BS Abdur Rahman Crescent Institute of Science Technology. Okay, and thank you very much for close attention for my talk. Okay, now I'd like to answer some questions if time is available.
Good afternoon, madam. Actually, your talk was very good.
Thank you.
I wanted to know about that agriculture. You have just applied that one for that agriculture, this one. So what was the purpose to add there in that? Means I did not got that point. Could you please explain that slide?
I don't hear you very well. So can you tell me which slide you are mentioning?
The agriculture application. Could you please go to fifth slide?
I have a PDF file, so I cannot.
First talk means first part results one.
This one?
This one, yeah.
Yeah.
So may I know the reason that why it was added, means what was the benefit? Results are very good, madam. But only thing just I wish to know that the purpose of adding this one.
Okay, I think there was a report regarding oligoalginate, okay, promoting growth of plant. So I wanted to check that, okay, for the oligoalginate generated or synthesized using SPP. So that's the reason. But it showed very, how can I say, positive results for the growth of lettuce. So I think it can be applied for, the agricultural purposes, even though I'm not, in the field. So,
Okay. Actually, madam, this in slide, this 70 days, and it is written that 60 minutes. So could you please help me to understand this one? 75 days and 0.5%, that 60 minutes is written in that slide. The previous slide only, madam. The agriculture slide only. Yeah. 1 minute. Agriculture slide only, madam.
you mean this
No,
one?
no, no. No, the agriculture one, the same slide which we were discussing.
Yes.
Yeah, this
Yes.
one. This one. Yeah,
Hmm.
it's, could you please see that growth of lettuce, and in this caption there is the third 70 days. You have shown that 0.5% oligoalginate 60 minutes. So
0.5% oligoalginate that had been discharged with plasma for 60 minutes. That's what it meant.
okay, that is a reaction time. But madam, statistical analysis data is there, not there. So I mean to say, it is just a representative, or it is statistically also proved?
I think it has been tried, I think 2 or 3 times, but this slide, this picture is the best one from the, triplicate, try.
Okay, madam, it's a very good work. So I will send you email regarding to understand this work more.
Okay,
So
thank
very
you.
thanks. Very thanks.
Okay,
Very nice
thanks.
presentation.
Actually, Professor Mubarak Ali collaborates with me for these topics. So you can ask him.
Okay, sure.
For more details. Okay.
Sure.
Hello.
Hi, it's howling, so I don't hear you very well.
I am audible, ma'am. I have some
yes,
questions.
Yes, it's better, but can you talk kind of slow for me?
Yeah, I have some questions. Whenever we synthesizing a nanoparticle by using ascorbic acid, there is color change in reddish brownish color, red brownish color. But instead of ascorbic acid, we use our cell-free extract or our plant extract, and the color changes in a blackish color. What you say about that change in color?
These are not. You mean this one, right?
From your slide, not from your slide, from my work. I have question from my work.
Oh, from your work. Okay.
Yes. What is the action of that ascorbic acid or our what about that color change? Whenever we using an ascorbic acid, there is change in color of red brownish color. But while we using our extract, biogenic synthesis, the color change in blackish color.
Oh, really? This is the research. This is the published. This is the research published by other group, and this is the result from our laboratory. But we have not detected any black, particles formed when we use the ascorbic acid. So I'm not sure whether you are using too much sodium selenite, and I'm not sure. And I think it was not, sensitive to light either. Okay, but let me check if we have some. But when we, when we synthesized nanoselenium using SPP, the color was kind of, less reddish than those produced by ascorbic acid. And it could be due to tungsten particles, getting off the electrodes though. But I'm not sure what's happening in your, experiment.
Okay, thank you, ma'am. Thank you.
So why don't you let me know your, conditions of experiment more in detail by email? Then I will, discuss it with my, researcher.
Okay, thank you, ma'am.
Okay. Movie, I don't hear you.
Ma'am, I have one more question.
Mm-hmm.
Can I ask?
Sure.
When we synthesize chemical synthesis of nanoparticles, the results means results coming soon, means immediately changing the color. But when we synthesize biogenic synthesis, there is a little bit problems in that conditions. What do you say about that biogenic synthesis of nanoparticles?
I have not tried either chemical or biological method for the synthesis of nanoparticles, so I may not be able to give you more information though. Sorry.
Okay, no problem. Thank you.
Hello. Professor.
Yes.
Yes. Is there any question from here? No. Professor, it's all done. Can we? So, Professor, thank you so much for your time to present here for attending this conference.
No problem. Thank you for the invitation. Bye. Have a good conference.
It's not audible actually.
and Siriga Samba, Wal and Samba, Nilumaipu Samba. Some of the considerable sporulating fungal endophytes are given below. And the isolates were all the, I have isolated 20 endophytes, fungal endophytes. 8 were found to be sporulating and 12 were found to be mycelia sterile species. And the sporulating forms are given in the table. Like KK, they are called as Pilostica, MC is Fusarium moniliform, P and V1 are Chetomium, V2 is Trastelia australensis, V3 is Chetomium, and SS2 is Aspergillus flavus, SS6 is Aspergillus tamari. And evaluation of fungal endophytes for plant growth promoting characters was studied using following standard procedures. IA is found to be present in all the isolated strains, and the presence will promote the growth and yield of the crop. Ammonia was found to be present in all the considerable sporulating strains, and this promotes the biocontrol agent in the plant. The quantification of IAA was done using standard procedure. It was found to be high in SS6, that is Aspergillus flavus, followed by Aspergillus tamari. And the therapeutic picture of IA production, ammonium production, phosphate solubilization, cererophore production, and hydrogen cyanide production as a plant growth promoting characters were characterized. Salient features of this plant growth promoting characters: IAA, they promote the growth of the plant and crop yield by increasing the biomass of the plant. The isolated fungal strains, they are capable of solubilizing the minerals which are available in the insoluble form, and the cererophore direction assay is done. That shows the presence of orange or yellow colonies zone around the colonies, and hydrogen cyanide and ammonium production from the strains act as a biocontrol agent that offers eco-friendly approach to sustainable agriculture, which acts as a biopesticides, that by promoting the great promise in the improvement of agricultural yields. And the results of the phosphate solubilization, results of cererophore production is given pictorially. And test for hydrogen cyanide production, they act as a biocontrol agent and acts as the best source of biopesticide. And the test for extracellular enzyme production, I have done around 6 enzyme activities like cellulase, amylase, lactase, lipase, protease, and pectinase. Results of cellulase activity showed 100% cellulase activity, which means they can degrade starch in the plant synases. Amylase activity is found to be the 87.5%, and that was found to be lacking in the V3 isolate. Lactase activity was found to be present in only 2 strains out of the 8 sporulating ones. They were found in Fusarium moniliform and Chetomium, and this showed that they oxidized the alpha naphthol and shows the blue color around the colonies. And lipase activity was found to be present in 87.5% of the isolated fungal strains, excluding the V1 isolate. Protease activity was found to be present in 75% of the isolated strains, excluding P and V1 variety. And 100% pectinase activity was found. From the isolated strains, we have different extracellular enzyme activity, which means they are found to be present 100% in cellulase and pectinase, and 87.5% in amylase, and lipase, 75% of protease, proteolytic enzyme, and 25% of lactase enzyme activity. And why we are studying this enzyme activity? In the sense, they degrade the starch by the presence of amylase. Cellulase, they play as an important role in the biosphere by recycling the cellulase. They are present in the abundant when they in the plant photosynthesize. Lactase is a blue copper dependent oxidase that promotes the oxidation of large number of phenolic compounds. And these lipids, they act as an energy source. Proteolytic enzyme, they act as an important role in the fungal physiology and development. Fungal pectinase are important in the phytopathologic process. Summary: have utilized traditional rice seeds from a current study, and 20 different fungal isolates, endophyte strains were obtained as green, and they were characterized for colony morphology, mycelium textures, and pigments of the fungal endophytes were studied. And the 20 out of the 20 strains, 8 were found to be culturable sporulating ones, and 12 were found to be mycelia sterile. And the characterization of plant growth promoting traits were done for all the 8 cultivars which are found to be sporulating. Their potentials of promising extracellular enzymes, thereby actively secreting or merely expressed in few strains. The extracellular enzymes influence the plant host against infection and stimulates the nutritional values. Conclusion: the isolation and characterization of these endophytic microflora from the traditional rice cultivars will open up new ventures and exciting opportunities for crop improvement, thus promoting plant growth and productivity in agricultural crops. Thank you.
Thank you, Sukanti. Several presentation. You told it's a lot of biocontrol agent is producing, right?
Yes, sir.
Even you said hydrogen cyanide also.
Yes, sir.
So what purpose this plant is producing cyclogen?
So when the endophyte are associated with the host, they promote the growth of the plants. When this endophyte is associated, they release some enzymes and they release some acids. When hydrogen cyanide is released,
is it for the plant helpful for the plant, or it is for survival of the particular?
When endophytes are associated with plant, they promote the growth. When the plant is having some adverse environmental conditions or stress.
It's okay. Promotion is different. I'm talking about the enzymes or the components produced by the fungi.
Yes, sir.
Is it for that endophyte or it is for the plants?
They have mutualism between them.
How they communicate together?
Because when the endophyte is released into the soil or with the plant, when they interact with each other.
Is there any communication mechanism?
Yes, sir,
between the fungi and the, what is that plant?
Symbiotic mutualism is there between them.
See, a real example is maybe this molecule is produced for communication. How they interact with each other, plant and the fungi.
When their enzymes are released out, they will turn into this brown color. I have shown the image.
No, that is fine. Producing that's a reaction molecule. Is there any communication mechanism?
Yes, sir.
What is that?
They'll have the interaction when the plant synthesize some enzymes. They'll have the interaction from their abiotic stress can be overruled, so that they'll have the better growth when they act as a biocontrol agent. When this is synthesized, it will promote the growth.
Good, but see, still will not answer the question. Is the fungi or maybe actinomyces, whatever the microbe, they're producing some molecule.
Yes, sir.
That is anyway against the molecule there in the plant, it is color change, all it's happening.
Okay, sir.
It doesn't mean it's communicating, right?
When the plant communicates, only the changes will occur, no, sir. When they interact with each other.
No, I mean the plant is protecting against the material synthesized or produced, right?
Why not the same interaction can promote the growth? No. Like I'm not communicating about the promoting. When they interact with them, the changes will promote the betterment only.
No, that is different. How they communicate. Is there any methodology already proposed or any concept is proposed previously? No.
I'm not aware of it.
This kind of quorum sensing or chemical communication, something like that. No.
I'm not aware of it.
Okay, thank you.
Thank you.
Can you go slide number 9?
Yes, sir.
Slide number 9. You given one graph, and the last one shown high density.
Yes, sir.
So others less. So what's the reason?
IA was found to be higher when this endophyte is having, in spite of all the other 7 isolate, IA was found to be present higher in SS6 isolate, that is our aspergillus flavus. It is when considering the literature part, aspergillus flavus is supposed to promote the growth and biomass of the plant.
Again, the hydrogen cyanide issue is little toxic. The people are using for sulfur as a biopesticides. That are the cases, but the limit is very important. Maybe it's lesser than the toxic level.
Yes,
but it is not advisable to use as a biopesticides, hydrogen cyanide. Generally, people can use for sulfur as a biopesticide. Okay, good.
Okay.
Any questions from audience?
Myself, Dr. Smuthu, from Government College for Women, Puducherry. So you told about the beneficial effect of fungal contents.
Yes, sir.
Is there any harmful effect caused by these fungal contents?
Yes, sir, definitely there will be some fungus which are harmful, but these endophytes, when residing inside the plant pot, will definitely promote the growth.
Endophyte is caused harmful.
As of now, I have not seen, sir.
Then other is I saw about fungal forms produce indolactic acid.
Yes, sir.
What for whether it's useful for fungal or for plants?
Generally, IAA, indole acetic acid, will promote the growth. So we have characterized plant growth promoting traits of fungal endophytes. By considering that part, I have characterized for IAA production of each of the strains.
Yeah, for the benefit of plant, it is producing.
Yes, sir.
What is the benefit of indole acetic to fungal forms?
Fungal, they will definitely promote the growth. As endophytes, they promote the growth and germination of the plant, right? That will definitely have impact.
What's the use for its own?
They'll have mutualism. Endophytes, when residing inside the plant, will have the plant host mutualism. That symbiosis will definitely be there, right?
Indole acetic is not useful for fungal, so only for plant use.
Of course, when somebody is residing on someone, they will have the benefits only, no, sir.
Still, you're not understanding or see whatever is a fungi is producing for their own benefit only. That will be useful for the
host plant.
Host plant. That's it.
Yes,
doesn't mean it will produce a material for the host plant.
It is not producing for the host plant. As it is residing in the host plant, when it is produced, it will be utilized for the host.
Okay. Is there any other question? Anyone wants to ask question? Okay. Thank you so much, Suganti, for your wonderful presentation.
Thank you.
Next to Rashmi from Indiraj College Program. Rashmi, ma'am. Good luck, Rashmi.
Preliminary phytochemical analysis, organoleptic cooking characteristics of Tamil Nadu traditional rice varieties. I'm Rashmi J, PhD research scholar, Department of Plant Biology and Plant Biotechnology, Abdur College for Women, under the guidance of Dr. Kavita, Assistant Professor, Department of Plant Biology in Abdur College. Introduction. Rice is considered as the princess among the cereals as it serves as the food for half of the population in India. The cultivation of rice ranks third in the production of agricultural commodity next to maize and sugarcane. Traditionally grown rice varieties are rich sources of minerals and vitamins. Its nutritional content, anti-diabetic and anti-cancer properties are far better than the commercial rice varieties. So benefits of traditional rice varieties. So excellent source of carbohydrates, good energy source, low fat, low salt, no cholesterol in it, and good source of vitamins, minerals such as thiamine, niacin, riboflavin, vitamin D, calcium, and fiber. No gluten and contains a resistant starch. Medicinal benefits of traditional rice to humankind. It helps in the formation of RBC and contributes to immunity. Vitamin B1 is present, which helps in preventing stomach ulcers, helps in prevention of diabetes, and contains proanthocyanin, which controls hyperglycemia and reduces cholesterol and prevents cancer. Moving on to the study, for selection of traditional rice varieties based on the literature, medicinal properties from literature, and collection of traditional rice varieties from Swami Dayananda Educational Trust, Manchapudi. And the selected rice varieties include Maple Samba SMS, Garvan Samba GS, Arvadam Kurubai, AK, Sigapu Kauni SK, Karupu Kauni KK, Kartianum SKY, and ADT 37, that is the local cultivar. Just comparing the traditional rice varieties with one of the local cultivar. Moving on to the determination of organoleptic characters, according to Shilpa et al. 2010, the traditional rice varieties color, we are just checking for the organoleptic characters, which includes the color, order, texture, and taste or touch. So the color was almost red and shades of red, dark red in the traditional rice varieties, whereas the odor was aromatic and the texture was moderately hard in Maple Samba, Kartianum, and Arvadam Kurubai, whereas in Karupu Kavni, it was literally predominantly hard, and the taste was good. And compared to the local cultivar, the color was white, and the odor was mild, and the texture was soft, and its desirable taste. Moving on to the physical parameters to evaluate the traditional rice grain quality, bulk density, grain shape, and grain length were being determined. So going on to the bulk density, determination of bulk density to determine the grain quality according to Fraser et al. 1978. So the bulk density was found to be high in Garudan Samba and was found to be low in local cultivar LC. And moving on to the grain length, according to the IRRI 2004, so the grain length has been classified into 4 genres, that is the extra long 7.5 above 7.5 mm, and long 6.61 to 7.5 mm, and medium is from 5.5 to 6.6, and short is 5.5 mm. And the results were being found that SK, AK, and LC, that is Sikapkavani, Arvidam Kuruvai, and LC were found to be short size grains, whereas the other was found to be in the medium sized grains. And to determine the grain quality, that's the grain shape. According to IRRI, that is if the grain shape is above 3.0, it is slender. If it is 2.1 to 3.0, it is medium, and 1.1 to 2.0, it is bold, and below 1.1, it is round. In my study, whereas this SK and LC showed bold shaped grains, whereas the other showed the medium shaped grains, that is the MS, GS, KY, KK, and AK. Moving on to the determination of cooking characteristics of traditional rice varieties, 5 cooking characteristics have been determined. That's the optimum cooking time and water uptake ratio has been done according to the method of Bhattacharya and Saubhakya 1971, and Gruville solid loss percentage was done by Bhatt and Rayar 2017. Elongation ratio and cooked rice length breadth ratio was above Oko et al. 2012. Moving on to the results of each cooking characteristics. So the cooking time was found to be maximum in KK, that is 101 minute, followed by MS 91 minute, and found to be minimum in LC, that is 25 minutes, and SK, GS were 44, 57, 71, and 79 minutes has been their cooking time. And moving on to water uptake ratio. So water uptake ratio was highest in AK, that is water uptake ratio, and water uptake ratio was found lowest in LC, that is 2.16. Moving on to the Gruville solid loss percentage, the Gruville solid loss was found to be low in, found to be higher in 0.76% in LC, and found to be lower in KY 0.25, and followed by MS, AK, and GS. Elongation ratio of cooked traditional rice varieties, the elongation ratio was found to be higher in SK and found to be lower in LC, that is the local cultivar. And the cooked length breadth of cooked rice varieties. So the length and breadth was found to be lowest in LC and was found to be highest in GS. So put into consideration of all these 5 cooking characteristics, LC was found to be the lower comparable to the traditional rice varieties. So the cooking quality of traditional rice varieties are far better than the local cultivars. Moving on to the qualitative phytochemical analysis of rice varieties. So preparation of extracts being done, 6 solvents, initially started with 6 solvents based on the polarity based aqueous, methanol, ethanol, acetone, benzene, petroleum ether. But results were found in 4 solvents, that is aqueous, methanol, ethanol, and acetone. And rice seed is being used as the sample. So qualitative analysis of MS rice variety, alkaloids, carbohydrates, saponins, proteins, amino acids, phytosterols, phenolic compounds, flavonoids, terpenoids. All these have been present in the rice variety of MS group. And in GS also the same. Moreover, comparatively, the traditional rice varieties showed the presence of, in this tabular column, that single plus sign indicates the presence, double plus sign indicates predominantly present, and the minus sign indicates the absence. And the presence and all have been highlighted with a red color. So in each and every traditional rice varieties, the alkaloids, carbohydrates, saponins, proteins and amino acids, phytosterols, phenolic compounds, and flavonoids has been present in moreover all the 6 traditional rice varieties, whereas terpenoids, gums, and mucilages are not present in any of the rice varieties. So these are the results for all the rice varieties from, this is LC. So in the local cultivar also the phytochemicals has been present, but flavonoids has not been present. Either terpenoids is present in it, and glycosides are also present in it. So qualitative phytochemical analysis results, that is preliminary phytochemical screening was being carried out for 6 traditional rice varieties and 1 local cultivar as the control. So solvents used were methanol, ethanol, acetone, and aqueous. Presence of alkaloids, carbohydrates, saponins, proteins, and amino acids, phytosterols, phenols, tannins were detected in all the tested rice cultivars, whereas the flavonoids were found predominantly present in the traditional rice varieties, and terpenoids were found in MS, KY, and LC. 2 minutes, sir. And glycosides were found to be present in LC. Conclusion: the rice seed extracts of traditional rice varieties are rich in nutritive value. This study actually examines the preliminary analysis of the rice varieties with 1 local cultivar as a control, and the presence of flavonoids indicates, that is the presence of flavonoids in the traditional rice varieties indicates that the varieties are accepted as therapeutic agents, and traditional rice varieties are far better in the medicinal properties compared to the local cultivars. But one thing why we are not using now, it's because the scientific validation is being not validated. Scientifically, it's not being proved. So this study's future prospects to formulate a nutraceutical formulation using the traditional rice varieties. And the summary. Thank you.
Thank you, Rashmi, for a very good presentation. So you have compared any predominantly used rice variety for me, like so many varieties people are using, right?
I've taken local cultivar LC, I mean ADT 37 as a LC, and I've named something, so that is ADT 37. I'm using ADT 37 as a local cultivar.
Okay.
I'm just comparing the traditional rice varieties with a local cultivar.
Local cultivar. Okay. So how many fold it's better?
Comparatively,
property.
as of now, I just did the preliminary studies. So when I'm moving on to the other studies,
even you told the flavonoids are not present.
Yeah.
Right?
Yes.
In
Sir.
LC.
Yes, sir.
Why? What's the reason?
I guess because of the color, sir. Mostly compare, except Garuda and Samba, all the other traditional rice varieties are colored red and black colored. Karupa Kavani will be in black, others. So the color indicates the presence of anthocyanin present in it. So in our local cultivar, there is no color and anthocyanin will be absent. So maybe that may be the reason.
And also one more, maybe you said cooking time is too much, right?
Yeah, sir.
Usually
Yeah.
Our normal predominant rice will take less than
yes.
the
one lag thing that we are not using the traditional rice varieties in a day to
cook for 1 hour.
No. We should. So instead, if we want to eat traditional rice varieties, means we have to soak it in the night and we have to eat it in the morning. I've tried eating. It's good taste.
Okay. Now taste parameter, who actually
a set of myself and 2 to 3 scholars with a set of panel.
It's supposed to be some expert people, right?
Yeah. As of now, for preliminary studies, I used this. They are in the protocol.
For example, if you do it, you will say tasty.
Tasty.
Right?
Yes.
It's supposed to be a
set of control
already
panels.
known people. They are already certified people who will taste. Maybe better if you do it that way. It will be better.
Dear, should I ask a question, sir?
Okay. So
Hello.
basic question.
Am I audible?
The nutrition is present inside. It's based on the soil. For example, if you are cultivating the paddy here, the same nutrition you cannot expect if we are cultivating near Kaveri River. Okay? So you have taken 12 varieties. Are they collect all the varieties in one particular place?
6 varieties, sir.
Yeah, 6 varieties.
Plus
so
one.
If you are comparing all the things, the soil you have to cultivate in one particular place. If you are taking from one Kashmir, one
no, everything is from that Swami Dayananda. Okay, sir.
So if it is coming for a comparison, so you have to give all the things you need: water, soil, source, nutrition, everything you should give equal. So, but it's based on the place. Apple can grow in Himalayas very well, but not growing here. So then here nutrition's 0, they're high. So please concentrate that area.
Okay.
And also you have taken many actinoid flavonoid tests.
Yes,
So what kind of test you done? Can you briefly explain the confirmation of actinoids, flavonoids?
For flavonoids, alkaline reagent test, sir. These methods has been followed by Harbo 1998 and Sofovera 1993. The protocols which I followed were these protocols for entire test. Starting from alkaloids, it was Mayer test, Wagner's test, Dragendorf test. Yes, sir.
Okay.
Any other question?
Yes, sir. Actually, I am online. Whether I'm online, whether I'm audible. Hello.
Yeah.
Actually, my question is, dear, all these tests you have done is a qualitative test.
Yes.
What about quantitative test?
Did you not in the future? I have to do.
Because this is a PhD, so you need to give a
I have to
quantitative
do.
test also, and some graphs and other thing. Now, another thing is that in your presentation, you have represented that anti-cancer. Actually, first of all, I should introduce. I am from Bangalore and I am a principal scientist in Indian Council of Agriculture Research. So your studies are really good if it is giving some conclusion, because till now it is just a vague. It is not giving any conclusion in quantitative manner. So the thing is that in a presentation you showed that these rice are having anti-cancer and so properties. But what about references? Nowhere in your slide. Could you please show in your introduction slide?
I haven't
First
had it.
slide.
I'll add it.
So then presentation, that reference should be mentioned properly, and then quantitative results are required. And why not you are doing this volatile profiling? Because nowadays GCMS studies is very easy
I have to go. Actually, I'm in my 1.5 years. I have to complete. In this year, I'll be doing the estimations, antioxidants, and other GCMS and LCMS.
Okay, and all the varieties what you have represented, you have purchased from a shop or what you have raised yourself?
Yeah, from a farm, ma'am.
You have from, so it's in a, and this I mean to say that a protocol how to raise all those things, whether it is same or it is different, so all those things also should be included. And in your some studies, I think that error is also, standard deviation and error bar is also not there.
Okay,
so just include all those
yeah,
things.
sure, ma'am.
Thank you. These are incomplete actually. Thank you.
Okay.
Thanks a lot.
Thank you, ma'am.
So your conducted some qualitative tests. Have you done any quantitative tests?
I've done, but I haven't included in the slides, sir. Just preliminary test has been included in it. I'm just working on it. I haven't completed it yet.
Yeah, my question is whether you have done this all biochemical assay using polished or unpolished rice?
Unpolished rice. I'm just buying the seeds, and I'm myself removing the
kernel.
Yeah, and I'm just using it for my studies. Thank you, sir.
Thank you, Rashmi, for your presentation. You have a big round of applause. Next presenter, Isabel Clark. She's from University of London. All the best, ma'am.
you have an idea, is between the size of protein and DNA. So within my research, I used copper oxide. I synthesized copper oxide and I used L-threonine amino acid. So copper was used particularly because there's a great catalytic activity and it's a good semiconductor. And it's already being used in the medical field. They have fabrics within hospitals which are lined with nanoparticle or copper oxide nanoparticles, which are able to prevent the growth of bacteria. And I used L-threonine amino acid because this acts as the ligand in my research, and it's also a novel synthesis. This has not been done before. Just to go over my objectives. The first thing I did was synthesize copper oxide nanoparticles using the amino acid during a by a wet chemical method. I then characterized these nanoparticles using different techniques. This is to understand the structure, the shape, the properties of my nanoparticles. And lastly, most importantly, we had to apply this to understand the antibacterial activity of my nanoparticles and compare this to common antibiotics such as penicillin and ampicillin. So just briefly, just to go over, we used copper sulfate, diluted it with water and L-threonine, and used sodium hydroxide as a reducing agent. And this is the process. The first picture is the copper sulfate. And the last picture is my copper oxide nanoparticles that have been formed. From reading different literatures, we can distinguish that the copper oxide nanoparticles have been formed by the dark color. The characterization that we used, so the UV vis was UV-Vis was used to basically establish that there are nanoparticles present. The FTIR is used to understand the frequency and that the frequency of the my amino acid that has bound. The electron microscope was used to take a picture of my image of my nanoparticle, and the EDX was used to understand the elements that have been formed. So the antibacterial activity was studied, first of all, by agar well diffusion. This is, first of all, to establish that the bacteria actually works, so we know that we can proceed with the next steps. Next was the minimal inhibitory concentration. This is the concentration that inhibits the growth of the bacteria. We then took that data and then used it for the MBC, which is the concentration that fully kills the concentration of the nanoparticle that fully kills the bacteria. And lastly is the biofilm assay, which biofilm is produced by bacteria as a kind of protective layer. And there are a lot of bacteria which are also resistant to the antibiotics that are used. So antibiotics do not work on biofilm either. There's been studies that show that, which is also important that we could establish this. So the first picture is actually an example of one of the plates, my MRSA plate. So you can see the zone, I will go into later, the zone of inhibition that we calculated, but you can see here that it has successfully inhibited the growth. The bacteria strains we used was MRSA, E. coli, Staphylococcus aureus, and KP. So the results, my UV-Vis here confirms that there is a presence of copper oxide nanoparticles. It had a peak at 210 to 275. This was compared to previous literatures, so we understand that this data is what is expected for copper oxide nanoparticles. My FTIR spectra is the frequency of the amino acid that has bound to my copper oxide nanoparticles. So if I just show you here, these are the functional groups of my amino acid. So this has shown that it successfully has bound to my copper oxide nanoparticles. This is my picture of my nanoparticles. So they have a flower-like shape with the width of 100 nanometers, which means they successfully have, they fit into the category of nanoparticles. It's the shape is really supports the mechanism of action that they have against bacteria. So you can see they have very sharp, small edges. So this means that they are able to penetrate the create pits inside the bacterial wall, which could then lead to, as an example here, membrane injury, can cause release of ions, and then it can damage the DNA. And this just supports that my copper is present, oxide is present, and my carbon is also present from my amino acid. You can see at the bottom here that copper accounts for nearly 70% of the weight of my copper oxide, which supports that this is the leading element that is killing the bacteria. And this is just this is the zone of inhibition. So you can see that even at lower concentration, and for both negative and gram positive and gram negative, both have been inhibited. From using the MIC, we created and plotted the data. So the percentages above the gray lines is the amount of growth that grew on my within my 96 well plate. So you can see here that for E. coli, my nanoparticles only allowed 4% of growth compared to the blue, which is the control. You can see that the orange, which is the antibiotic, my nanoparticles have successfully worked better than the antibiotic. Unfortunately, MRSA is resistant to ampicillin, so this is what they're showing here. And then this is the biofilm. Like I said, biofilm is a kind of a natural slime that is created by the bacteria. So it's very important that we test that the nanoparticles are able to also prevent this growth as well. And that was successful. You can see that my nanoparticle treatment is lower than the ampicillin in percentage of growth. So why nanoparticles are fighting antibiotic resistance? So the great things about this and why it will add a lot of benefit to our society is, of course, with the rate of antibiotic resistance increasing, nanoparticles will be able, bacteria will not be able to keep up with the mechanism of action nanoparticles can offer. So with the bacteria would have to require multiple gene mutations in order to overcome the nanoparticle mechanism, which I can confirm is not possible. So in the meantime, we need to slow down the process and educate those around us, and healthcare industries need to understand to not overuse and teach those to not misuse antibiotics. So in conclusion, the synthesis of copper oxide nanoparticles using L309 was successful and did inhibit the growth of E. coli, Cane pneumoniae, Staphylococcus aureus, and MRSA. And due to the small size and large surface area to volume ratio, the nanoparticles can carry out their physical and chemical properties. And this will be, for the future, I hope that this can be the replacement of antibiotics, as unfortunately, as you can see here, this is an estimate of deaths, annual deaths in 2050. In 2050, by 2050, it will increase to 10 million deaths, which is actually overtaking cancer. So yeah, I hope I've put across the importance of this, and thank you for listening. And, yeah.
Thank you, Isabel, for an excellent presentation. So actually, you're used amino acids also, right? So what is the storage condition for your nanoparticle? Is there anything special you need?
About my nanoparticle? Well, copper oxide nanoparticles have been synthesized before, but it's by the process of synthesizing. So the amino acid L309 hasn't been used before in combination with copper sulfate.
I'm asking, is there any special storage condition you need?
Storage condition? No, it's very quick. very quick process.
No, because you have oven acids. It won't be if it is high temperature. It will be nature, right?
Well, if well, just room temperature is fine. Of course, like incubating at 37 degrees is fine, but of course, yeah, if it's too cold or too hot, it will damage the amino acid.
Okay. And also, I see the percentage of bilateral inhibition. It's 250. It's supposed to be below 100, right? Why?
For the MRSA,
Ah.
this one.
Yeah.
Yeah. So I spoke with the doctor who helped me conduct this research, and this data was plotted like this because it's actually resistant to the ampicillin that was used. It didn't form any zone.
No, that's okay. It's supposed to be 100%, right?
Yeah.
Percentage of inhibition.
Yeah.
It's not supposed to be 250, right?
I know. Yeah.
Okay.
Wherever.
Hi.
Hi.
Thanks for your nice presentation. Where did you bacteria?
Why do we choose these bacteria? Well, actually, these bacteria are, as you know, might be a natural flora. So they're opportunistic pathogens. So because of the increased infections that are caused by these, there's increased demand for antibiotics. There's a very high percentage of antibiotic resistance to these. So by using these microorganisms, we're able, it's a step forward to preventing the deaths that are caused.
May I know the zone length? Antibacterial study, you showed from zones.
Zones. Yes.
Yeah, yes. From the zone length, which one is higher?
So actually, K-pneumonia work best actually. Yeah, with the corpuscle nanoparticles.
So from this data, what's your conclusion? Which one is having good antibacterial activities?
Okay, pneumonia is copper oxide is working best with that.
In which bacteria?
In which bacteria? Sorry. What do you mean in which bacteria? Sorry.
The zone length it is shorter and it is a bit long, right?
It works best with a higher concentration.
Yes.
The bigger the zone of inhibition.
And also you should study about the formation and then the anti formation.
Show the bar biofilm formation. The fourth MRSA.
Yes.
The control biofilm formation is low, but after ampicillin treatment, biofilm formation is more. The fourth MRSA.
You remember this one? It's increased.
Yeah. Well,
yes. I will get back to you on that one.
Control is 100.
I'm going to be honest.
But after ampicillin treatment is going to more than nearly 250 after 48 days of treatment.
Yes. I'm going to be honest with you. I will come back to you on that one. This is all very new to me. It's my first time plotting this and everything, so I will confirm and get back to you with an answer.
Another thing is, you not using copper antibiotics, usually for treating the vegetables, fruits, antibiotics, copper sulfate. Not a copper oxide is superior than copper sulfate. Superior, copper oxide is superior to copper sulfate.
not sure which one's superior.
Shankari madam is a HOD. She's not here. She's gone for lunch, I guess.
Okay.
She's a new
Document submission for new admission.
I think these people are also waiting for this.
No, you haven't selected that organisms in your work.
Okay.
You have used MRSA, E. coli staph,
Yeah.
and pneumonia.
Yeah.
So Pseudomonas aeruginosa is better opportunistic.
Okay.
And these all organisms will have a quorum system. I would like to suggest that you check the anti-quorum system.
Okay. Thank you.
Activity of your it's better than the antimicrobial resistance.
Okay.
Because antimicrobial resistance is provided by the quantum sensing of the organisms. So I would like to suggest to look into that method.
Okay, that's really interesting to apply actually. So thank you for that.
Yeah. Thank you.
Thank you.
Thank you. We do a big round of applause. Now, invited talks will happen in the SLS block. Okay. Yeah, you can check the names outside displayed. it'll be after the lunch, you can come back. 2 o'clock. Okay. 2:15. It's fine. 2:15. Okay. Okay. Thank you. Thank you for your attention. So lunch will be served in the canteen.
Hello. Hello. Am I audible?
Hello. 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 Very good afternoon to everyone. Now we are going to have our guest lecture by Dr. Mukesh Dobul. Actually, we are postponing the oral and e-poster session after the guest lecture. So please.
Welcome back everyone for afternoon session. So we're gonna start with the excellent guest invited talk before the presentation. The talk is going to be given by Professor Mukesh Dobul. He's from IIT Madras. So when you see his profile, it is very big. I would say he has more than 45 index. You can imagine how much quantum of work he has done, contributed. And he has more than 246 publications. And he has won a lot of awards. And so today's topic is going to talk about nanoparticle related topic. So it will be very relevant to this conference. So I'll cordially invite you, sir, Mukesh Dobul, sir, for your talk. And we're all waiting for your knowledge to gain the knowledge. Thank you, sir. Yeah.
Now, Dr. Karthikeyan will honor Dr. Mukesh Dobul.
Good afternoon, everyone.
Change that side.
Good afternoon, everyone. Let me thank Dean for the invitation and for the kind words of introduction. I'm going to talk about design of polymeric nanoparticles for drug delivery applications. We have looked at several nanoparticles. Depending upon the time I will like to spend. So if you look at drugs, they call it lead candidates. Most of the drugs, when they move from the laboratory to the final market, many of them fail, as shown here. Many of them have poor absorption, distribution, metabolism, excretion properties. Some of them show toxicity and lack of efficacy. So almost 95% of the drugs which are developed in the lab, when it comes to the clinical trials, fail. Okay, because of poor absorption properties, maybe toxicities, maybe doesn't have the efficacy. That means it would have got degraded and so on. So that's where your drug delivery system comes into play. There is a very important concept called oral bioavailability. Okay, whatever we take orally, the amount of drug that reaches the target site, there is a big difference. So you may be having an inflammation in the hand. So you take a ibuprofen of certain quantity, but the drug takes a very long path to reach the target, right? So it goes through the stomach. The pH of the stomach is almost 2. So it's very, very acidic. Drugs may get degraded. It has to be soluble at that pH. Then it gets absorbed, reaches the bloodstream, and then it has to reach the final target site, wherever the inflammation is. So many things happen. The degradation of the drug because of acidic pH, the lack of absorptions, then going into the bloodstream, and so on. So the quantity of drug that reaches the target site is much, much lower than what is orally taken. And that's called oral bioavailability. Okay, so generally the oral bioavailability has to be high. If the availability is high, then you need to give only small quantity of drug. For example, if you take metformin, it's got, you all know what's metformin for as an anti-diabetic. The oral bioavailability is 74%. That means 74% of the drug goes and reaches the target site. Whereas if you take some anti-malarial drugs, for example, they have very poor 30%. That means more drug has to be given so that it acts at the target site, which leads to toxicity. If you take some anti-cancer drugs like Taxol, Taxol is an anti-cancer drug. It's got very poor oral bioavailability. So these are some problems. That's why many of the drugs before they reach the market fail because of poor oral bioavailability, maybe toxicity, and so on actually. And that's where drug delivery systems come into play. Can we encapsulate these drugs using some polymeric system, which will carry the drug without creating toxicity, also having good solubility, does not allow the drug to degrade and then deliver the drug at the target site. That's where this type of drug delivery, polymeric drug delivery systems come into picture. I'm going to show you some systems where we have worked on. Okay, so when we have a drug delivery system where it's encapsulated in a polymer and the drug slowly gets released as the polymer starts degrading, so you can use minimum concentration at the right time to the exact target site. So instead of drug traveling from the GI, from the stomach, GI tract, going to the bloodstream and then finally reaching the target site, can we have the drug delivered at the target site? So, and that's how the targeted drug delivery comes into picture. And normally when you look at how the drug concentration is in the plasma, we take some drug, it goes to the bloodstream, so the concentration goes up. And then drug gets eliminated because of biotransformation, because of liver action, and so on. So the drug concentration goes down. So for example, if you look at this graph, concentration goes up in the bloodstream, and then it starts coming down. And then again, we take another dose of the drug, again, concentration goes up, comes down. So you have something like a cyclic. So if the elimination is very fast, then you need to take the drug more often. Sometimes the doctor says take every 4 hours. If the elimination is very slow, drug remains inside for a longer time. So sometimes doctor says take drug once in a day. Maybe the elimination is much slower. So the normal way when we take drug, always the concentration goes up, then comes down. So it's a very cyclic process actually. It goes up, sometimes it goes up very high, maybe it's toxic, and then it goes down very low. It is not acting. Okay, if the concentration is not sufficient for it to act. This type of cyclic things happen. Whereas when we have a targeted delivery, you can see the bottom graph, and slowly the drug gets released as the polymer degrades slowly. So you will have a constant concentration of the drug available in the plasma region, unlike the normal cyclic type of concentration changes actually. That is the normal. Whereas when you have a slow release using some sort of a polymeric system, the drug concentration will remain constant. Okay, that's what we would like to achieve actually, rather than this type of very high concentration or very low concentration. Okay, so the drug release mechanism, there are different types of mechanisms available. Diffusion type, drug gets slowly diffused from the polymers. Polymer degradation, the polymer will start degrading. If I use a biodegradable polymer, there are many synthetic biodegradable polymer, natural based biodegradable polymers are there. So the polymer will degrade and slowly it will release the drug. So how will it degrade? It can go into some sort of a hydrolysis type of reaction. Okay, so there are enzymes are there in our bloodstream like lipase, esterase, which will help in the slow degradation of the drug, degradation of the polymer, and the drug can get released. So there are different mechanisms we can think of. Enzymatic, because of, the bloodstream will contain protease enzymes, lipases, esterases. So we can design polymers which will allow the enzyme to act on, degrade the polymer and release the drug slowly actually. So the polymer will degrade, become smaller and smaller. The drug which is encapsulated will start slowly getting released actually. So that's how the mechanism is. You can also have the surface of the polymer just degrading, not the bulk, just the surface, and then release the drug. For example, if you have a wound healing drug, we can have a patch, wound patch, and the polymer will degrade slowly at the surface and release the drug at the surface. Okay, so you can have a surface type of degradation, or you can have a bulk polymer degradation. Both are possible if you are looking at the wound healing systems or if you are looking at drug delivery systems. Okay, so different types of designs can be made to achieve this type of release of the drug from polymeric system. Okay, so many factors play a role. Polymer composition, molecular weight of the polymer crystallinity. I will not go into each of the release medium, physical size of the matrix. So many different properties we can play around and design polymers. I would like to show you a small case study. This is in collaboration with the Christian Medical Center in Vellore. So they load meropenem. Meropenem is a broad spectrum antibiotic into polymethyl methacrylate beads, and they keep the beads inside where there is a lot of infection, especially after a trauma or after an open wound. So the drug gets released slowly and it reduces the infection. But the polymethyl methacrylate is not biodegradable. So once the drug is completely removed, they have to remove the polymethyl methacrylate beads also. So that's a big problem. So they were looking at some biodegradable polymers also. So see this type of open wound where after a fracture you have an open wound, a lot of infection, staphylococcus related infections are there, which will form. So they keep, as you can see in the second picture here, they keep these drug loaded, meropenem loaded PMMA inside, and then they sew it up. The drug gets slowly released and it will control the infection. But as I said, PMMA is not biodegradable. So they have to remove the PMMA beads once the infection is gone. So we were looking at some biodegradable polymers to work on. So we looked at something called polylactic glycolic acid. So this is a polymer with two monomers, lactic acid and glycolic acid. So glycolic acid is more hydrophilic, lactic acid is more hydrophobic. Both are biodegradable. Glycolic degrades faster than lactic acid. So we can play around with the composition of lactic and glycolic to control the degradation profile very effectively. Okay, so it's a high glycolic and less lactic. So it's more hydrophilic and it's faster biodegrading product actually. So I'll not go into the synthesis of this. This is what the right hand side, this is polylactic acid structure, you can see, and this is the glycolic acid. So we end up with polylactic glycolic copolymer actually. By adjusting the composition of lactic and glycolic, we can get different ratios of lactic glycolic. We can make it very hydrophilic, and we can make it more relatively more hydrophobic by having more lactic. If you have more glycolic, it can become more hydrophilic. Okay. Let's not go too much of this. Too much of characterization is there. So we looked at how the drug gets released. With time, the x-axis is time. You can see this is the polylactic acid release of meropenem. Top one is polylactic glycolic acid based system where the drug gets released. So we can achieve a higher drug concentration, that is more antibiotic concentration in the system. Then this is the degradation profile of the polymer. The top one is polylactic acid, bottom one is polylactic glycolic acid. So the lactic glycolic combination gives you a better degradation profile. So more polymer gets really degraded in 30 days. So more drug also gets released in 30 days actually. Okay, so the beauty of it is we can adjust the lactic to glycolic concentration so that we can get different degradation profiles. We can make it degrade faster or we can make it degrade slower. Okay, so the released drug, we look at its antibiotic property against E. coli, one of the pathogens. And then we see that the lactic glycolic system seems to work better than a pure lactic system actually. So you can see the weight of the polymer goes down with time, 30 days. This is just the polylactic acid and this is polylactic glycolic acid. So the weight goes down much faster. Particle size also goes down much faster in 30 days when compared to just plain lactic acid. That means more drug gets released in the 30 days and we are able to control the infection also better. And the beauty of it is these polymers are biodegradable. So you don't have to perform another surgery to remove like in polymethyl methacrylate because polymethyl methacrylate does not degrade. Okay. So this is a very interesting problem where we can play around with the composition of the monomers to achieve either more or slightly less degradation. So we can achieve higher rate of drug release or slower rate of drug release. So instead of working with a non-biodegradable polymer like polymethyl methacrylate. So we tried to mathematically model that. So the polymer slowly gets eroded, and as it gets eroded, slowly the particle size of the polymer goes down with time. So whatever drug is entrapped gets slowly released as a function of time. Okay, so that is the mathematical model concept actually. So we can develop a mathematical model and see how the mass of the polymer nanoparticles reduce with time, starting from an initial mass. I will not go into the derivation of this model, but this modeling helps you to understand whether the mechanism is through erosion of the polymer or the entire polymer gets completely dissolved. Okay. Erosion means slow release of the drug, or the entire polymer gets eroded. That means the drug gets released as a burst. You don't want it as a burst release. You want the drug to get released slowly over a period of 30 days, because generally in orthopedic infection, they are looking up to controlling the infection within 30 days. But then we started working on something called cyclic glucons. These are produced by organisms, Bradyrhizobium japonicum. They produce different types of cyclic glucons. You have glucose closed as a ring. We can have different glucose units actually. No? 14, 17, 15, 16, 17, 18 like that. And we can have different way the glucose units are connected. So we can call it 1,3, 1,6 connection, how each glucose is connected. These are called cyclic glucons. They are water soluble, produced by bacteria. So they are biocompatible, they are biodegradable, and they also have cavities inside. So we can put in drugs inside these cavities. That's the beauty of the cyclic glucons. So we have worked on this. They have a hydrophobic pocket, so we can put hydrophobic drugs inside. Solubility problems are taken care. These are some transmission electron microscope images of cyclic glucon with the combination blended with other polymers as such. Because cyclic glucon is water soluble, we want to reduce the water solubility a little bit. So we add some other polymer to reduce the water solubility actually. So by modifying the combination of cyclic glucon with another polymer called PLGA, we get different combinations of polymer which can improve the drug encapsulation. Okay, so from 79% drug encapsulation, we can go up to 93% drug encapsulation. Okay, almost 42% of the drug is encapsulated per gram of the polymer. So by playing around with the cyclic glucon and PLGA, we can achieve very high drug encapsulation. So we tested these encapsulated drug on, these are some TM pictures of the same thing. Let's not go into that. Yeah, so we tested this on animals. We wanted to see how the pharmacokinetics in rats look like actually. So we gave these drugs to animals, and we followed the concentration of the drug as a function of time, okay, in male blister rats. Okay, so you can see the concentration initially increases as the drug concentration increases in the blood, and then it starts falling down. So by encapsulating the drug, you can reduce the amount of drug that gets eliminated from the rats. That means you can keep the drug longer when it is encapsulated with the polymer when compared to an encapsulated drug. So that's another advantage when we encapsulate. We can reduce the amount of drug that gets eliminated from the body for a much longer time. That means drug will act for a longer time when compared to just giving the drug alone. That's what we found out from these animal studies actually. So that's one of the advantage of encapsulating drugs with biodegradable polymer rather than just injecting the drug to the animal. So these are some pharmacokinetic parameters which can be calculated. Pharmacokinetic parameters like volume of distribution, maximum concentration that's reached, maximum concentration that is reached, and the time at which maximum concentration happens, clearance, that means how fast the drug gets cleared from the bloodstream. All these can be calculated. So we feel that we can achieve very high drug stay in the plasma when compared to an encapsulated drug. So we get longer clearance time. That's what is the conclusion when we carry out this type of animal studies with encapsulating drugs in biodegradable polymer. So we wanted to look at how the drugs interact with this type of polymers which have a cavity inside, cyclic glucons, they have a cavity, the drug is inside. You can have hydrophobic, different types of hydrophobic drugs, right? So there is an interaction between the drug molecules with the cyclic glucon. So we wanted to look at it. So we performed some computational studies called molecular dynamic studies. These are molecular dynamic studies. So the polymer is a cyclic beta glucan. So it's got a cyclic and it's like a donut. You can see that. And then we looked at different drugs encapsulated inside and then looked at how these drugs interact with the polymer, the glucose units in the polymer, cyclic glucan. These red colors are oxygens and the whitish ones are the carbons actually. Hydrogens are not shown here. So different types of drug depending upon how, what type of hydrogen bonds it has with the glucose units of the polymer, what type of binding energy they have. You can see that they have different binding energies. And depending upon the binding energies, when you compare it with the experimental, the binding energies seem to correlate well with how much drug gets encapsulated. So we can use this type of molecular dynamic study to predict whether a drug will have better encapsulation in the polymer or whether it will have a poor encapsulation in the polymer. Okay, so by carrying out this type of molecular dynamic study before actually doing experiments. So good binding energies indicate stable complex. Okay, so negative correlation. So there is a correlation between binding energy and the hydrophilic properties of the drug, molecular weight of the drug, and so on actually. So by looking at the properties of the drug, we can predict whether the drug can be encapsulated well with the polymer or not. Instead of doing experiments, we can predict using these type of computational molecular dynamics tool. That's the conclusion which we have reached from this type of study actually. Okay, so we wanted to spend more on the computational study on designing what polymer is needed for what drug. So you may have different drugs you want to encapsulate, you may have different polymers which are biodegradable. So do you have to do experiments every time, or is there any way of predicting if I have a drug, can I say this polymer system will work well? So we tried to attempt that using some computer-aided approach, using molecular modeling approach actually. So what we did was we picked up 3 drugs, doxorubicin, okay, it's an anti-cancer drug, silmarin, it's a liver-related drug, glycoside is an anti-diabetic. And then we took up 6 polymers, alginic acid, sodium alginate, eudagrate, 2 types of then gantries, chitosan. Some of them are biodegradable and some of them are not biodegradable. Okay, so we took up 3 drugs, we took up 6 polymers. So we have 18 combinations. We did experiment to see the encapsulation. And then we tried to see from the properties of the drug, from the properties of the polymer, can we predict how much the drug will get encapsulated. That's what the whole study was actually. So experimentally what we do, we prepare one drug with one polymer and see how much gets encapsulated. So we do all the polymers. And then similarly, we take another drug, then another drug. So we have 18 different combinations of drug and the polymer encapsulation. And then we look at the physical properties of the drug. And then we look at the physical chemical properties of the polymer and see whether there is a correlation between them and the encapsulation efficiency. That was the study about actually. Okay, let's not go into that. So we mathematically, we molecular model the polymers, we model the drugs, and then we see the interaction, mostly non-bonded interactions like electrostatic forces, hydrogen bonds, van der Waals forces. And then we calculate the interaction energy. That's the sum of all these. And then see what is the correlation between the interaction energy with the drug encapsulation, which is done experimentally. Okay. So these are some pictures of molecular modeled drug and the polymers. Some polymers are like a bulk polymer, some polymers are like a strand, and they form long chains. You can see from them. Okay, then we found out the entrapment efficiency. This is experimental. There is a correlation with the drug hydration property. That means hydrophilic nature of the drug. That is one parameter. Another parameter is entrapment efficiency, which is experimental parameter, and the interaction energy between the drug and the polymer. That means what is the interaction energy between the drug, which is here, and the polymer. Interaction energy means van der Waals forces, electrostatic forces, hydrogen bond. Okay. So two parameters like drug hydration energy and the interaction energy between drug and polymer have a good correlation with the experimental entrapment efficiency. Okay, that's the correlation we found. So the nanoparticles were prepared in the usual way, and then these are some experimental data on particle size, dispersivity, and then what is the entrapment efficiency. That is this particular column actually. Okay, so our encapsulation efficiency. So with different polymers, the doxorubicin, which is an anti-cancer drug, you have different entrapment efficiency. You can see varying from 82% going right up to 10%. With chitosan, it's very, very poorly getting entrapped. Whereas with this particular polymer, Gantres, 82% is getting entrapped, doxorubicin. If you take another, these are some molecular modeling pictures. Okay, so and like I said, the hydration energy of the drug, which is the hydrophilic nature of the drug, and the drug polymer interaction energy is correlating with the experimental entrapment efficiency. And these circles, you show the correlation coefficient. So minus 0.6, that means higher the hydration energy, the entrapment efficiency goes down. So more hydrophobic the drug is, entrapment efficiency is better. More hydrophilic the drug is, entrapment efficiency is lower. Similarly, drug polymer interaction, it's a positive correlation coefficient. So higher the interaction, more will be the entrapment efficiency. Lower the interaction, less will be the entrapment efficiency, as expected actually. So these are some graphics of that, same thing. So hydration energy decreases, and then it's increasing. And then similarly, if you see the entrapment efficiency also goes like this with encapsulation. So we can develop a mathematical regression relation, the entrapment efficiency, that's the experimental, both with interaction energy and hydration energy of the drug. So this equation is very useful because if I have a drug and if I have a polymer, I can calculate hydration energy of the drug. I can do molecular modeling and see what is the interaction energy. I can substitute in this equation and I can predict what could be the encapsulation efficiency. Predict, okay, based on this data. So it can help you before actually going into lab to identify whether this polymer will work well for this drug, or some other polymer will work better. Okay, so that's the advantage of this type of model actually. So this is called a regression model. Yeah, this is the fit of the regression model. So we also tried a neural network approach to do the same modeling. So again, the hydration energy and interaction energy are the independent variable, and encapsulation efficiency is the dependent variable that coming on the top. So this is a neural network with one hidden layer and two elements. So this is the structure of the entire neural network. This is called a back propagation neural network. Then again, it can predict the encapsulation efficiency by using these experimental data. And we see this neural network model looks better when compared to the regression model actually. The regression model has an advantage because it looks very simple, it looks very practical, whereas in neural network, it looks like a black box where you have to try to predict the encapsulation efficiency. So two different types of models we can use to predict the encapsulation efficiency, which is the experimental value, and hydration energy is the drug hydrophilic nature, interaction energy is interaction between the drug and the polymer. Okay. So advantage is we can use this model a priori to predict what will be the encapsulation efficiency without actually testing it out in the lab. That's the main advantage. So I showed you a lot of different types of studies where you can use modeling, computational tools to predict a drug release. You can predict computational tools to find out the best polymer, which can be used for encapsulating different drugs based on the drug properties and the interaction between the drug and the polymer. So it can be used as a predictive tool, theoretically modeling a drug polymer combination. So when I have a drug, what type of polymers will be better to use? So the polymers could be synthetic or natural, because I showed you synthetic as well. Chitosan is a natural polymer, and so on actually, right? And also we can use it as a screening. So if I have 2-3 polymers and I have a drug, I don't know which polymer to use, I can use this type of approach to say, okay, this polymer may be better than this polymer. Okay, that's the advantage of CAM. Okay, so in drug delivery, it's going to be delivery drugs through implantable devices. So there are already some drug delivery systems are coming where when the glucose level goes up, automatically it should be sending in insulin or some anti-diabetic drug. So, and then it will not be doing it every time, but only when the glucose level goes up. So the delivered drugs through implantable devices in response to a measured blood level. Okay, so glucose level goes up, then only it will work. Otherwise, it will operate. Otherwise, it will not operate. That sort of. Copolymers with desirable hydrogen.
बहुत अच्छा प्रेजेंटेशन दे रहा है आईआईटी चेन्नई का प्रोफेसर है और करीब 200-300 पब्लिकेशन है इसके पॉलीमर के ऊपर चल रहा नैनो पार्टिकल.
Okay, so deliver drugs only when there is glucose level goes up, and then other times you don't have to deliver. So that is one approach. So that sort of smart delivery systems will happen. Copolymers with desirable hydrophilic hydrophobic nature. I showed you simple like a gallic acid lactic acid combination. So we can achieve very different hydrophilic hydrophobic nature. We can achieve different degradation, so different delivery rates also. Block or graft polymer. So a lot of research can be done on polymer design, which will have all the necessary properties, which are biodegradable, which are biocompatible, which will not have cytotoxicity, which will easily enter, which will be able to encapsulate drugs in a very high efficiency. So there is a lot of possibilities of research in this area. Complexation network responding via hydrogen or ionic bonding. Dendrimers, so polymers which have dendrimeric type of structures. So we can have many drugs attached to them. So that is another approach. New biodegradable polymers always there. New blends, hydrocolloids, carbohydrate-based polymers. Because carbohydrate-based polymers, whatever I showed you like glucons, they are sugar-based polymers. Then can we think about other type of protein-based polymers and so on actually. So there is a lot of scope to do research in that area also. So controlled delivery, controlling the time, controlled properties like hydrophobic, hydrophilic nature, as well as degradable nature, reduced cytotoxicity. So there is a lot of scope to work in this particular, and targeted delivery. Can I target to the liver? Can I target to say enzyme, protease type of enzymes in say coronavirus type? Can I target to a particular tumor cell instead of generally going to other parts of the body? So like that, can be targeted. Can I put in ligands which will have the targeted delivery on top of these biodegradable polymers? So that is another exciting area where there could be a lot of scope for doing research as such. So with that, I will conclude. Okay, yeah. So finally, acknowledgement, all my research scholars, Dr. Geeta, Dr. Nandakumar, Dr. Anju Nair, Subhashini, all of them who had contributed considerably in this, and also my collaborators and financial support. Thank you very much for your time.
Thank you so much, Professor, for a wonderful talk on polymeric nanoparticle. So the session, if you have any questions, you can ask it. I have one question, Professor. Is it any polymer material is available to encapsulate liquid material without changing the properties of the liquid? In nano level.
In nano level.
It's a micro, it's already available. Capsules are there.
So far, I cannot think of. What we do is we always make it into solid by spray drying or lyophilizing, and then we put it inside. But we have never worked on liquid.
Yeah, because we tried it many, but we made it to some liquid capsule, but it's not that great.
Yes,
Nano level.
Nano level you won't get it.
Micro level it is possible, but I don't know, say polymer.
Agglomeration problems will be there, and then slow release, slow diffusion out is there. If it is solid, diffusion won't be there. Liquids, if you make it more viscous, then chances are better.
So same modeling can be applied to find out this polymer. Is it possible? Sir?
Yeah, it is, it is possible. So basically, we are looking at interaction between the liquid, whatever compound, and the polymer system. So it's possible actually.
Thank you, sir. Is there anyone has a question?
Yes, sir. Hello. Hello.
Yeah.
Yes.
I am audible, sir.
Yeah.
Good evening, sir. Good afternoon, sir. I have one query about the ketosane biopolymer. Ketosane is a biodegradable polymer, and ketosane has various biodegradable activity and slow release activity. But I have a query about whenever we stabilize ketosane with our nanoparticles, then what is the mechanism behind the stabilization of ketosane to our targeted nanoparticles, and how to predict our ketosane is get stabilized or bind to our nanoparticles?
Yeah, ketosane has a charge, right? So if you have a complementary charged drugs, the interaction is much higher. Whereas if you have hydrophobic type of drugs, the interactions will be lower because of the charge that's present on ketosane. So that is one rule of thumb which you can follow. So any charged drugs will nicely bind to ketosane if it is in a complementary charge.
Okay. And I have another one question. There are so much biopolymers, but what is your opinion about ketosane?
Chitosan has been used widely for a long time. That is why it's been a lot of research papers will be there. But now there is a lot of interest on, because chitosan is an animal derived product. So there is now a lot of interest on non-animal derived products. That's why there is interest on other polymers. Like I showed you some cyclic glucons, glycons. So non-animal derived. So there is quite a lot of interest in that area. So one day it may get replaced, because chitosan is widely used for a long time and a lot of papers are there. So immediately I will also start using chitosan. But there is an interest now to move away from animal derived products.
Okay, thank you, sir.
Good evening, sir. Thank you for wonderful talk. So, using molecular dynamics approach, is it possible to study the colloidal stability like beforehand, even preparing the nanoparticles? Like I can understand that it's telling you the binding energy and hydration energy. But what about the colloidal stability? This computational analysis will give that details also?
Colloidal stability comes because of one of the basic energies like van der Waals or electrostatic or hydrogen bond or charge-charge interaction. So if you go down to that basic calculations of interactions, yes, it's possible to do that.
And what is your opinion about negatively charged nanocarriers? Like polydopamine is ionic polymer, and it is still used for as a drug carrier, like coming up. Like with the compared to comparison.
So if you have negative charge, of course, the positive charge drugs will bind better rather than hydrophobic type of drugs. So you have to select that sort of drugs.
What about the cell uptake, sir? Like what is your opinion on cell uptake of negatively charged carriers?
So you're asking about whether it is through passive diffusion or active uptake.
Will there be better cell uptake when compared to cationic carriers?
Yes. Definitely it can be better actually, but you have to see which drugs will be complement with respect to the charge, right? So that problem is there. Especially when you take charged polymers, it will work only for complementary charge. Hydrophobic drugs won't bind and get encapsulated as much. So that problem is there.
Thank you so much for all of you. For want of time, Professor is available. If you want to interact with him, you can always welcome to the chat. Thank you, Professor, for your wonderful.
Thank you, sir.
So we have the next invited talk. The next speaker, Dr. Sudhir Ravindran, the faculty from Health Sciences and Life Sciences of the Eastside University. So he complete.
Oh. Okay, thank you so much. It's very privileged to introduce Dr. Srijit Ravindran. Srijit, are you listening? Right? Hearing?
Yeah, I can hear you.
Yeah, okay, thank you. He's an assistant professor from Biotechnology, School of Health Sciences, Health Life Sciences, Crescent University, Middleburg, UK, and also research group leader from disease-specific research and biomanufacturing, National Horizon Center at the same university. He's graduated in the School of Life Sciences, Bio-Nanoscience at Bio-Nano-Electronics Research Center, Toyo University, Japan. And he's a professional, actually he's an assistant professor at the same university and is a project coordinator from the India-Japan Bio-Nano mission in IIT Delhi, and visiting researcher from Toyo University, and is got awarded the very prestigious award as a Marie Curie Fellow from the University of Britain, UK. And he's worked as a JRF, SRF from various universities. and he received the fellowship of Research Excellence Framework from University of Britain and the Strategy Committee from various agencies and also European Commission. He's a next fellowship from the Ministry of Education, Japan. So also getting the PhD and PG students, and have plenty of paper in his credit, which includes nanoscale, RSC, small structures, materials, nano research, oncogenesis, and biological macromolecule and so on. With this, I'd like to welcome Professor Srijit Rabindran to give his views. Thank you.
Thank you so much for the great welcome that I had now. Thank you so much once again for having me here today for this presentation. I'm sure my voice is audible to all of you.
Yes, sir.
Okay, great. So because the camera doesn't show any of the faces and it's not showing the crowd over, so I was just wondering, like, I'm just not talking to a space. That I hope you can see me all. After the nice introduction and the great talk by the IIT Madras professor, I'm glad I just joined half way between his talk, and it was quite good to see a lot of work going in IIT Madras regarding the drug delivery and a lot of polymer related works. I could see only last few slides, but it was really nice presentation, the professor. And so to begin with, I'm going to share my screen now. Oops. Can you see the screen?
No, sir.
Hello. Hello, can you hear me now?
Yes, sir. Your voice is audible.
Sorry for this interruption caused. Okay. Can you see the screen now?
Yes, sir.
Yes, sir.
Okay, cool. Okay, great. So once again, thank you so much for having me here. So, at the moment, I'm as an assistant professor in biotechnology from School of Health and Life Sciences, Teesside University, Middlesbrough, UK. So the topic, I understand that it's all based upon nanotechnology and biotechnology as the theme today. And I also understand that it's between Indo and US. It's just because of Dr. Mubarak Ali. He invited me. He has been inviting me to give a talk to Crescent University since 2019 while I was in UK as a Marie Curie Fellowship. But after a couple of years, I came to IIT Delhi as a project coordinator for Toy University and in IIT Delhi. And at that time, it was totally blocked up with this COVID-19. So I couldn't come down to Crescent University to give a personal talk. But after those 2 years, and Mubarak was continuously calling me to give a talk, and I'm so happy to give a talk at least through this online platform today. And definitely when I come to India next time, I will try to come down to Crescent University to meet you all guys. So I'm really happy to be here today once again. So the topic which I'm going to deliver today is about the combinatorial nanotherapeutics and pharmaceutical and bio-nanotechnology. And as I mentioned, currently I'm assistant professor and a group leader in disease-specific research and biomanufacturing in National Horizon Center, Teesside University. So to give a gist about my career path, after my post-graduation in microbiology from Bharatidasan University, I did all my college in Bharatidasan University and Bharatiyar University. So basically, I did all my studies in Tamil Nadu. So after completing in 2007, I just started working in a couple of pharmaceutical industry. One was in Chennai, and that was like as a junior research associate in ABL Biotechnologies from 2 years. And then I moved to AstraZeneca Pharmaceuticals. So before that, I was like extraction of various pharmacologically active ingredients from like algae, cyanobacteria, fungi, and dealing with different types of fermenters for making pharmacologically active ingredients like pigments, polysaccharides, fatty acids, etc., etc. So these were in my early career days. I was working with these companies, and after that, I just moved to AstraZeneca Bangalore. At present, we don't have that R&D there. It was completely shifted to Sweden and UK. So there was working in the drug discovery and infection pharmacology for the development of tuberculosis drug. And while I was working in AstraZeneca, I got this prestigious mixed government fellowship for doing my PhD in Japan. Then I moved to Toy University, and then I completed almost like 4.5 years of postdoctoral research in Japan. And there I was actually trying to bring a new field of research that brings extremophilic microbiology into nanotechnology. So that's why I just introduced a polymer-based nanoparticle system for drug delivery applications. For that polymer, I extracted the polymers from extremophilic bacteria, especially from halophilic bacteria that lives in the high salt concentration. And those polymers were used for nanotechnology application, different types of nanotechnology applications like drug delivery, tissue engineering, biosensors, and etc., etc. So I will give a gist of those things in my coming slides. Then after doing postdoctoral research in Toy University for almost like working in 8 years there, I got two different options. One was in the Johns Hopkins University Hospital in US as a postdoctoral fellow under the guidance of a very well-known neuro-oncologist, and he's actually one of the top 5 neuro-oncologists in US for oncology research and brain tumor therapy. And another option I got was the Marie Curie Fellowship from European Union. So with these two options, I chose the Marie Curie Fellowship, and I moved to UK in 2017. And while I was working in UK as a Marie Curie Fellow, a couple of years there, I had a lot of collaborations and industrial projects and collaboration with European companies and etc., etc. So we just got really exposed to it, and there's a lot of potential opportunities for expanding your academic research into potential and commercial applications as well. And then after this Marie Curie Fellowship, I was invited to join as a project coordinator for Indian Institute of Technology, Delhi in India in 2019. for a project in India, Japan project, which was between the Toy University. And I was working there prior coming to UK this year. And after 2 years, then I just got this assistant professor position in Teesside University and joined here this year. Well, you can see my career graph here. The first I started in India, then I moved to UK, then moved to Japan. From there, I moved to UK and again back to India, and then from again back to UK now. So once we see about the international established research network, so this is what, like, a lot of international collaborations and research network have been established across different countries. And the very remarkable ones are like in the Imperial College, then Coventry University, Kingston University, NTU Singapore, then Thomas Jefferson US, Mayo Clinic, Rice University, Texas A&M, then Germany. Then in India, we have like Sri Chitra Institute of Medical Science, then IIT Delhi, then many universities from Japan and from Oman. So it's quite a lot of wide exposure of the research expertise and collaborative network being established. And to come to give just about the Teesside University. So Teesside University is actually one of the most renowned university from northeast of England. So at the beginning, I was actually based at the southern part of UK. So which is like Brighton here, which is down to London, which is Brighton is also known as London by Sea. So University of Brighton was here, and then now I'm actually based upon the northeast of England, and Teesside University is actually located here, just down to Scotland. And we have got two campuses for Teesside University. One is Middlesbrough campus, which is the main campus. And now we have Darlington campus, which is actually a research-based medical campus. And we have National Horizon Center. You can see the picture here. This is a Center of Excellence for Bioscience Research, which we have like newly built in 2019. And this is the Middlesbrough campus. And here we have all sort of like state-of-art facilities for doing medical and bioscience research as well. And we are going to have a new building coming up here for the medical university platform. So this is actually the about the Teesside University. And when I talk about my research strength in nanotechnology and biotechnology, so my lab actually focusing on targeted nanomedicine, nanobiotechnology, theranostics, and pharmaceutical biotechnology. So the targeted nanomedicine is nothing but the combination therapeutics for cancers. We are focusing on that. So this is something that we know that the cancers can be how notorious, and still we don't have a complete solution for tackling this disease. So we have like chemotherapies, we have immunotherapies, we have hormone therapy. So there are quite a lot of therapeutics we have developed for this cancers, but still we are having that metastasis, or the occurrence of cancer is increasing. So with that in mind, I've been focusing on combination therapeutics. For example, like how we can include this different modules of therapies into a single platform. For example, chemo, immuno, adjuvant modules together, or bringing hormone therapy together. So likewise, when you combine different modules of therapeutic things into one platform, it will be quite helpful for the cancer cells to be tackled. So that is one of the areas that I'm focusing in. And the second one is actually the and that includes the personalized medicine as well, like nanotoxicology, etc. So here in UK, we have a lot of personalized medicine strategies being developed. For example, like gene therapy, then cell-based therapy, then CAR T cell therapy. So there are different types of therapies being introduced in UK, especially in the NHS. So, like NHS is actually the National Health Service here, and it's everything under the NHS, the clinical trials that are happening, the preclinical trials and everything. So we are trying to introduce a lot of personalized medicine for the patients by taking medicine from patients and then trying to sort of what sort of treatment can be introduced to those patients, etc., etc. So that comes under the targeted nanomedicine. Coming to nanobiotechnology. So that's actually just like how I was mentioning, like extraction of biopolymers and small molecules from different sources of natural habitat, for example, extremophiles or algae or fungi or bacteria or plants or animals, etc., etc. So it's like extraction of biopolymers and pharmacologically active ingredients, and trying to use it for the development of various biotechnological applications. And next is about the development of prodrug therapeutic vaccine models. So we are focusing on nano vaccines as well. So just like how we are doing the combination therapeutics, we are focusing on therapeutic vaccines as well. And I'm glad to tell you that the nano vaccine that we have developed, I mean, that came to the market by AstraZeneca, which was developed just next to the facility of Teesside University, which is, you might have heard of the AstraZeneca vaccine. So that vaccine was actually produced in a bulk, like the company scale production was taking place in the facility, which is close to the Teesside University campus, which is CPI. And theranostics is another application, like, like optical contrast agents for imaging. So there are different types of imaging platforms being used for cancers and other diseases. So we can use different theragnostics, including biosensors and nanoparticles like quantum dots, magnetic nanoparticles, then fluorescent nanoparticles, etc., can be used for theranostic applications. And then 3D printing of cells for bionano-sensors fabrication. This is something that we have been working with Japan and IIT Delhi, and it's for identification of the nosocomial infections in hospitals, etc., etc. And coming down to pharmaceutical biotechnology, this includes the bioprocess technology for extracting API, as I mentioned earlier, but this includes a large-scale production using fermentation as well. And that is what my teaching expertise is also involved. So I teach in all these subjects. And this includes extraction and application of pigments, proteins, antibodies, polysaccharides, etc., etc. So coming to a typical work that was published in 2019. So as I mentioned, so tackling the cancers is very, very difficult. So what we are trying to do is, like, we are trying to incorporate different types of modules in a single stretch, and then trying to target the cancer cells more specifically compared to more passivated way or more passive way. We are going for an active way of targeting these cancer cells. So in this particular work, what we have done is, like, we have developed the nano cages. The actual nano cage was developed by a group of scientists from Georgia Tech University in US. That was in early 2000. But the technique involved a 24-hour incubation period or chemistry that is involved in it for the synthesis. But here we have used a microwave techniques, and we have reduced that 24 hours time into 4 seconds. So within 4 seconds of time, using the microwave, we have made nano cages. So we have a template of nano cubes here, silver nano cubes, you can see here. And from that, we are converting into nano cages by chemical reaction, galvanization reaction of galvanizing from silver to gold. And after that, we do a lot of passivation using a polymer, adjuvant polymer, which is extracted from extremophiles, as I mentioned, moron. And then we target with the 4-hydroxy-tamoxifen drug. And then we make a multi-targeted nano structure. So with a central nanoparticle coated with a polymer onto a surface, and then onto it, we are incorporating the drug. So, and then we add an antibody, which is specifically targeting to these cancer cells. And that was here is anti-TROP2 antibody, which is specific to the, which is overexpressed in breast cancer cells. And to our surprise, this TROP2 antibody is something which is present not only in breast cancer cells, but it is found in ovarian cancer cells, cervical cancer cells, etc., etc. So that shows that by choosing a target which is common to different types of cancer cells, it is very effective of therapeutic targeting, irrespective of whether the cancer is based upon breast or ovarian or prostate or cervical, etc., etc. So our aim is actually to target something which is uniformly going and binding to all sort of cancer cells. So a common cancer target can be used here. So, and we were successful in that. And so you can see here, this is actually the high resolution TEM image of a single nanocube with a whole image sender. And we can even fill this whole, the cavity inside this nano cage with drug or with a thermosensitive polymer as well, or we can just go onto the surface of it. So because the inclusion of the drug inside has caused the very less yield of the product, so we try to incorporate onto the surface of it. And this is the typical schematic representation of this drug. Well, when we go for studying it, we found that there's 2 different pathways being used by this nanoparticles to kill cancer cells, which is actually type 1 cell death and type 2 cell death. So type 1 cell death is nothing but the apoptosis. You might be familiar with this word apoptosis. It's a programmed cell death of cells that takes place in our body. And autophagy is nothing but it's a different, like a type 2 cell death, which is actually being in most worst scenarios, autophagy causes a reason for the development of the resistance by the cancer cells. So what we're doing is like, we just tilted this mechanism and we interfered with the pathway of killing mechanism in autophagy. And rather going to a resistance mechanism, we just use this autophagy into a useful killing mechanism, which is actually a parallel killing of the cancer cells using type 1 cell death and type 2 cell death. So apoptosis and autophagy will be taking place simultaneously in the cancer cells, and it will be killing the cancer cells. So this can be understood with different, this can be identified using different types of molecular analysis, assays, Western blot, etc. Apart from that, we have did a very interesting imaging process using the confocal microscopy and high resolution TEM. And you can see that the all intrinsic toxicology that happens after the treatment with nanodrug can be visualized using transmission electron microscope. So these images, which shows a clear-cut information about the cell biology and subcellular interactions of these nanodrug inside the cancer cells. And this work was published in Nanoscale Advances as a back cover page. So this was in 2019 while I was working in Japan. And the same work you can see here, like, so this is actually a video. I hope you can see the video. Is it running or is it still this one? Hello? Can you just hear me?
Yes, sir, you are audible.
Okay, cool. So I was just wondering whether this video is working well there.
Yes, sir, it's working.
Fine. So if you closely watch this video, you can see that there is big black clusters of nanoparticles being seen. You can see here, this is actually a typical lysosome. And this is another lysosome that got fused. So two lysosomes, when they fuse, they form an autophagosome. So autophagy is a process that try to engulf the dead organelles as well as the lysosomes which are actually damaged. So this is actually a defensive mechanism being used by the cells. For example, if somebody is going to attack us, so we always go for a defense mechanism, right? So in the same way, when the cancer cell is being attacked by the cancer drugs or the nanodrugs, automatically the cells, just like any other cells in the body, they'll start doing a defense mechanism. And autophagy is a kind of defense mechanism which they bring to target these cancers, cancer drugs, and fight against them and try to bring a resistance against it. And this causes the relapse of cancer or metastasis of cancer. So how we are targeting this autophagy process and how we are tackling this defense mechanism as a mechanism that can be used for killing the cancer cells. That's the interesting part of this work. Okay, so because these gold nanoparticles have a property of changing the acidic parameter inside the lysosome into basic. So what we do is like the nanoparticles once, especially the gold nanoparticles. Why we chose gold nanoparticles? Just because we have the proof that these gold nanoparticles have the tendency to change the mechanism, pH mechanism inside lysosomes. So when the lysosomes go and interfere with these gold nanoparticles, what they happen is like these gold nanoparticles inside the lysosome, they try to turn the alkaline phosphatase enzyme and they denature it and they try to interfere with the pH mechanism of the lysosomes, and the lysosomes are no longer act as a suicidal bag for killing these foreign bodies. So what will happen? Then these lysosomes will become defective lysosomes, and these defective lysosomes are being engulfed by the autophagosomes. And because there is no active enzymes present inside the lysosome, so the autophagosomes cannot complete the process called autophagy. So what will happen? Then there will be an accumulation of these autophagosomes taking place inside the cancer cells. So too much of autophagosomes and apoptotic bodies engulfing, starting accumulation inside the cancer cells can lead to autophagic cell death. So this will enhance the process of type 1 cell death, apoptosis, and type 2 cell death, autophagy cell death. So this is how we are trying to bring a parallel killing mechanism with the help of gold nanostructures inside the cancer cells. And when you watch closely, apart from these lysosomes, you can see that there is like these structures. They are nothing but the mitochondria, they are also getting damaged by these cancer cell structures. And you know what? Why these particular mitochondria are being attacked by these nanoclusters is because in breast cancer cells, certain receptors that is present in mitochondria, because we are targeting to a receptor which is specific. The drug that we use is for hydroxytamoxifen, which is commercially available drug for breast cancer, and which is 30 times more toxic than the tamoxifen that being used for breast cancer therapy. Okay, so this tamoxifen drug, they interact with the estrogen receptors present on the surface of breast cancer cells. And apart from that, we have a lot of estrogen receptors present on the surface of mitochondria as well. So these nanoparticles, they interact with these ER receptors, estrogen receptors, and they try to engulf the inside the mitochondria. And you can see here that there is a lot of like interaction. You can see which we have actually closely monitored with the help of the transmission electron microscope. If you watch this image, you can see here that the nanoclusters are actually being present here, and it is scorching the surface, the cell wall of mitochondria. And this is actually the segmented three-dimensional visualization of this mitochondria. And you can see here there's the yellow box. This is nothing but a typical nano cage with a drug is scorching the surface of the mitochondrial cell wall, and it is trying to get inside this mitochondria. So this shows that our targeting is more specific towards mitochondria and endoplasmic reticulum, and the treatment that we are trying to introduce is also a success. And as I mentioned, when we are choosing the best biomarker in all biomarkers, we can see that how specifically we can deliver cancer cells with the drugs, for example, breast cancer and ovarian cancer, etc. And this work is actually a huge collaboration between industry and academia. So to our university, we had a collaboration with GEOL. So you might be knowing GEOL is actually a company that introduce a lot of laboratory instruments like microscopes, then XPS and different types of instruments. So GEOL is actually a giant of laboratory instruments. So we had a collaboration with them. And the thing is, like, GEOL was using actually the results that we developed from our project is actually used for the commercial marketing of their instruments. That was the collaborative motto from this one. And the segmentation and the separation of these images and all these software analysis was done with GEOL and Texas A&M University from US. And still we are having the collaboration, and we'll be publishing soon a couple of papers, which is actually in its submission stage. Something similar to this three-dimensional visualization. And we have used, and to make these kind of videos and images, we have used serial block phase scanning electron microscopy. So which is nothing but we make the sample inside resin, and that resin is actually being sectioned with the help of ultra microtome. And then what we do is we just stitch these all images together to make a three-dimensional image. And then with that, we make the videos as well. So it's very easy to find out at the three-dimensional space where these nanoparticles or where these nanomaterials are being engulfed, or where it is present, whether it is interacting with mitochondria or with lysosome or with nucleus or any organelle that we are interacting. So it's very easy to understand the three-dimensional visualization by this. Coming to its another work, this is a very interesting work that we did long before with IIT Delhi. So before going for any sort of therapies, we need to understand the bioinformatics behind that. So if you are going to target a cancer cell or any disease, we need to know whether the drug or the nanoparticle that we are going to use is going to bind to that particular cells or not. So for that, what we do is we do a lot of bioinformatics work. And we do an in silico model for understanding whether the target or the novel biomarker that we have chosen will go and interact with these cancer cells and it binds perfectly or not. So for that, we do the in silico model of TROP2 breast cancer network, and then with the triple cancer breast cancer cell line as well. And we, after finding out that whether the chosen novel biomarker has got a good hit, and if you're trying to hitting that particular biomarker, whether the cancer cell can be subject to a cell death properly, etc., or do we need to include some other targets as well? So likewise, so with this study, we found that breast cancers can be killed with the help of TROP2, but at the same time, if you are trying to incorporate another target as well, IGFR1, a dual target, then the cancer killing can be more effective. So that's what the result that came out from this data. And this data is not published so far, and we are still working on this one. And this was a work which was conducted between IIT Delhi and Toyo University, Japan. Again, coming to this work. So I just mentioned about the nanotoxicology and cancer biology. So here you can see that the same way here, if you closely watch here, this is actually the high resolution TEM image of a typical cancer cell, breast cancer cell. And you can see the clusters of gold nanoparticles being entering inside the nucleus as well. So this is the nucleolus, and it is getting clumped, showing that the death process has started. So here, if you closely watch here, you can see that the square shape, the cube shaped nanoparticles being bound to the mitochondria, the cell wall, and different parts of the subcellular entities. And once after doing the three-dimensional visualization, so as I mentioned, we make this cancer cells. After treating these cancer cells at different stages, we chose the cancer cells and we embed inside the resin, and then we go for sectioning. And this work is actually also done with the serial block phase scanning electron microscope. So you can see here, this is a typical mitochondria being segmented, and you can see that the nanoparticle is binding to the surface of these structures. And then this is actually another small vacuole which is present inside, and it demonstrates how specifically these nanoparticles, once it is entering inside the cancer cells, they are interacting with different type of entities inside the cancer cells. Okay, so and this is actually the autophagosome or the lysosome which I mentioned. So you can see the cluster of gold nanoparticles being present, and we can easily segment this and find out the difference, the different 3D conformation or orientation that takes place with the help of focused ion beam scanning as well as serial block phase scanning electron microscope. So there are different side of, so I'm sure that scanning electron microscopy and transmission electron microscopy is actually the base of microscopic visualization in nanotechnology. But these two microscopes are something which is more sophisticated and which is most modern, which is called the serial block phase for finding three-dimensional view of it. And we can use for three-dimensional EDS analysis as well. So for example, if you're using a nanoparticle inside the cancer cells and you're doing a 3D analysis, so which will give you an idea about where these elements are present in the 3D conformation or the 3D space. So so far we've been doing in 2D. So we'll get 2D images or 2D mapping. But when we are using this serial block phase or focused ion beam scanning electron microscopes, and then we do an EDS analysis, we can find out that where exactly these elements, gold elements or silver atoms or platinum or any elements or from the drug or anything. So we can find that it is present in any part of this 3D interstices. And this work was recently published as a cover paper, cover image or cover design of small structures in 2021 recently. And this is also a collaborative work between Geol, Toyo, and Texas. And coming to this one, to show about the nanotoxicology and advanced microscopy, as I was mentioning. So this work is actually based upon focused ion beam scanning electron microscope. Focused ion beam. The previous one was on the scanning, serial block phase scanning, and this is focused ion beam scanning. So here you can see here. So if you closely watch this video, it is self-explanatory. So this is actually a typical cancer cells, and you can see a lot of mitochondria, nucleus, Golgi bodies, endoplasmic reticulum, and we are actually trying to do a segmentation and try to find out where these elements or where these nanoparticles are exactly going in once after doing the nanotechnology, nanotherapeutics. So targeted drug delivery, we do it, and we go for finding about the cell toxicity using MTS assay or Alama Blue assay or any sort of assays that we do. But the thing is, like, what exactly is happening inside the cancer cells? That's what my interest was about. So we know that once we do a targeted drug delivery, the things will go and kill the cancers. And sometimes it doesn't kill the cancers. It can go to the relapse, or it can go for metastasis. So my interest, or our interest, was exactly is why these cancer cells are actually relapsing and what makes them relapse. So that's the thing which we focused here, and we find out once we are targeting these cancer cells, where these gold nanoparticles or where these nano drugs are actually going, and where these are interacting, and what makes the cancer to come again. So that is the reason, in order to understand the base or the root of the cancer cause, until we find that, we cannot treat the cancer disease. So that's what we are looking into. So we're trying to find out what causes the cancer to relapse. So that's why I know like autophagy is a reason. Autophagy is one of the process that gives resistance to the cancer cells. That's why when we are treating the cancers with exactly the same drug again and again, it causes only the side effects, but it doesn't kill the cells, rather than it is causing a resistance to cancer cells, and it is relapsing, and it is going and metastatizing to different parts of the cancers. So in this particular video, you could see that all the green is actually segmented mitochondria inside the cancer cells, and the yellow clusters are nothing but the gold clusters. So you can see that the gold clusters with the drug is specifically going and accumulating in the mitochondria of breast cancer cells. At the same time, when you watch here, you can see that this actually a complete complex image of segmented image of cancer cells, and you can see the green is mitochondria, the purple is actually the endoplasmic reticulum, and the yellow and the purple is actually the lysosomes or autophagosomes. And we stitch together all these images to get a complete complex cancer cell, which will be like this. So you can see that the yellow gold nanoparticles are interacting with almost all sort of subcellular entities. And this work is actually a huge collaborative work between Troy University, MEXT, and FEI, Thermo Fisher Scientific. These guys, they also develop different types of electron microscopes. And I got a chance to visit their facility in Tokyo, nanoport facility in Tokyo, and these kind of segmentation was done from China, Shanghai Nanoport. So it's a huge collaboration that happens between industries, academia, and different countries, etc., etc. And these work is yet to be published. Well, coming to the Marie Curie work, which was funded by European Union. In this work, what we did is we just were addressing the glioblastoma. Glioblastoma is something which is a brain tumor, and it is something very dreadful, and the survival rate is just 5%. So so we were targeting the brain tumor, and we know that brain tumor can be treated only if once the drug can cross the blood-brain barrier. So the crossing the blood-brain barrier is something very, very difficult thing. So because gold is actually a noble metal, and gold is actually so far considered as not toxic so much compared to other like silver or iron, etc., etc. So we use gold, and because of the size, it is very easy to cross the blood-brain barrier. As we reduce the size of this gold nanoparticles to below 70 nanometers or 100 nanometers, and with proper appropriate tagging and targeting moieties, we were successful in crossing the blood-brain barrier. And we found that there is quite an interesting results of killing the cancer cells, glioblastoma. And we did the animal work with this, and this work is still under the review stage. The work is still under publication in Cancers. And this was the work that I did during my Marie Curie fellowship. And the collaborators include like European Commission, University of Brighton, Pharmadex, Troy University, then etc., etc. So quite a lot of handful of research institutes and universities. So, well, what we did here is actually, we chose the same gold nanoparticles, gold nano cages. And what we tried is like select a cancer drug, which is less bioavailable. For example, here we used 5-fluorouracil, and 5-fluorouracil is basically used for colon cancers, stomach, peptic cancers, all relating to the ulcers. So these kind of cancers are generally being treated with 5-fluorouracil. However, 5-FU has got a lot of side effects, which is not beneficial for us. So in order to overcome that, like scientists are trying to incorporate this 5-FU in a different way. What we did is actually we're trying to make the 5-fluorouracil in a prodrug formation. For example, we have chosen the same extremophilic bacterial polysaccharide, and we try to make a prodrug out of this 5-FU. And we are incorporating this 5FU as a chloroacetyl moran and tagging with 5FU to make it more effective in the treatment. And then after making this prodrug, we try to incorporate into cancer, gold nano cages. I'm sorry. Okay. I think I'm running out of time. Okay, cool. I'll just be fast. Okay, so this is actually the mercury work that we did, and targeting the cancer cells with the prodrugs, and it gives a very impactful results as well. And this is a similar kind of work that we did with the NTU Singapore, which is actually using the gold nanoparticles. We are trying to target the cancer that causes an eye, and we can image it. We can enhance the imaging, biomedical imaging, using photoacoustic imaging process. So this was also published as a cover page for Nanoscale. And this work was between Nanyang Technological University, Singapore, and Toh University. And this is also very interesting work that we published. And just skipping this one was an old work, which is biosensors and theranostics. Am I exceeding the time limit? Hello?
Yes, sir.
Okay, cool. I will wind up now. So likewise, we have a lot of biosensors and theranostic applications we can do using this biocompatible polymers. Same with the different other polymers extracted for different applications like tissue engineering, drug delivery, etc., etc. And finally, coming to the collaboration. So we have a wide range of collaborations available between UK and India. Not only with UK, we have like China, Japan, and European countries, and US, etc. So there are few opportunities for Indian students who can, if you are interested to work in UK or European countries for PhD or postdoc opportunities, we are welcoming the students. You can go to internet and you can find out these are like Wellcome Trust, BBSRC, MRC, Innovate UK, KTP Associate Funds, Royal Society of Chemistry, and Marie Curie Fellowship, Newton Fellowship, and Commonwealth Fellowship from Indian government. So there are a lot of opportunities for students to work with us. So if you are planning for your future to work in UK for doing PhDs or postdocs or something, you are most welcome to apply. And in fact, I'm happy to collaborate with Crescent University, and we have already had a discussion. Dr. Mubarak has discussed with me to internship for students. I'm happy to take interns from India for students. If you're interested to work with me, you can come here for short-term projects for 6 months or something. So it's quite open. So, well, that's all from my talk today. So once again, thank you so much for having me here. And it's my pleasure being one of these invited speaker for this session. Thank you so much once again. Have a good day.
Okay, thank you so much, Dr. Srijit. Is there any question from the participants in Zoom or here? Yes. So, Srijit, you have one question from the...
Yeah, please.
Thank you for wonderful talk, sir. So you were telling about gold nano cage, and you're able to localize it in the cell. What about polymeric nano cages? So you can do the same with them also?
Well, that's a good question. So in fact, the mechanism behind the targeting is like polymeric nanoparticles. Sometimes it depends upon what mechanism of intake is taking place. So for example, polymeric mechanism, we are using polymers, which are quite common, which is quite familiar with this cell mechanism, because polymers are nothing but they are biomolecules made up of carbon, hydrogen, nitrogen, oxygen, etc., etc. So it is basically biomolecules. Compared to other nanoparticles like inorganic nanoparticles, like metal nanoparticles, they don't be considered as a foreign body. So basically, these polymeric nanoparticles will be considered as a biomolecule, and it will be recognized by the any cells as a friendly, bio-friendly one. The only thing is that the drug that we are using is sometimes can cause as a foreign body, and it recognizes as foreign, and it will start the defense mechanism will start work on it. So I think even with the polymers, you can do this. So because there is no contrast between the polymer and the, because both are biomolecules. In the case of metal nanoparticles, we have a very good contrast in TEM and other things, other microscopy things. So that's why we can able to identify where these nanoparticles are going in. But I'm sure that when you're using polymeric nanoparticles, it will have a tendency to engulf and it will start disappearing inside the cells by delivering its cargo. So it's very difficult to identify these polymers inside the cells. But I'm sure that you can identify if it is like an inorganic nanoparticles. Is that your question?
Yes, sir, that's my question. I'm also curious to know, like, is it possible to target a particular organ like mitochondria?
Yeah, of course you can. Of course you can do that, because the target moiety is nothing but the drug. So the drug that you choose should be something very specific to the novel biomarkers which is present in mitochondria or endoplasmic reticulum. So you have to have a clear picture about what targets or what are the novel biomarkers that are present in different subcellular organs. I'm not talking about the surface of the cancer cells, but inside the cancer cells. So we have a lot of subcellular organelles. For example, Golgi bodies, mitochondria. So we have receptors in those subcellular organelles as well. So if you are choosing a drug which is specific to those subcellular markers, then definitely you can target it.
Thank you so much, sir.
My pleasure.
Is there a good question? Okay, if not, then thank you so much, Trijit, for your wonderful time given for us. So the participants in Zoom can join in any of the Google Meet which is provided in the schedule for the student presentation. So the Zoom window will be closed. The participant can join any of the Google Meet links that provided in the schedule for the student presentation. Thank you so much for joining. Tomorrow, link will be this. Yeah, tomorrow's presentation link will be shared by today's mail. So please follow it. Thank you.
Good afternoon, everyone. My name is Enrica, and I'm a former student at University of East London. I'm here on a placement of 6 weeks doing research on nanomolecule. So today I'm here to show you my project. It's about the synthesis of nanozinc particle using amino acids against both gram-positive and negative bacteria. So nanoparticle are materials that needs to have a surface 100 nanometers or less. These particles are usually used in drugs, to drug therapy or in gene therapy as well. So why did I choose zinc oxide? Zinc oxide is known to have stronger microbic effects and also is highly used in tumors therapy as well. Also, he has high biocompatibility and low toxicity. So the objective of this study are the synthesis of the zinc oxide nanoparticle using L7 amino acid. Next, we characterize the particle through a series of spectrometry techniques, for example, UV visible, FTIR, FESM, and ADX. Next, we're going to study the antibacterial properties of zinc oxide nanoparticle. And we're going to compare the zinc oxide against control treatment, which is ampicillin. So as I said, the methodology is going to be for the synthesis, wet chemical methods. Characterization is going to be done through spectroscopy, and then we're going to do the application with MIC, MBC, against MTCC bacteria strains. So the synthesis, as you can see here, we had solution A mixed with solution B. They gave us the clear liquid in the beaker. When we added the ammonia, we had a color change. So from see-through, we have the white color in the beaker. That suggests that the zinc oxide might be present in the solution. Next, we stir the solution at 40 degrees Celsius and we centrifugate the solution. So this left us with a solid pellet, white in color. And then at the end, you can see the pellet only with water. So that's the final solution that has been applied in the further studies. So characterization, this is the first study we did, is the UV visible. As we can see, there is a peak in 210 nanometer. This indicates that the particle has been successfully synthesized. And also, because the color is white, also this suggests the correct synthesis of the particle. Next, we have FTIR. So from this graph, from this analysis, we can see a really sharp peak at 3226, which is the OH stretching. Also, we can see C double bond O stretching at 1581. And single bond H, vibration frequency at 1410. These are mainly the functional group present in my amino acid. So this means that the zinc oxide has been coated by the ligand and therefore is a proof that it should be synthesized properly. So the image you see is the FESM. It shows the shapes of my molecule. The shape is a nanorod shape, and as measurement we go for 75% nanometer width and 600 nanometer length. So because the width is less than 100 nanometer, my particle classifies as a nanoparticle. Also, the shape is good for drug delivery and also in electronic. From the graph, the EDX graph, we can see that the zinc oxide is the greatest compound present in the graph with 45%. That means that is that zinc oxide that's working and showing in the further studies I'm going to show you. So, for example, here in the MIC, we can see, so the orange represents the control, so that's only the bacteria. The yellow is the bacteria treated with ampicillin, and the green is the bacteria treated with nanoparticle. So as we can see, in all these bacteria, the nanoparticle inhibited for Bacillus subtilis 85.61%. For Salmonella, inhibited 91%. For Enterobacter, 88%. For Enterobacter, 95%. And for Pseudomonas, 96%. So this is almost double than the antibiotic used ampicillin. Next is antibiofilm assay. So
time up, need to faster.
Okay, sorry. So antibiofilm assay, we can see also that it has greater impact on gram-negative bacteria, especially Enterobacter and Pseudomonas aeruginosa, which ampicillin almost didn't have any effect. So as summary, as we can see, the nanoparticle has been successfully synthesized and it has been of great effect against both gram-positive and gram-negative bacteria, especially against the last bacteria, which ampicillin didn't work. Therefore, it's worth going through this path for further studies and the healthcare applicancies. And thank you very much for this university and the University of East London that has allowed me to come here and work on my research. Thank you very much.
Thank you, for excellent presentation. So, you sum of your nanoparticle, if for example above 600 nanometers size. So if your bacteria is 500 nanometers size, what will happen?
Sorry, if the bacteria is what size?
500 nanometer.
5 nanometer. I'm not sure if I can answer this question now.
Okay.
Yeah.
Mostly bacteria are 1 micrometer. Most of the size bacteria, if it is, they're not growing better, even if we 500 nanometer size, 500 to 1000 nanometer size. So if it is bigger nanoparticle, it can't enter, right?
Yeah, I guess.
Yeah. So we have what do you say your what novelty?
So the novelty of this research is the ligand we use. So we use an amino acid, which is L-serine, and it doesn't have any research before. And we chose this amino acid because it's highly bioavailable. And also zinc oxide has some issue dissolving in water, and L-serine is hydrophilic, therefore it can make the zinc oxide more suitable and more soluble in water.
So if when you're adding amino acids, do we need to have any special storage condition for your nanoparticle?
Well, as is an amino acid, it cannot stay at really high temperature and really low temperature because it can be deteriorated.
Okay, thank you. So any question from audience? No. Okay, thank you.
Thank you.
Thank you. You are a good one of class. Next, Francis Jahan, George.
Hello. Myself is Francis Jaganraj. I'm doing my first year PhD in Biomaterials University. I did my work evaluation of phytochemical and antioxidant and anti-diabetic potential of plant Miliosa nilagirica in the bioprospecting lab of botany department in Biomaterials University. This is my first year work. I'm just presenting my work here. As introduction, we all know Ananusi is one of the plant families with the most potent antioxidant and hypoglycemic activity. The secondary metabolites from the medicinal plants of genus Miliosa are renowned for traditional uses and pharmaceutical potentials. Until now, it has been reported it consists about 60 species distributed throughout India, Bhutan, to Australia and New Guinea, but mostly found in mainland in Asia. However, there has been not much focus given to the assess the value of this genus to best of our knowledge. As I said earlier, the chemical constitutions derived from the Miliosa have fallen into multiple classes of compounds such as alkaloids, flavonoids, terpenoids, and etc. And it has some various activity like anti-herpes, cardioprotective actions, anti-diabetic, cytotoxic activity, etc. I have chosen this plant particularly because of the location of this plant. This plant it is now available in hilly regions of Western Ghats, and this is a systematic question. As you see, yeah, my objective of the study done till now is the collection and extraction of the plant leaves and investigation of for a preliminary and phytochemical and the quantification of the polyphenolic contents and basic antioxidant, anti-diabetic, and qualitative and quantitative analysis through HPLC. And this is my experimental design. This study is involved bringing out the basic screening and potentials of underutilized plant, which is endemic to the hills of hill regions of Wayanad, Kerala. Now I'm presenting the results. This is the basic phytochemicals and approximate analysis of my extract, which as we can see that it contains plenty of carbohydrates and flavonoid and flavonoglycosides, which will be helpful in evaluating the antioxidant potential of the plant. As we move on further, the total carbohydrate content and total starch content shows the same. Now, after that, I assessed total phenolic and flavonoid content, which says as the precursor for the anti-diabetic, antioxidant activity, from which I have taken two types of extract. Basically, I've taken the traditional Soxhlet method and other ultrasonic sound separation of the leaf extracts of leaf powder in solvents like polar petroleum ether, ethyl acetate, and methanol. These are the three solvents I have taken, and two types of method, sonication and soxhlation method. From this, we can see that mostly the sonication method is proven to be effective. Next, we move on to antioxidant assays, from which we can see both the sonication and soxhlation method. The percentage inhibition of the methanolic extract seems higher, and in the ABTS scavenging activity of leaf shows the sonication method as a well eluded method compared to traditional Soxhlet method. I have done other ferric oxide reducing power and phosphomolybdenum reduction. In both these assays, the sonication method proven to be better than the Soxhlet method, from which two ethyl acetate and methanol extracts have higher activity. The other antioxidant assay is a nitric oxide radical scavenging activity, from which, as I said earlier, ethyl acetate and methanol extract of sonication method is proven to be, it's shown to be higher of activity. And these are the standards I have compared with. I have done a single anti-diabetic assay, from which from this is the same sonication method proven to be highly effective than the traditional Soxhlet method, from which the ethyl acetate shows 75% inhibition when compared to 90% of positive control. And this is my well plate. Next, HPLC analysis of the plant extract is shown here, from which I have compared with standards like rutin, gallic acid, comaric acid, naringenin, quercetin, etc. From which we can clearly see that the rutin and caffeic acid act as a precursor, approves the antioxidant potential of the leaf extract, where the naringenin proves the anti-diabetic effect of the leaf extract. From this work, I concluded that the evaluation of in vitro antioxidant and phytochemical and preliminary analysis of this Milius and Illegrica are proven to be effective, and the HPLC analysis shows the presence of antioxidant and anti-diabetic activity. From these results, I have further moved on to the next work, which is I am doing now. The complete in vitro analysis of Milius and Illegrica leaves is being carried out now, and additional research is going on for the identification of organic compounds and structural elucidation through FT-IR spectroscopy. If this proven to be any special any compounds to be shown, next I will work on with the flash chromatography for the further crystallization and isolation of the compound. Thank you.
Thank you so much, Nancy. It's a good presentation. So, for example, you're using so many solvent for extraction, right? So, is it all the solvent? For example, if you take what kind of materials you can extract? Is it polar or non-polar? Unipolar, which compound can be extracted from the plant extract?
Sir, I have taken from non-polar to polar solvents. From that which we can.
You are using only single, right? If you are combining multiple solvents, so you can extract all polar, non-polar,
yes,
all the compounds. But most of the things you use only single solvent. Is it okay?
Yeah, I have taken from the polar to non. Regarding which. Ascending to the polarity, I have taken the solvents from the petroleum ether to methanol. Methanol is next to water, and petroleum ether is the basic non-polar solvent. It's taken in many of the works.
Okay, so what's your novelty if you say ask? What's your novelty?
About the novelty, yes, most of the medicinal plants which are endemic to the hilly regions, we can find out their medicinal properties, and we can cultivate. We can try to bring out them to the plains for the future propagation and commercialization. That was the last objective of my study, which is plant tissue culture, which can be cultivated.
So when you are taking ethanol, it is well known that methanol, if you are taking.
I didn't take ethanol.
So leaves,
yes,
green leaves. First one chlorophyll, it will be leaching now.
Yes.
But your case, I haven't seen any data with the chlorophyll.
I didn't go for chlorophyll, sir. I just gone for flavonoids and phenolic contents for the antioxidant and anti-diabetic only.
So when you are boiling, so yes, chlorophyll also can leach out.
Yeah, yes, sir. Obviously it will.
But in your HPLC data, so we haven't seen any chlorophyll peaks.
Yes, sir. That's why. That's because I have taken the standard, only the standard compounds, sir. Gallic acid. I didn't take chlorophyll. I have taken. Yeah, yes, sir. We obviously everyone knows chlorophyll will come out, so I omitted it.
So any one question? Okay, thank you. Next to Wendy, show your turn. Yes. So next presentation will be Abdur. Okay. After Wendy finishes.
Number 10.
Yes.
Thank you. Hi, everyone. My name is Wendy Gomez, and I'm currently doing pharmacology at my BSc at the University of East London. And I came here with my classmates for the 6 weeks exchange program. And I work in this project called Synthesis and Characterization of Copper Oxide Nanoparticles and its application in the healthcare sector as an antibacterial agent. So as I need to skip some information, I know everybody knows what nanotechnology is, so I'm not going to explain that part. So the aim of this experiment was to achieve the synthesis and characterization of copper oxide. I know Isabel already talked about this, but my novelty, or what is different from my side, is the type of ligand that I use to do this synthesis. So synthesis of copper oxide nanoparticle, basically, this is one graphic representation of what I have performed. And as bulk material, we use copper sulfate. My ligand was L-tryptophan. And we reduced we use as a reducing agent, sodium hydroxide. And then when we achieve the dark brown color, this is when we confirm that nanoparticles were formed. Obviously, we compare this with spread literature. Then I'm showing here just my photos. I took these pictures. So, and the process took only 15 minutes. So characterization of copper oxide nanoparticles. So I used UV visible spectroscopy, also Fourier transform infrared spectroscopy. And what I want to show here is just that for the UV, we use the liquid sample because we use both dry and solid and liquid. And in this case, just the wavelength was in 200 nanometers, which as per literature, we know the formation of the nanoparticles. And then for the FTIR spectroscopy, I just put this table. This table correlates with the peaks shown in this graph, where basically what I'm showing here is how the ligand is in the surface of the nanoparticles, and these are the functional groups. So next. Oh, sorry. Sorry. Oh, it's gone. Perfect. Thank you. And then here the FESEM, as probably many of you know that the nanoparticles have different shapes. So in this case, I have beautiful flower-like pattern. And the ED X-ray analysis, basically here is just to show the elemental distribution. So we can see at the kilo electrovolt number 8 is present copper, also like in 1.7, and the other on also the oxygen, and the carbon is because the is present on my ligand. Okay, let's go to the next one. Ooh, it's not moving. Okay, now. But, okay, so the antibacterial studies, I perform so I check for the zonon inhibition using agar plates, also the MIC, MBC. And for the growth curve and biofilm assay, I use 96 well plates. So here for the agar well diffusion, basically what I used was these 3 gram-negative bacteria, and these are my results. So as you can see, B, C are those concentrations here, 5 mg per ml and 50. And I'm comparing it. The first one is the A line is there was nothing on it. Then in the D was water, and E was ampicillin. So as you can see, the results were great comparing with the ampicillin. So for the bacterial growth curve, I don't know, can you see it? Oh, no, sorry, for the minimum inhibitory concentrations, these are the concentrations, and we know, I think everybody knows what minimum inhibitory concentration is. So it's the lowest concentration needed to inhibit the growth after the incubation period. And the minimum bactericidal concentration is exactly the same as the MIC, but when it kills completely the bacteria. Okay, so I will move. So just to mention that in the growth curve and the biofilm assay, in both cases, nanoparticles worked better in 3 of the strains. And as a conclusion, I just want to mention that the characterization techniques were successful. Also the synthesis, as I mentioned before, the ligand was my novelty. And I think that after performing an optimization of these nanoparticles, we could start working in another option to solve the problem that we have with antimicrobial resistance, and also not only for that, for any other studies. Thank you.
Thank you so much, Wendy, for a very nice presentation. So what about the toxicity level? For example, you are telling you can use it instead of antibiotic, right? So what about toxicity? So how much I can use this copper inside?
I think by performing the MIC and the MBC is like the beginning to understand the doses that we need to use. So of course, from the pharmacology point of view, I will say this is not enough information to talk about the toxicity. So I think further studies will be needed.
Okay. Thank you.
Actually, spectrum is a singular, spectra is plural.
Oh, sorry, the spelling mistake. Sorry. Thank you.
Questions from audience? Okay. Okay, thank you, Eddie. I see you people are making very nice slides. To all of you. Good job. So many of the pictures, I think you are drawing yourself, the presentation, right? Synthesis.
Everything I have done by myself.
Okay, good.
They can point it with a black color. Oh, in this side. What's that? This one. Okay, okay. I'm not able to see the cursor. Okay, great. Thank you so much.
A warm good evening to everyone. My name is Abhinaya and I work as a research scholar in the Tissue Engineering and Cancer Research Laboratory at SRM University. Today, I'm going to share with you my project, 3D polylactic acid scaffold.
surface modified and 4-methoxycinnamic acid loaded kerosene nanoparticles for bone regeneration. So before I go into my project, I would like to share a little bit of background here. Bone is a highly dynamically integrated organ of human body that undergoes remodeling with the help of bone cells, namely the osteoclast and the osteoblast. In the event of an excessive damage, the bone cells, the stem cells, under the influence of several signaling pathways, aid in bone regeneration. But this happens in a very dilatory manner, very slow. So human intervention is needed. Usually, the conventional techniques is the autograft and allograft. But bone tissue engineering is coming into play. In bone tissue engineering, we aim at producing biocomposite scaffold incorporated with stem cells and other bioactive small molecules to aid quicker osteogenesis. So this is how nanotechnology aids in bone regeneration. Nanotechnology can be used for drug delivery, for stem cell labeling, and so many other things. And phytochemical that aids in osteogenesis is evolving area in this study. The phytocompound of our interest is a polyphenolic acid. It's 4-methoxycinnamic acid. It has various therapeutic potential, but its osteogenic potential is yet to be evaluated. That's a novelty. And another disadvantage of 4-methoxycinnamic acid is highly hydrophobic in nature. To overcome its hydrophobicity, we are calling a drug delivery system. Kerosene nanoparticle here is a suitable drug delivery system of our choice. And the scaffold bulk material is polylactic acid, is the FDA approved nanocarrier. And the 3D polylactic acid scaffold are surface coated with polydopamine. It's well known for its adhesive nature. So aim of my study is to synthesize and characterize the scaffold. The objective is, first objective is to synthesize and characterize the biocomposite scaffold. The second objective is to check its cell viability, check its cytotoxicity. The third objective is to check its osteogenic potential at both cellular and molecular level. This is my methodology here. First, this is the STL file that we produce by AutoCAD, and then we'll give it to the 3D printer, and these are the scaffolds that we fabricated. After that, we are immersion coating them with polydopamine and then lyophilizing them. Simultaneously, here we are preparing 4-methoxycinnamic acid load, that is a nanoparticle by ionic gelation technique in 3 different concentrations, lyophilizing them, and then again immersion coating them on top of the 3D printed scaffold. Now it's ready for material characterization, cell viability, and osteogenic evaluation studies. These are my results. Transmission electron microscopy was used to analyze the size and surface morphology of the nanoparticles produced. As you see, the nanoparticles are uniform size distribution, spherical in morphology. The size diameter of the nanoparticle were between 144 to 148. There was no significant increase in size of the nanoparticle. The stability of colloidal stability of the nanoparticle was found using a zeta analyzer. As you see, any charge that's greater than 30 is considered to be a highly stable nanoparticle. In our case, the anti-Carson nanoparticle was plus 38, and in the inclusion it was plus 42. The stability gradually increased. And these are the nanoparticle modified scaffold surfaces were subjected to cell analysis. And as you see here, the surface is uniformly coated with the nanoparticle, and spherical shape is sterility. Entrapment efficiency of the nanoparticle was found during the nanoparticle preparation step, collecting the supernatant and then subjecting them to UV spec analysis. As you see, the entrapment efficiency of all the 3 groups here are around 68, which is good. FDR analysis was done to find the chemical interaction between the molecules. These are the standard compounds that I use, and these are the FTIR spectra of the scaffolds. As you see, there is no new bond formation, indicating there is no chemical interaction between any of the compounds. XRD analysis was done to study the crystalline structure of the compound. As you see, 4-methoxycinnamic acid is a highly crystalline drug, and it is not favorable for the biological environment. In formation of the nanoparticle, you can see amorphization happening, and it's transforming to a semi-crystalline state, which is better for bioadhesion and bioavailability. So biomineralization studies is very important for a scaffold because it tells you how much bone is able to form in presence of biological fluid. The scaffolds were incubated in stimulated body fluid for a period of 21 days, and then were subjected to cell analysis. As you see, the cube structures are hydroxyapatite crystals that were formed on the surface of the scaffold. We did the EVDS analysis to check the elemental composition of the mineral scaffold, and the EVDS analysis clearly told the calcium phosphate ratio was between 1.8 to 2.2, which is similar to that of the biological bone. Drug release study from the scaffold was calculated by immersing the scaffold in 1x PDS for a period of 21 days, and then the supernatant was collected and subjected to UV spec analysis. And the release profile shows a sustained and prolonged release for even 21 days. The presence of methoxycinnamic acid was confirmed with HPLC. Protein absorption studies showed good protein absorption when compared to the control uncoated PLA scaffold. And toxicity studies were assessed by MTT, and there was no toxicity when of 4-methoxycinnamic acid when compared to the control. The cellular uptake studies was there was good cellular uptake. It was confirmed using FDA, and the osteogenic evaluation was done at both cellular and molecular level. These are the cellular studies and these are the molecular level studies. The mouse mesenchymal stem cells were cultured on top of the scaffold, and the ALP staining was done here. As you see, these are the control and these are the 4-methoxycinnamic acid modified groups. You can see intense colors indicating the formation of more ALP here, more calcium here, and more calcium ions here. In case of molecular studies, we studied 2 molecular markers, the master gene, the RNX2, and the lead osteogenic marker, the osteocalcin. In case of 20 micromolar 4-methoxycinnamic acid groups, there is increased amount of osteocalcin at 14 days by culturing mouse mesenchymal stem cells. In case of RNX2, again 20 micromolar should increase RNX2 mRNA expression. Therefore, I conclude that the inclusion of 4-methoxycinnamic acid did not increase the size of the particle, did not contribute to any change in the physicochemical properties, did not contribute to any cytotoxicity, but it did contribute to increased osteogenic differentiation. Therefore, I conclude that 4-methoxycinnamic acid has a huge potential in bone tissue engineering application. The future perspective is to go forward for in vivo studies. Thank you, sir.
Okay, thank you, Abhinaya, for a good presentation.
Thank you so much, sir.
So, you said cinnamic acid.
4-methoxycinnamic acid, sir.
What's the pH of that?
pH
value for the
Sir, actually, we dissolve it in DMSO. And while adding it to the chitosan solution, the pH should be 5.5. Yes.
No, I'm asking, is it biocompatible with the
It is very biocompatible, sir. That is why we did 3 different cell cytotoxicity array. We did mu cell analysis, we did MTT, we did FDA. In all 3, there was minimal cytotoxicity.
So your scaffold is biocompatible with the
100%.
100%.
Yeah, it's compatible.
So what is your novelty, if you want to say?
That nobody has ever reported the osteogenic potential of 4-methoxycinnamic acid. And when I'm saying 4-methoxycinnamic acid, the methoxy group is in the para position. So it has a huge bio potential, therapeutic potential. And it's surprising that nobody has evaluated its osteogenic potential.
Toxicity?
Toxicity, nobody has done that, sir.
Nobody done that? Or
done that in this bone tissue engineering perspective. Like I have done it in CT half. It's a mouse mesenchymal stem cell, and it slowly goes into osteoblast lineage. So nobody has done it in this cell line. But my novelty is 4-methoxycinnamic acid's osteogenic potential has never been evaluated. Nobody has thought of using it in bone tissue engineering perspective.
Oh, yeah. So in your case, you have taken PLA and PDA, chitosan and methoxycinnamic acid. First, a systematic study is needed. One is you simply taken 4. In case, in absence of 1, for example, in absence of PLA, what was the result? In absence of chitosan, what was the result? And this is called A, B, C, D. So we must study what is A plus B, A plus C, and B plus C, and A, B, C. Likely you have to study. Then only you can be able to conclude this is because of the methoxycinnamic acid.
That is what we have done, sir. So the first group here you see here is PLA. Next group is PLA PDA. Next group is just empty chitosan without 4-methoxycinnamic acid. And the bottom 3 groups are 4-methoxycinnamic acid loaded. So you can compare between the groups. This is empty PLA. It's just the PLA. So in each of the experiments, I have all the 6 groups. So in each of the experiment, I am comparing it with PLA, polydopamine coated PLA, chitosan nanoparticle, blank chitosan nanoparticle coated polydopamine coated PLA, and then the drug ones.
What about PDA alone, or what about this chitosan alone, and what about methoxy?
So it's well known, sir. It's already reported. So many papers have reported for those individual components. And we need a bulk material, scaffold that supports the growth of cells. So for just chitosan nanoparticle, how can we report? Like we need a 3D structure.
And you just go for the 3D printing?
The methodology.
Yes. What temperature you started to melt?
So it melts at 188 degrees Celsius.
Okay, actually, you know the temperature of melting point of PDA 370.
Not PDA, sir. This is PLA. PDA we don't melt.
You have taken?
Only PLA. It's just the PLA filament. We get it from the buyer and we give it to the
immersion coating of PDA you return.
Yes, immersion coating is the room temperature, sir.
Room temperature.
Yeah, we just coated room temperature. It requires basic conditions. The pH should be 8.5. So we coated at that pH. The dopamine hydrochloride automatically polymerizes to polydopamine, and then it coats. It has very good adhesive nature. It's a coming of biopolymers, sir. Recently, they are coating a lot of metals with polydopamine.
Okay, good.
Thank you so much, sir.
Thank you. Any questions from audience? Okay, thank you. Good job.
Thank you so much.
Thank you. So next presenter. Jaydeep Patel from University of London.
Hello everyone. Thank you. Thank you for giving me an opportunity to present my presentation in front of you all guys. Myself, Jaydeep Patel. Basically, I'm from native Gujarat, but I'm studying my BSc Biomedical Science in the University of East London. I just completed my second year in BSc Biomedical Science, and I got this opportunity to participate in this wonderful short work placement. And in this institute, I did my work in one of the applications in nanotechnology. So my present topic is like the silver nanoparticle, which I use for the degradation of dye as well as the antibacterial activities. And here I choose the ligand tryptophan. So the aim of my study, the main purpose of the study is to synthesize a silver nanoparticle at normal room temperature by a wet chemical method. And that silver nanoparticle which I synthesize, which is used for the degradation of the dye as well as the antibacterial activity. So introduction, everyone's know about the nanotechnology, so I don't want to go in the deep. But one of the interesting thing I just want to tell, the nanoparticle are not just a molecule. It is made up of 3 different layers. The first one is a surface layer, which has a polymer. Second one is a cell, which has a metal ion as well as the surfactant ion. And the third one is a core layer. The cell and the core layer is different in terms of the chemical properties. And the core layer itself is the nanoparticles. So I'm just going through the properties and the application of nanotechnology. It has a wide range of unique properties. You all can see like mechanical, thermal, and magnetic, as well as electronic and optical. So because of this wide unique properties as well as the morphological characters, it has been used in varieties of different fields like agriculture, health, electronics, textiles, foods, and etc. many more. Just I want to go in toxic dyes. Right now, dye industries are producing a majority of waste, and they are mainly responsible for producing wastewater. And some of the common dyes which are used by the industries are azo, cationic, acidic, as well as basic, which are creating lots of pollution. And what they do is normally they according to estimate, they roughly produces 700,000 tons of dye annually. And what they do is 10 to 15% of the dyes, which they are projected to stay unfixed. So they directly end up into the water bodies, and that's why it's creates lots of pollution and also affect to the human life as well. So thus the dye degradation is really mandatory before prior to release it into the water bodies. to protect the environment as well as to the human life. And also, as I told you earlier, that I also go through the antibacterial study with the same silver nanoparticle which I synthesized. So, because right now, like we are seeing lots of numerous problems with the bacterial sickness that's going on, because microorganisms are really small. They can like penetrate everywhere. You can see like microorganisms, they're affecting lots, they're creating lots of problem, and like also they are like various like illness because of the we are like experiencing, such as respiratory tract infection, diarrhea, and etc. So on. Sorry. So what is a silver nanoparticle? Silver is like after I researched so many articles, and I found that silver is like a good for anti-infective reagent, and it has a wide range.
Okay, actually, your 3 minutes already over. It's over to your work.
Okay. So sorry, synthesis of silver nanoparticles and physical, chemical, and biological method. So my experimental study is like synthesis of a silver nanoparticle by the chemical method, and then after that synthesized nanoparticle go for the different characterization purposes like UV and FDI, and then immediately I applied the silver nanoparticle for catalytic degradation as well as the antibacterial studies. So this is how I synthesize silver nanoparticle by using the silver nitrate as well as the ligand Endophyte. I just mix it in the beaker, and then after stir for 5 minutes, and I add sodium hydroxide, and then I got the silver nanoparticles. And also for the antibacterial studies, I choose a different 4 different type of microorganism, and I use a value fusion technique method to perform antibacterial studies. So, and the result and discussion part, as we can see that the graph obtained by using the UV spectral studies, the obtained silver nanoparticle at 420 nanometer of surface plasma resonance, and because of this, yellow colors indicate that that we have successfully synthesized a silver nanoparticle. And after it can go for the FDR characterization to check the attachment of ligand on the surface of the silver nanoparticle, and we got a different peaks, as you can see that because of the different functional group of silver nanoparticle, we got different peaks. And then the most interesting, I got a good, wonderful result of catalytic degradation. At the first time, you see like when we started, the peak observed at around 1. Then after each one time, like 1 minute after interval, before it was like a crystal violet solution was like totally like colorful, but after 12 minutes, it like shows a totally colorless solution I obtained. And the degradation efficiency which I obtained is 96.95%. So from this, we can say that it's like my silver nanoparticle work effectively in light degradation. And I also got antibacterial studies I did. So these are the zone of inhibition which I obtained by using my silver nanoparticle, and I use a different concentration, like 2 mg 100 microliter as well as 1 mg 50 microliter, and each like zone which I obtained like different. So from this we can say that of course a silver nanoparticle is like wonderful one of the good has an antibacterial activity. And the summary I just want to go through like fast. So because of this, textile industries are producing lots of waste. So I can easily, like from my data and my experiment, I can easily apply to the any textile industry in terms of crystalline violet dye, because the data and the record which I obtained is like good to decolorize the crystal violet dye to a colorful solution. So, and then after we can release to any water bodies so that it can save the environment as well as the life. And also silver nanoparticles used as antibacterial activity as well. And also because of the outstanding data, we can say that it has also an ability of bacterial activity. So overall, I can say that my synthesized silver nanoparticles has a bifunctional activity of antibacterial as well as the degradation of the dye of crystal violet dye. So these are my references which I wrote my information. This is thank you very much for giving an opportunity to all Abdur Crescent Institute of Science and Technology, the University of East London, as well as the Turing Syndrome. So thank you everyone.
Thank you. So is it crystal violet used in the textile industry? Are you sure?
Yeah, I refer many papers and so like the crystal violet used for imparting different dyes have been used.
Okay, so we have 1,000 liters of effluent. So how much silver nitrate is used, the nanoparticle will be used? It won't be expensive?
This is expensive. Because it's expensive.
Okay, thank you. Good work. Any?
So you took the polluted with dye water, the silver nitrate nanoparticles, no? After 12 minutes, it turns to colorless.
Yeah.
You tested the water?
Sorry?
Colorless water. You
Yeah.
tested water for its chemical quality, whether it's ready to release in the open environment or open water bodies.
You know, I'm just like evaluating my result. So I'm working on it right now. Yeah.
So good evening.
Yeah, good evening.
Could you tell your experimental setup? How did you do the dye degradation experimental setup?
Yeah, sure. First of all, I synthesized my silver nanoparticle.
That's fine.
Yeah.
I'm just telling you did dye degradation,
Yeah.
right? So you might
Yeah.
have put your silver nanoparticles in the copper.
Yeah. First of all,
crystal
silver nanoparticle. First of all, I get in total I tasted 11 different dyes with a 5 ml concentration in 100 in 10 ml water, and I remained for overnight. By adding silver nanoparticle like a small drop micro, I just add and remain for overnight, and then after I saw that different colors has been obtained for different dyes like 2-3 aniline blue and crystal violet dye, and then after that I go for the FTI, not FTI, UV, and then I got different data, but the most fascinating data I found in a crystal violet.
So you simply kept it overnight.
Yeah, for overnight.
You did not expose it to sunlight. Or
No. I just
kept it in the dark.
Yeah.
The reaction was in the dark.
Yeah.
Overnight.
Overnight, yes.
Are you sure it was in the dark? Or was there any light falling on the silver nanoparticles?
Not sure. No. I'm sure like it's
Because if light falls on the silver nanoparticle and from the UV graph you see it is 420 wavelength, right?
Yeah.
So it can get activated because the light falls on the silver.
No, I remained for overnight because I did 10 o'clock, 11 o'clock.
No. Overnight you kept it in the dark.
In the dark, yeah. No, in the dark. In the dark, I kept it.
In the dark.
Yeah.
And the dilation happened.
Yeah.
In the dark.
Yeah.
Okay. Then it's fine. But if you would expose your similar experimental setup in the sunlight, then your reaction will be more faster.
That one is like photocatalytic, but
you said degradation happened in 12 minutes?
Yeah, one minute of each interval. Yeah.
But you kept it overnight.
Yeah. But degradation happened. I just found the color, and then after I go for the characterization of UV.
Okay. From the UV, you could even calculate the band gap. So with the help of band gap, you can analyze if it is actively in the sunlight or if you can keep it in the normal light. It's a good nanoparticle. And as sir told about the expensiveness, right?
Yeah.
So we could make a composite of silver nitrate with any other composite like graphite carbon nitride, which is not toxic and not expensive also. So with that composite, we can achieve the similar dye degradation under sunlight.
Next time in future, I'll try. If I come to India, then definitely I'll try.
Okay, thank you.
Okay, thank you very much.
The next is Soumya. She's from SPIMS University, Tripoli. So SE means Sri Venkateswara Institute, right? Institute of Medical Sciences.
This one. Up down. This one. Cursor is up down.
Good evening to one and all. So my name is Samundeshwari. I am the research scholar from the Department of Biotechnology, and I am from Sri Venkateshwara Institute of Medical Sciences, Tirupati, Andhra Pradesh. So my work is about novel mutations in HFE gene and its impact on erythrocytosis. So it is a molecular diagnostic approach. So first thing, why we are going into the molecular diagnostic approach means because we need the more precision in medicine or treatment or whatever. Because nowadays we are getting a lot of mutations in the disease, but we are following the same treatment protocol. So we are doing these studies. So it is like a project we are doing in our department. So it is like patients visited to the outpatient, and we'll get the samples from that, and we also have ethical clearance for that, and we'll do this study. So what is this is erythrocytosis. This is the condition. So it is associated with elevated hematocrit and hemoglobin levels in adults. So what happens means in the erythrocytosis conditions, because of this elevated hemoglobin and hematocrit level, the blood becoming more viscous and thickening. So because of that, you will get like strokes and cardiovascular diseases like that. So you know what is hematocrit is the number of red blood cells you have. I mean a number of red blood cells, and the hemoglobin is the it is the essential protein. It is found in the red blood cells. So we will first diagnostic the patient, that is they are related to erythrocytosis, means the hematocrit value should be above 50% and hemoglobin value should be above 17.5 gram per deciliter. So these are the some causes of the erythrocytosis, and these are the some symptoms of the erythrocytosis. So next we'll come to general classification of erythrocytosis. Normally erythrocytosis means you produce more number of red blood cells. Okay, so it is mainly by the process called erythropoiesis. So because of why erythropoiesis means because of the erythropoietin hormone, and it is secreted from the kidney. So depending on, there will be the classification whether we having a low erythropoietin or high erythropoietin. So in the high erythropoietin, we'll have the congenital and acquired. In the congenital and acquired, or there again is the primary and secondary erythrocytosis. So these are the some of the classification of erythrocytosis. So next is the this is the common, but what our aim is to study the HFE gene. So what is this HFE gene? Is the human homeostatic iron regulator protein. So what is the function of this is to regulate the circulating iron uptake by regulating the interaction of the transferrin receptor with the transferrin. And because the mutations in this gene, it causes hereditary hemochromatosis. It is a autosomal recessive genetic disorder. So there are common mutations was observed in this gene is the cysteine 282, tyrosine, and histidine 63, aspartic acid. And next is increased iron bioavailability resulting from the defects of molecules involved in the iron balance could lead to increased erythropoiesis and erythrocytosis. So because of these conditions, among the all classifications, we are focusing to the in the HFE gene. So what are the mutations in the HFE gene? So the aim of the study is to identify and analyze the mutations in HFE gene and its impact on erythrocytosis patient. So the methodology is there are a lot of patients coming to the outpatient department, but it is like the pilot study. First, we initially took 5 patients who were symptomatic with erythrocytosis, and they already was a classified as they are not into the primary erythrocytosis and secondary erythrocytosis, because the patients which I am taken here, this 5 patients was not a primary erythrocytosis, secondary erythrocytosis. They are something new called idiopathic erythrocytosis. That is the reason is unknown. So what my study is, because the erythropoiesis produced because of this iron and the red blood cells also produce more because of the iron overload. Because of this, I took this gene for the interest. So first, genomic DNA is isolated from the patient, and amplification of exon 4 of HFE gene using a polymerase chain reaction, and a sequencing of the exon 4 of HFE gene, and the mutations was identified in the gene using cluster X, and RNA isolation from the blood was done from the patient, and these are the iron related genes, that is hepcidin, transferrin, ferritin and ferroprotein expressions were analyzed by using RT-PCR. And finally, endogenous erythroid colonies, that is the assay, was performed for the patient. So in the results, we got 473 base pairs of the HFE gene, that is the exon 4, and this is the one of the chromatogram we got from the sequencing results. And in the sequencing alignment using the ClusterLex software, we got the 3 novel mutation out of 5 patients. So first is the genomic DNA, we got 5356 G is substituted with A, that is we observed in the patient 1, and in the patient 2 5435 and the genomic place we G is substituted with T, and in the third patient 5347 genomic DNA place C is substituted with the T. So these are the 3 novel mutations we have identified. So we so we concluded. So real-time PCR is also observed for the hepcidin, ferritin and ferroprotein transferrin genes. So we got the elevated ferritin, ferroprotein and transferrin level. So coming to the discussion, so 3 novel mutations was observed in this patients. So which makes the low hepcidin and increased ferritin, ferroprotein and saturated transferrin level, which gives the which tells that these patients were iron overloaded. So this study may be help for identifying these patients, that idiopathic, the unknown cause may be due to iron overload, and we can treat these patients with the hepcidin agonist that will reduce the iron overload, and we can give the genetic counseling to the patients for the HFE gene affected individuals. That's all. Thank you.
Thank you, Shari, for a good presentation. So you saying all the mutations leads to iron.
In which change?
All the mutate like change something, differences using 3 different changes because of the iron.
Not iron, sir, because the gene has this mutation, it has the changes in the iron metabolism. So the iron overload is increasing in that patient.
Because mutation leads to iron accumulation.
Yes. Because that study we have proved in the real-time PCR, because that the genes knows that hepcidin, ferritin, ferroprotein, they are related to iron homostatic genes.
So you're saying now what is your counseling you will give to the
and it's not like the counseling. So first the thing is novelty. These genes we will process and we will submit to GenBank, sir, NCBA. And next is the this is like idiopathic condition. So some of the disease.
Is it because 5 patients you studied, 3 people have a mutation?
Yes, mutation, novel mutation.
It is more than 50%.
It's more than 50% is there are already.
Like if I study 10 people, will have 6 different mutations?
No, sir. Why? Because I'm telling this is they are already classified. They are not with any of this. This is particular with erythrocytosis. We are already classified. That is, they are not primary and they are not secondary. So most of the disease may be causes of this increased red blood cells is because of the iron. So maybe iron metabolisms will be the one of the cause.
No, why I'm saying maybe it's kind of you're telling like a personalized medicine. Each one will get a different treatment.
Yes, of course.
Because after getting you seeing your results, we cannot give any one drug for one disease.
Yes,
so
sir, we have to
personalized medicine. Each one will
personalized medicine is different, sir, but personal diagnostics is also important.
Both
Yes.
Diagnostics and maybe treatment.
Yes.
Somebody say methodology studies, you should mention the patient gender and the age that he takes also. That is very important. And what methodology you have used to isolate the DNA from blood?
Chloroform method, sir.
And the DNA sequences you given, by what technique you found that one is the sequence is correct?
Sure, sir, I didn't understand.
The DNA sequences you given
Yes.
using some software.
Yes, cluster like software, sir.
Further, did you confirm that one is correct sequence by any technology like a mass spectrometry or any other things?
No, sir, we can't do like this. Sir. This is the last one. Like sequencing is the last thing where we can check the mutations.
Based on the applied data.
Yes, sir.
Iron hyper level of ions, that is mutation. Which iron specifically, always any iron?
Sir, iron.
Iron. Which iron?
Iron.
Like this.
Ferrous, sir.
Ferrous ions. Okay. So second is, you in your question you told about the RNA isolation. Why you are isolating RNA?
RNA, that is mRNA isolation.
For what you are? No, for what you isolate the mRNA?
For expression studies, sir. Of ferreting hepcidin genes.
Are there any changes in the mRNA expression?
Yes, sir.
Then the next you study only molecular biology. You study anything about the hormone that leads to these genetic mutations?
No, sir.
Because many hormones are regulating iron metabolism.
Because we have to do, sir, because this is the, in our department we are doing like, we are collecting some patient samples and we are just doing primary, secondary and we are getting into that. So we have to do some more.
Okay, thank you.
You can validate the science,
Yes, that is the Sanger sequencing chromogram. Yes.
And did you use any age match control?
Age match control
for your patient sample?
No, we are not using any age match control. So this is like, it's not a no, population study. It is a particular good molecular study. First, we will develop the molecular methodology, and after
developing gene panels.
A gene panel, and also so how we can new mutations can be occur in disease conditions. That's all. So it's not about the population and how much number of patients we are taking like that. So after this pilot study, we will take all into the conclusion, exclusion, inclusion, and all that after we will follow that.
For that, you need control, right?
Yeah, we having control. Control means they are apparently healthy control, like they are not erythrocytosis. That's all. That is we having more in real time research. In expression study, first is the control.
Okay, you can give a talk later, so because many people are waiting to do the presentation. The next, Sabina from University of East London, UK.
Give a big round of applause for Sabina.
This one, Melissa.
Yeah. Just upward or downward or right and left. Anything is okay.
Hello, good afternoon.
My name is Sabina. I'm from Moldova, a small country from Eastern Europe. Currently, I finished my second degree in UK in pharmaceutical science. And I'm glad to present you today my last research, which is fabrication, characterization, and antibacterial potential of nano-sized graphene oxide against clinical isolated of Staphylococcus aureus. This research is part of the short course here at the Crescent University, which I'm very thankful for. So why studying antibacterial research? Why is that important? Because antibiotics are becoming limited in modern world. The development of antibiotic is time-consuming and is difficult, and it causes a high rate of mortality. In 2019, it was reported 4.95 million deaths because of antibacterial resistance, and it can rise up to 10 million because by 2015, if left unsolved. Why graphene oxide nanoparticles? Because it's effective against both gram-positive and gram-negative bacteria. The size and the sharp edge of graphene oxide molecule can be easily penetrated in the cell membrane of the microorganism. Because graphene oxide has high surface area and it can be a potential ideal drug carrier, can be used as a nanocomposite with other molecules to increase the pharmacological response or to decrease the toxicity. And lastly, in this particular research, we discovered that it's easy to synthesize it. It is one-step reaction, very straightforward, it's easy, quick, and cost-efficient. So the project was structured in 3 parts and was performed stepwise. First was synthesize our nanoparticle by heating bottom-up chemical approach, by heating citric acid and alvaline for 3 hours at 120 degrees in muffled furnace. The produced nanoparticles was validated with the spectroscopic techniques such as UV visible and FTIR. And lastly was studied antibacterial study for graphene oxide nanoparticles for 3 different strains of Staphylococcus aureus, which one was pathogenic one, and different methods was applied. Results. The results from the UVs show that the peaks for a CC aromatic bond and CO bond at 250 nanometers and small pocket at 300 nanometers actually indicates the formation of our nanoparticles. Also, our nanoparticles in solution got a yellowish-like color, suggesting the oxidative form of graphene. FTIR results shows the aminated graphene oxide nanoparticle, which is very interesting because we use amino acid here. So our graphene oxide was functionalizing amine. So we can see the primary amine in our structure at the peak 3500. So it's a symmetric and asymmetric peaks here. Plus OH and CO groups was all characterized by FTIR, so therefore was validated on a nanoparticle. Next, the antibacterial studies for agar-well diffusion shown that the graphene oxide nanoparticle has a concentration dependent zone of inhibition against all strains of Staphylococcus aureus after 24 hours incubation at 37 degrees. MIC and NBC results shows that our nanoparticle had a good antibacterial properties for all bacterial strains, particularly for MIC tests, the Staphylococcus aureus pathogenic was shown very good results. Bacterial inhibition and biofuel formation assay So the diagram A shows the bacterial growth, and table A shows bacterial inhibition. So from the table, from the graph, we can understand that the growth was inhibited by more than 90% for all bacterial strains. Particularly was effective for pathogenic strain, which is 96.83% inhibition rate. It's from MIC concentration. And in table B and diagram B, it shows the biofilm formation rate and the biofilm inhibition rate. So the rate of biofilm formation was also reduced by 100% for two strains of Staphylococcus aureus and by 70% for pathogenic strain. So from these results, we can easily understand that our nanoparticle was far more effective than control ampicillin used, and in comparison with untreated control. In conclusion, the outcome of this research indicates that the bottom-up synthesis of graphene oxide nanoparticle from citric acid and L-valine is enabling the amine functionalization of graphene oxide nanoparticle, which is advantageous since it enhances the mechanism properties, therefore exhibiting the great antibacterial properties against all gram-positive. We study gram-positive bacteria, so against gram-positive bacteria, which is very notable. So physical and chemical interaction between the graphene oxide and the bacterial cell wall is actually responsible for its mechanism of action, antibacterial action. And it's notable that our nanoparticle have good results for gram-positive bacteria because they are known for a thick cell wall, which is hard to penetrate. Yeah, the oxidative nature of the graphene oxide nanoparticles, plus its sharp structure, enable them to penetrate easily through the cell membrane of the microorganism, therefore breaking down the structure of the microorganism and leading to the cell death. The presented findings could be used for in-depth study of graphene oxide nanoparticles and bacterial inhibition mechanisms and applied in development of new nanomedicine. Thank you.
Thank you. Good job, Sabina.
Questions already. You got the best questions.
No, actually, see, you said it's working. The graphene oxide is nanoparticle. Okay, it's working excellent.
Yeah. This
So
what the data show.
Okay, how you're gonna use it?
How I'm gonna use me
Yeah.
personally or in
No, I'm saying general. I'm saying what's the application you're planning?
So we studied the healthcare application, yes.
Is it a graphene oxide? We can use it for human being? Is it a toxic?
It has a concentration of toxicity. So if you pass the concentration, which is according to the literature is 500 microgram per mil, we got here an immunoinhibitory concentration less than that, much more less than that. So it's not toxic at all. According to literature, but it's better to do more studies because no many studies about graphene oxide. It's most known as technology than in healthcare applications.
Okay, thank you. So you have any novelty? What do you say about your work?
I have novelty, yeah.
Yeah. What's your novelty?
The way of synthesis.
Oh, synthesis.
So the raw material, the primary material we use. So you're not gonna find it in literature. It's like something new. Also, it's very cost efficient, yeah. And what impressed me that actually functionalized our nanoparticle. So it's aminated, graphene oxide nanoparticle, and this aminated group enhances its property, penetration property.
Okay, good. Thank you.
Yeah, Sabina.
Yeah.
My question is related to synthesis.
Yeah.
So how graphene oxide has been formed?
Oh, it was formed by bottom-up synthesis. So basically, we use material A plus material B, and we got the product C. So we got a new product from two different materials. So it's bottom-up synthesis. used us, so we use the chemical approach for that.
Actually, this is a simple heating method, but inside 4 mechanisms. That one is hydrolysis, pyrolysis, passivation, carbonization. So actually, this one is pyrolysis.
Yeah.
Okay, good job.
Thank you.
So any question, one question from audience, one question. Yeah.
Okay. Hi.
I just have a simple doubt. So you have used 5 mg per ml and 10 mg per ml of your
Yeah.
Don't you think that is so much for a nanoparticle to use for a bacterial culture?
We use less concentration, so we started the less concentration. We done many tries, yeah, we tried many times, but it didn't work. It didn't show any zone of inhibition.
But can you go to that picture? This next.
Yeah.
So you have mentioned 5 mg per ml and 10 mg per ml.
Yeah.
So that's my doubt. Isn't that I mean, it's a very larger amount for a nanoparticle to be used.
Why do you think it's large?
Because if many plant-derived flavonoids, it's MIC below 500 mg per ml. So nanoparticle should be more efficient than that. Right?
Yeah, but we've got the minimum inhibitory concentration and minimum bacterial concentration, which is 0.01 something. So that one is like first step to validate antibacterial activity. This is the first step. We just why we use this to actually understand if this nanoparticle has any activity against this bacteria, yeah. And then we done the further studies, yeah. And then we find the minimum inhibitory concentration and minimum bacterial concentration. So it got a response. So look, it showed 96% bacterial inhibition on its MIC concentration. So MIC concentration is 0.0195.
So you have used that MIC concentration to test.
Yeah.
But MIC should inhibit all organisms, right?
Sorry?
MIC actually should inhibit all the organisms. So how come you got that much?
This is what the data says.
Usually for biofilm inhibition, we use sub MIC concentrations, not MIC concentrations. MIC concentration is the concentration which kills the organisms.
No, MIC is which inhibits the organism, MBC which kills the microorganisms.
So we should use the sub MIC concentrations.
So this is what we use, MIC concentration.
No.
So you say below the
MIC concentration.
Below the MIC concentration. So well, it was 5 weeks research, which is very short time, and we still didn't finish our research. Yeah. We was working intensely every day, but you need to do a proper research. You need more time, at least couple of months. But for 6 weeks, the data we got is actually beautiful. Yeah.
I understand.
Thank you.
Yeah.
Even I would say we need to, you people are excellent. I would say even their BSc level, the second year, even not even they have completed. So they have done an excellent job, really. Awesome job. Good job, all of you.
Lisa Larry from University of London, UK.
Hello, my name is Melissa. I'm from the University of East London, and this is the title of my research project. It's a bit of a mouthful, so I won't read it. So the objective of my research project was to synthesize a novel copper oxide nanoparticle from scratch using L-proline, an amino acid, as a ligand via a wet chemical method. Our secondary aim was to study the antibacterial potential and efficacy of copper oxide nanoparticles and compare this with a known antibiotic, ampicillin. We synthesized by using copper sulfate and L-proline, combining them together and leaving. After 72 hours, the copper oxide nanoparticle had formed. And to confirm it was present, we did some characterization studies. The first one was UV visible spectroscopy. So as you can see, there's a broad band obtained between 210 nanometers and 800 nanometers. And this is typical for the literature of copper. Next, we did FTIR. I've listed the functional groups and the wavelengths of their stretching, vibrational frequency are generating the peaks on the trace. This trace matches the FTIR trace for L-proline, proving that the amino acid ligand has successfully adsorbed to the surface of the copper oxide. Then we did scanning electron microscopy to obtain the morphology. This is a polymorphic shape that is flower-like, and the width of my nanoparticle is 100 nanometers and the length is 300 nanometers. This satisfies the condition that it fits as a nanoparticle because one dimension is within 1 to 100 nanometers. So we began our antimicrobial studies. I looked at 3 strains, E. coli, Acinetobacter baumannii, and Klebsiella pneumoniae. As you can see, wells B and C have both been treated with copper oxide nanoparticle, and there are clear zones of inhibition. In fact, for E. coli and Acinetobacter baumannii, the diameter of the zones of inhibition are wider than that of ampicillin. We then did MIC and NBC bioassays. The purple plate is dyed with crystal violet, and the intensity of the purple increases when there is more biofilm growth, and it's more potent at the bottom where it was treated with less concentration of nanoparticle. From the MIC, we generated our growth curve, and the nanoparticle, where the nanoparticle was treated, that had less growth of bacteria after 24 hours than the ampicillin for all 3. For AB was the most susceptible to the nanoparticle treatment. It says 26%, but it's actually 2.6. And then biofilm had quite dramatic results. There was almost negligible biofilm growth. For E. coli, it was 0.34% compared to ampicillin, which was 14.2%. So in summary, we were successful in synthesizing an amino acid capped copper oxide nanoparticle. We completed characterization and antibacterial studies. The conclusions we can draw from this are nanoparticles showed efficacy as an antibacterial agent against 3 strains of bacteria. Nanoparticles were more effective than ampicillin. They produced larger zones of inhibition, and the copper oxide nanoparticles had lower MIC, MBC, and biofilm growth for all 3 strains. And this has the potential for copper oxide nanoparticles to be used as an alternative to antibiotics and to combat bacteria that have become antibiotic resistant. Thank you very much for listening. Thank you to Dr. Malta, Dr. Rajani, Dr. Basimilai, and Crescent University. Thank you.
So which part of your experiment you got more excitement?
The agar well diffusion.
Oh, okay.
Because rather than just numbers, you can actually see, and you're like, oh, it works.
Okay, so thank you.
Because of the less time availability, I request our participant to ask only one question.
One question from participant, no? Okay, thank you.
Thank you very much.
Next question. Registrar, Institute of Medical Sciences. After Sureka, Naga Satya. From Isana, Registrar.
Good evening, everyone. Myself, Sureka, research scholar, Department of Biotechnology, SPIMS, Tirupati. I am here to present my work entitled In Vitro Anti-Diabetic and Protective Activity of SSS Statistics on In Vitro Differentiated Beta Cells from Human Hematopoietic Stem Cells. Before going to discuss how I proved the effect of SSS statistics on human hematopoietic and beta cells, I want to give a brief introduction about the diabetic. This is the World Health Organization report which submitted by WHO, stating that the mortality rate of the diabetic mellitus patients has been increasing. This is the epidemiology of the diabetic mellitus. When we observe the epidemiology of the diabetic mellitus, it is the leading cause of the death globally, which including 1.6 million patients were causing the death because of the diabetic mellitus, and prevalence of the diabetes has been increasing when compared to the other disease conditions. And this is the report submitted by WHO. And when it comes to the major and minor complications of the diabetes, which the microvascular complications, which include diabetic retinopathy, diabetic nephropathy, and neuropathy conditions. When coming to the macrovascular complications of the diabetes, it will affect the brain, heart, and it will cause extremities. And this is the milestones of the diabetic timeline, where 2014 is the year where the stem cell transplantation of the beta cells come into the existence. And these are the presently used synthetic drugs for the treatment of.
Dr. Sureka, could you put your results and then talk about your findings?
Okay, sir.
Thank you.
Okay. So our present work is on about the proving the anti-diabetic and protective activity of SSS statistics on in vitro differentiated pancreatic beta cells. It is also called Pancha-Vine. It is a plant used for around the world to treat various elements. Coming to my graphical abstract, we use the human hematopoietic stem cells used for the differentiation studies for the production of human pancreatic beta cells. Then these beta cells were treated with SSS statistics extract, and we analyzed the anti-diabetic and protective activity of SSS on beta cells. And before going to analyze the in vitro diabetic activity of SSS, first it characterized the human hematopoietic stem cells. When coming to the human hematopoietic stem cells, this is the A figure represents the morphology of the human hematopoietic stem cells. Coming to the B, it is the Leishman staining conformation of human hematopoietic stem cells, showing the round shape of morphology. When come to the C, it is the immunocytochemistry of human hematopoietic stem cells against CD34 marker, which is the major marker expressed by the human hematopoietic stem cells. When come to the flow cytometry analysis of human hematopoietic stem cells, human hematopoietic stem cells were characterized against CD34 and CD133 markers, which are the characteristic markers of human hematopoietic stem cells conjugated with phytoerythrin. And this is the next, after the characterization of human hematopoietic stem cells, they are infused to form the beta cells of islets of Langerhans. And this is the beta cell differentiation media which we have used for the differentiation studies for the conversion with the differentiation of human hematopoietic stem cells into the beta cells. And after induction, the PDX1 positive cells were selected, and further they were incubated with the beta cells differentiation media containing EGF, FGF, transferring nicotinamide and triidolo-L-trironine. After that, we have analyzed for data analysis, which include DTZ staining, immunocytochemistry, and qPCR and glucokinase enzyme assay. This is the protocol which we have followed for the induction of human hematopoietic stem cells into beta cells. This work is published already. These beta cells were further characterized with its morphology, DTZ staining, which is a specific staining for the beta cells, and also the immunocytochemistry studies against the PTX1 gene. PTX1 is the main marker which is exhibited by the pancreatic beta cells, so that we can prove that the in vitro human hematopoietic stem cells with the treatment of the beta cells differentiation medium have been differentiated into the pancreatic beta cells. Then these beta cells were treated with different concentrations of Tripulus terrestris extract, which is dissolved in the aqueous, that is water, and I have also analyzed using the different solvent. But when using the different solvent, I have analyzed that the viability of the cells goes on increasing in the glacial acetic acid, ethanol, and also in DMSO. When I dissolved in the drug in aqueous, it shows the maximum diabetic and protective activity. So I have used the solvent as the water, plain milky water. Then I have done the MDT assay, and using the different concentrations, when you observe here in control, while increasing the concentration of the glucose, the cell viability goes on decreasing. When I have treated these cells with the Tripulus terrestris extract, the cell viability of the beta cells has been increased in all the concentrations. This shows the protective activity of Tripulus on beta cells through MDT assay. Then the antidiabetic property of the Tripulus terrestris has proved through the glucokinase and glucose 6-phosphatase enzyme assays. Glucokinase is the major rate limiting step which can be helpful for the further metabolism of the glucose with insulin resulting in the production of insulin. So when we observe here, control beta cells were showing low levels of glucokinase. But when the beta cells were treated with different concentrations of drug, the glucokinase activity will goes on increasing, showing the antidiabetic property of the Tripulus. While the same drug will inhibiting the glucose 6-phosphatase enzyme, which is correlating with the results of the glucokinase. After that, we have analyzed the GLUT2 and insulin expression levels in Tripulus treated beta cells, where the GLUT2 and insulin were the major markers which are involved in the diabetic conditions. So when we observe here, the glucokinase and glucose 6-phosphatase enzyme assay results were correlated with the real-time PCR expression levels of insulin and GLUT2. Then to know what are the major compounds involved in the Tripulus terrestris extract, we have used the in silico structure validation. That is, the GLUT2 gene was structure validated, and the Ramachandran plot was plotted against the GLUT2 gene, and that this GLUT2 protein was docked with 4 different ligands when available in literature, and I have got the results that diosine and protodiosine are the 2 molecules were docking much with the GLUT2 protein. And I also docked similarly along with the GLUT2. I have done the same experiment with the in silico study with the insulin gene, where I have also docked with 4 molecules where got diosine and protodiosine as the major binding molecules. And this is the schematic representation of my work, where assuming this as a beta cell, I treated this extract with the beta cell, where we can show that the glucose intake was increased in the presence of GLUT2, resulting in the increasing of the glucokinase enzyme, which causes depolarization of calcium and potassium channels, in turn resulting in the insulin vesicle release, insulin resulting in the insulin secretion, so that the produced insulin can inhibit the high amount of the glucose which is present in the blood. This is my conclusion, how my drug is showing the antidiabetic and protective activity against the hyperglycemic conditions caused in diabetic complications. And this is the stem cell laboratory which I am working on. And he is my guide, Dr. P.V.J.K. Sharma, Associate Professor, Head and Department of Biotechnology. So last but not least, let food be your first medicine and kitchen be your first pharmacy. Thank you.
Thank you. So what is the novelty? So this plant is already not used for diabetes.
Yes, sir, already proven in vivo studies, sir.
Okay.
But there is no study that have proven in vitro and the beta cells. That too it differentiated from the naive hematopoietic stem cells collected from the patient. That naive human hematopoietic stem cells were differentiated into the beta cells, and they characterized that. And we checked that differentiated beta cells, the activity of tribulus on that differentiated beta cells. And we have increased the functionality and protective activity of tribulus, which is shown on the beta cells here.
Okay, any question from participants side?
Okay, thank you so much, Sureka. Good job.
Yeah. Oh, this is all.
Good evening all, I am Nagasatya from SRM University. My research topic is isolation, purification and in silico studies of actinic and glassine and alkaloids related to neurodegenerative disease from Nanotechnology databases. A neurodegenerative disease is age-based illness defined by the progressive loss of neurons and the neuronal cell death. The neurodegenerative disease is caused by amyloid beta plaques and neurofibrillary formation and the inflammation in the brain cells. According to the Alzheimer's Disease International Council, in 2050 they are expecting 107 billion Alzheimer's patients will be expected in the low and middle income countries. In this study, we have selected the Nanoparticle Jeramalci plant belongs to the Caprifoliaceae family, native to the Alps and Himalayas. This plant has a rich history of medicinal values and used in Indian system of medicine. The extract with the water is used to treat insomnia and central nervous system illness. The plant secondary metabolites, especially in alkaloids with pharmacological activity, has an exemplary repository to the development of novel drug development. The alkaloids having many of the literature survey implies alkaloids having a neuroproductive activity. It will inhibit it will show the neuroproduction by inhibiting the relative oxygen species and it reduces the mitochondrial dysfunction and acetylcholinesterase inhibition. My objective is to identify and purify the neuroproductive alkaloids from Nanoparticle Jeramalci. First, the condition was optimized and profiling the alkaloids from Nanoparticle Jeramalci and purify and characterize an abundant alkaloids from Jeramalci. To validate the molecular affinity of purified alkaloids, we have selected 15 target proteins associated with the neurodegenerative pathology to evaluate and antioxidant activity and cytotoxicity of the purified alkaloids were studied. Coming to the results, this is the alkaloid profiling of Nanoparticle Jeramalci. From the rhizome border of Jeramalci, the alkaloid was extracted and isolated by using the LC-MS technique. Initially, we identified the 4 alkaloids belongs to the deoxymannomeridazine, actinidine, and 16 epivelosamine and glaciamine. Based on the area percentage, actinidine and glaciamine as a highly abundant alkaloid, we have selected for this further purification. The alkaloids were purified by semi-preparative column chromatography. The fraction 1 and 2 were characterized by LC-MS fragmentation pattern. After purification, the purity was checked with the HPLC and the formula was derived from HRMS spectrum and structure was confirmed by the MS fragmentation pattern. To evaluate the neuroproductive effect of these purified alkaloids, we used molecular docking studies. Initially, we selected 15 target proteins related to the neurodegenerative disease pathology, and also we compared commercially available alkaloid drugs which is used to treat Alzheimer's disease, including tacrine, galantamine, and memantine. These are the drugs they are using to manage the Alzheimer's disease symptoms. So, among the 15 targets, these both actinidine and glaciovine alkaloid shows the very close binding affinity to the acetylcholine esterase site and monoamine oxidase enzyme, beta site amyloid precursor protein cleavage enzyme, and adenosine A2A receptor. These are the docking chromatogram of actinidine and glaciovine results. Then again, these purified alkaloids cell viability and cytotoxicity was studied by using TC12 rat neuroblastoma cells and SHSV5 human neuroblastoma cells. With this, we tested till 100 micromolar concentration. There is no it was not affected the cell viability and showed the minimum borderline cytotoxicity, and also we evaluated the antioxidant activity by using 3 assays, TPPH, APTS and FRAP. When comparing to the control, it shows the more than 70% of antioxidant activity. With this, we conclude the purified alkaloids have a significant effect on neuroproductive function on PC12 and SHSV5 neuroblastoma cells. The prospects of the indicated and similar these bioactive compounds as a platform for drug discovery look very attractive for neuronal related problem. Thank you, sir.
Thank you so much. So, what is the novelty your work?
Sir, these plant extract they are using as a whole extract, sir. Actually, it is a traded plant. For export, they are exploiting the plants now. So, to conserve the plant, if you instead of taking a whole extract, if you know any compound which is having the activity, we can synthesize by in vitro by suspension culture, due elicitation method, or we can synthesize as a chemical.
So when you come to purified compound, always the toxicity comes with following that, right?
Yes, sir.
So what will you do with that?
Sir, we done cytotoxicity assay, sir. It's showing the 3% of cytotoxicity. It's not more than that at 100 micromolar concentration.
Okay, it's similar to commercially available compounds.
Yes, sir. Through in silico docking, we confirmed that. We didn't check with the standard alkali drug with the cell lines that we have to perform.
Okay, thank you.
Thank you, sir.
For your case, HPLC issues.
Yes.
So, what about your mobile phase and stationary phase?
Stationary phase is XTP C18 columns, sir, 5 micron particle size. Mobile phase is 0.1% formic acid and acetonitrile as a gradient elution, 3 ml per minute flow rate, sir.
Mass spectrum molecular ion fix which molecular ion the fragment molecular ion.
Yes, sir.
That image from top. It's not able to see. That molecular ion plans to which compound?
The first one belongs to the actinidine alkaloid, sir. The second one belongs to glaciovine alkaloid.
You are talking about the third row.
Yes, sir. Second one is for HRM spectrum, sir, to find out the molecular formula. We got with the error of 0.1 ppm.
But both are positive mode or?
Both are positive mode. Positive.
So you will take negative mode?
No, sir. I didn't try it.
Okay.
Thanks.
Okay, thank you so much, Satya. We have a last presentation today, Dr. Monisha. Yeah, actually she's from
Tiruthangal
Nadar College. So it's actually from where?
Tiruthangal Nadar College is in Selai Vayal, sir.
Selai Vayal.
Kodungayur.
All the best, ma'am.
Thank you, sir. Thank you, sir. Open money. 19. பெரிய ஸ்கிரீனா வச்சுக்கோங்க சார். ஸ்லைட் ஷோ வச்சிருக்கோம்.
So good afternoon to one and all present here. First of all, I would like to thank Almighty for giving this opportunity, and I would like to thank all the jury members who are present here today. Thank you, sir. Thank you, ma'am. Today's presentation, the topic is in silico molecular docking analysis of ACE1 receptor of Culex quinquefasciatus and Aedes aegypti against the phytosterols from the seagrasses. So, mosquitoes are flying insects that have a greater impact on public health. According to latest reports of WHO 2020, around...
I think better we can go for your findings.
Okay, sir. Okay, sir. So first I'll start with the objectives. So first I went for collection and identification of seagrass. Here I have selected Pseudomonas cellata. Then I have done extraction using 3 different solvents according to the increasing order of polarity such as hexane, dichloromethane and ethanol. And I went for collection and identification of vectors like Aedes aegypti and Culex quinquefasciatus. Then I have done preliminary phytochemical activity and larvicidal activity for crude extracts. Next for fraction level. Next I have find out the compound. For that compound I went for characterization studies such as TLC, UV visible spectroscopy, FTIR, H1NMR and GCMS. Next I have applied in histopathological studies and non-target effects such as 2 fishes, Poecilia reticulata and Gambusia affinis for toxicity studies. Next, finally, I have performed in silico molecular docking analysis of ACE receptor. ACE receptor is an enzyme which codes for passing the nerve signaling. So this is the place of Rahman coastal region. Here the Pseudomonas species was collected. Next, they were brought to lab, washed, air dried, crushed, grounded in a machine blender. Then they have soaked in 3 different solvents, as I have told earlier, sequentially for every 48 hours. They were filtered, concentrated at 50 degrees Celsius, and they were further taken studies to phytochemical activity and mosquito larvicidal activity. And for phytochemical analysis, I have done amino acids, proteins, tannins, saponins, flavonoids, alkaloids, quinones, glycosides, triterpenoids, phenols, steroids, coumarin, following the methodology of Nazir et al. 2009. So before passing on to mosquito larvicidal activity, I went for mosquito larval collection. This is the picture showing collection of mixed stages of Culex quinquefasciatus from Coom river water. Right side is collection of larvae of Aedes from the open stored water. And diagrams is a flow chart of life cycle of mosquito. This is how it will be reared in the laboratory. For experiments, usually I will select the 3rd instar larva. So this is the experimental setup I have followed the Mayo Eton 2016. So I have prepared the extracts into 4 different concentrations: 62.5, 125, 250, 500. Control I have used water, and negative control I have used as DMSO. This is the enlarged picture showing the Culex quinquefasciatus and Aedes aegypti. So in each I have used 5 replicates. In each cup I will be introducing 23rd instar larva and my compound. After 24 hours the mortality will be calculated, and finally it is imputed using the Abbott's formula. And using the SPSS software, I will find the LC50, LC90 standard deviation chi-square test was calculated. Next, the potent crude fraction, the potent crude will be subjected into the column chromatography. Around 22 fractions I have collected, and the similar fractions were mixed with the help of TLC. So once again, larvicidal activity was carried out for all the 8 fractions, from which it was found that fraction E showed the very good mortality. So if we see the TLC pattern of fraction E, I have found 2 compounds like compound A and compound B. Once again, I have carried out the larvicidal activity. It was found that compound A was found to be potent, but no mortality was seen in compound B. So the compound A was further subjected to characterization studies such as UV visible spectroscopy, FTIR, H1NMR, and GCMS. And I have seen the histopathological alterations of third instar larva, like how much the midgut has affected. And I have applied my compound in 2 fishes such as Poecilia reticulata and Gambusia affinis. Next is results and discussion. So in table 1, I have explained seagrass, selection of seagrasses, parts used, extracts, crude, weight, powder, extractive value, etc. And table 2, preliminary phytochemical activity. Here we have to note Simodiasis cellata strongly answered the Limberman-Butcher test, showing the presence of steroids. And this is the results for larvicidal activity of crude extract. Among the 3 different solvent, hexane extract show a higher mortality, whereas it doesn't show activity. 2 minutes, sir. It doesn't show any activity in dichloromethane and ethanol. And this is the results for compound. Compound A has shown the activity. I have already told. Compound B doesn't show any activity. I have compared with acidirectin and temifos. Acidirectin natural compound, temifos is a commercial compound. And similar statistical analysis I have performed here. Next, this is the results for characterization studies. UV visible spectroscopy, there was a sharp intensity at 255 nanometer. It shows that it could be a phytosteroids. In FTIR, it shows a various peak from 3480 nanometer to 840 nanometer. Next, results from H1NMR. There was a multiplet which was found at 3.52, triplet at 3.56, and multiplet at 5.15 and 5.05. It strongly shows the presence of phytosteroids. Next, finally, GCMS, there was a peak at 29.777. It shows that there was a 3 phytosterols which were present in the mixture: sigmosterol, camphosterol, beta-cytosterol in the mixture 1:1:1. Next, results of histopathological studies. First one is untreated, whereas it doesn't show any activity. Second one, I have applied my compound and beta-cytosterol, where it strongly affected the midgut of the mosquito. Next one, I have applied in 2 target fishes such as Poecilia reticulata and Gambusia affinis. Up to 5 ppm, it doesn't show any activity. So the assay factor is favorable. Next, the in silico molecular docking analysis. So since it cannot be unable to separate the compounds using the commercial chromatographic techniques, I have went to find its individual efficacy through docking analysis. So first I have prepared ligand such as sigmosterol, camphosterol, beta-cytosterol, including its control. I have retrieved its 3D structure from PubChem, and the receptor preparation. I have done homology model of ACE receptor, and I have stored in PDB format. So I have counter-checked with the Ramachandran plot. I found it is favorable. Next, these are the results after molecular docking analysis. If you see the tabular column, it will be very clear. So it has a very good binding efficacy and a very good binding energy. So conclusion, it is concluded that phytosterol has synergetic or individual existence, has the ability to perform a significant role in the control of mosquito larvae. In future, this can be applied in field trials for the complete examination of the next advanced level of research. These are all the 2 relevant publications I have done related to large scale activity. These are the paper references. Thank you.
Thank you, ma'am, so much for very good presentation. Like, for example, now you have a seaweed compound. So how will apply in the field?
Field, sir.
Hmm.
Like mosquito
For
sprayer.
example, most of the time, the mosquito coming from sewage water, right?
Sprayers, and the madri use panla, sir. Sprayers, the drug will be formulated in the form of sprayers, and we can give like that.
You can spray.
Yes, sir.
Is it will work in
Yes,
that,
sir. அப்படிதான் நம்ம வந்து chemical compounds எல்லாம் நம்ம வந்து
mostly we are doing in the lab.
Yes,
but,
sir.
if you this reality that sewage water completely different.
They have found out
thicker, like, so many different forms.
yes, already they have found out from the ponnim, sir. அது பேரு Pongamia gabrella and Acidirecta indica neem. இத வச்சு ரெண்டும் mix பண்ணி கண்டுபிடிச்சிருக்காங்க, and they have applied in the field trials already.
Okay.
Thank you, sir. Thank you.
So any questions? Yeah, please. Yeah.
Ma'am, you have done homology modeling, right?
Yes.
So have you used any software for doing homology modeling?
Yes, ma'am. Swiss modeling I have used.
Swiss modeling,
Yes,
yes. And ma'am, for docking, which software have you used?
Swiss docking, ma'am.
Swiss docking.
Online docking.
Oh, thank you.
Thank you.
Okay, so really we enjoyed today's presentation. Okay, so it's a wonderful day. We had a lot of information, and thank you all of you for wonderful cooperation and useful information. And thank you on and off. Okay, thank you. Have a very good rest of the day. Okay.